go ahead and start with anything you like.
Thank you. What? Okay, good morning, everyone. Thank you for making it to the fourth day, 9:30 a.m. session. This is a new title for this early stages project, so any feedback is truly appreciated and any ideas we'll take on board and work on. This is joint work with Ricardo, the Seeds of Influence, Political Economy of Brazil Soy Boom. And this, as you'll see, will connect quite well with Alan Xiao's talk yesterday on the political economy of conservation. This is another angle, a complementary angle to the story. So here's some motivating starting facts. If you look on the left, this is Brazil's, in blue, soy production going up enormously over time, especially starting in the late 90s, early 2000s. Compared to the US production, just for reference, Brazil became the largest soy producer and exporter in the world. On the right-hand side, it's a simultaneous graph starting in 1998 of the percentage of seats of people in Congress affiliated with the agribusiness lobby, agribusiness caucus officially. It's become the largest caucus in Congress, and I'll show you some more stories and evidence of their actions. Basically, this is a protest in front of Congress. This is our Congress behind tractors in the 90s, a picture. This is a more recent event in 2012 when the group is organized in Congress, happily celebrating having voted a new forestry law that pardoned past deforestation. And it was a key point in the weakening of enforcement legislations in Brazil. The group is constantly associated with pushing for weakening rules against land encroachment, opposing environmental legislation in general, and also advocating for more resources, more subsidies from the government for agriculture.
Just to clarify, when you say they're affiliated with agribusiness, does it mean it's their job or like it's a party or?
It's not a party, it's across parties. It's mostly right-wing correlated, and it's an official caucus in Congress. There's others. This one is agribusiness related. Just to show how organized they are, and to start us off, there's two narratives that will be informing the rest of this talk. One is you can think of the agribusiness lobby arising endogenously from farmer demand for policy influence in order to remove barriers for growth, which would have led simultaneously to the growth of soy production and wealth. This would have enabled agricultural dynamism. Another narrative would be that the agribusiness lobby grew from sectoral wealth and power. It would have boomed anyway. So the influence enables political capture. Now they have enough money to fund this group, fund campaign donations, etc. I'll be discussing both of these. There's empirical challenges in studying how a political group consolidates and rises. One is that economics and politics co-evolve at a macro scale. The second is there's usually not enough data availability at the micro level, especially in developing countries, so that you can track and map activities. So this motivates my study in Brazil. You've probably heard enough of Brazilian data in the Brazil setting by now, but just as a reminder, Brazil experienced this large agricultural boom in recent decades. It could serve potentially as a model for other countries, especially in sub-Saharan Africa, as the search for productivity growth continues. And Brazil has enormous interesting environmental implications. It's home to the largest tropical forest, and it's also the country with the heaviest use of agricultural chemicals, etc. It's extremely relevant. We'll introduce new microdata here to help isolate causality, as I'll make clearer later. And we think this case informs two larger questions. One in politics, basically studying how special interest groups endogenously form and consolidate. The second in environmental economics, that this type of political consolidation is a new channel explaining the development conservation trade-off. If as countries grow, as agriculture becomes more productive, groups endogenously gain power and start pushing back against legislation with environmental externalities and consequences. So what are the three specific research questions we'll be asking so far? The first is, did the Brazil soy boom favor large landholders? Did it increase their participation in all levels of politics, both as candidates and campaign donors? Does that influence amplify soy adoption and the allocation of resources, indeed, beyond potentially what the fundamentals would predict? And third, which is even more work in progress, as you'll see, is how does individual behavior aggregate up to this rise of special interest group? Are there collective action problems? This is what we want to dig in further.
Can I just clarify, sorry, on the motivation there? So the two narratives that you put up at the beginning, they're both potentially consistent. Is an aim to distinguish there, or the answers here will be informative about the?
We'll try. I'll show you one exercise where we zoom in and maybe give me a few more slides. Yeah. They can definitely be consistent and be happening the same with different parts of the distribution. In terms of the contribution to literature, very quickly, this is positioned at the intersection of three large literatures that I don't attempt to summarize, but just give a few examples from more recent work on the political economy of tropical deforestation, a large literature on special interests and money in politics more generally, and an immense literature on structural transformation. I'm only bringing a few examples. Paula Bustos and others will be the most relevant paper studying structural transformation in Brazil, the soy boom, etc. So our goal is to microfound and endogenize a special group formation from property level shocks. And incentives, as I'll show in a minute. So here's one more slide on the setting quickly. As I already mentioned, Brazil experienced huge gains in productivity since the 90s. It expanded by essentially technology advances led by Embrapa, this public services company that does technological innovation. That Jacob Moscona was here. They have a recent paper exactly studying this, just came out last week. We'll be exploiting one key event in 2003 where GM soy was legalized in Brazil in 2003 that has been studied before, that allowed for larger productivity, soy being used and produced in areas that it wasn't before, because now farmers could use more glyphosate and chemicals to expand. So this will be a key event for us. And as I already mentioned, this group has simultaneously gotten more powerful. Okay, here's two slides on the model we write for the paper without math, just to bring some intuition. It's a model of quid pro quo politics under changing agricultural technology based on Grossman and Helpman. The main elements will be, main actors will be landholders, politicians. Landholders want to maximize profits. Politicians maximize a weighted sum of campaign donations and a policy deviation utility from their bliss point. It's a simple timing where landholders observe politicians' preferences. They choose a donation schedule, which is essentially a promise of, if you choose policy X, I'll donate Y. If you choose one or two, I'll donate something else. Politicians observe that, choose specific policies, and then we'll be modeling, choosing how much deforestation is enforced, what's the expected fine for deforesting, and subsidies that would alleviate a fixed cost that farmers need to pay in order to enter this new soy sector. Yeah, Jeanne.
Do companies like Monsanto come into this that are?
Not in our framework much, but they're definitely this type of big company with bundle contracts and access to seeds, etc., is common in the Amazon. Yeah. And finally, landholders choose land use shares in the end. And the interesting change is that there's two periods, one where soy isn't available and farmers can only choose how much land to use for pasture. And of course, this is a simplified version of the world where we're modeling the soy entry. The other is when GM soy becomes available, farmers can produce it, it enters their choice set. It has higher returns than pasture, increasing returns to scale, but it depends on farm suitability and it depends on an entry cost for buying a truck. looks like this. So the model has some key predictions that we'll take to the data. One is when GM soy becomes available, we expect increases in donations, potential increases in landholders entering politics directly. We would observe an increase in rural credit and potentially more deforestation and more soy adoption. We will link this to some detailed empirics that I'll skip now and discuss in the next slide. Yes, question.
On the increased donations, if you're of land that's already dedicated to soy, and then the productivity of that goes up, I guess I would have also thought they might get the other prediction that I don't actually want to lobby to deforest more because my incentives are like I'm actually having a higher profits for the land I already have.
Right.
So is there predictions that are differential, but based on like whether the land's already been cleared or not?
Yes, in the model, we do have a state variable that's how much land was already deforested, but in the data, in this, we can get there, but I would want to contract or a separate subset for places that have still forest available and land available for soy versus not. Thanks. Question in the back.
Can you just briefly give an idea, are there any opposition parties to agribusiness? I know in Mexico, there's been like an organized political resistance to banning these seeds or things like that. Is that important here?
There is a, let's call natural conservation coalition in Brazil that's very small and tries to push back. It's scattered geographically. This is much stronger and has been much stronger for a long time and more organized and more confident.
Some like market access or proximity to trade matter for both
It
the
does,
soy
yeah.
adoption and
Yeah.
also political activity.
Yeah, and we have the data
Oh,
in the empirics. Yes,
How should I think about I'm just trying to think about alternative land use, and you mentioned pasture, but is there a lobby group associated with cattle ranching, which presumably has different incentives here? How do they feature in your model?
that's a great question. It's my very last point. This group, just to briefly say it now, this group is both associated with pushback for, well, pushing for soy and cattle activities. We're focusing on soy now because it's a more lucrative activity and where we have some clear variation, but we have some ideas on how to exploit more the cattle side of the story. Here, a summary of our empirics, and let me just spend a minute on the data because we have a key new data set that unlocks many new interesting questions and that relates to Alan's talk yesterday. Now, we have access to this new georeference data set at the property level for 3 states, just on the southeast end of the Amazon, where not only we have the shape files for all farms, all properties, but we also have the names and IDs of the owners in the top, which then allows us to link this to a host of other data sets that Brazil has available, such as the Mapiomas data on 30 by 30 pixel level land use transitions, the FAO and GAIAs that has been widely used data on agronomic potential, to the universe of electoral results for candidates and all campaign donations at the micro level with names, so we can observe what owner or what farm donates to whom, etc. And also new data on the universe of individual rural credit loans that we'll use as well. And we're building more and more into the panel, but just to give a sense that this is a quite rich and detailed data set. So this is where we start from, and quickly some summary statistics, because this is still where you work and we're still trying to understand the data ourselves. We have more or less 300,000 properties in the data, about 370,000 unique owners. If you plot, for example, in our data, the first year of a soy adoption, defining soy adoption by at least 1 hectare of soy available in your property, you get variation like this. It starts in the south, in Mato Grosso, the state that eventually became the soy powerhouse in Brazil, but there's lots of variation over time that we're still trying to understand and explore more. If you put this in regression form, you find some intuitive results, such as The more your property has soil suitable for soy, the earlier you adopt. So a negative here is years, smaller years. So you adopt earlier. If you have more market access in 1990, you also adopt earlier. This is at the municipality level, we're working to produce market access data at the farm level, which will be a nice contribution as well. So it follows the intuitions we would have on the economics of adoption to some extent. To answer our research questions, we start from a challenge of how to create an exogenous measure of access to improved soil technologies. The path we chose to follow for now is Paula Bustos, Jacopo Ponticelli's work, who studied the same shock, what they call the soy shock, where they defined the shock as the suitability for soy under high inputs minus the suitability under low inputs, essentially capturing the suitability before GM soy versus suitability after GM soy, times a post-2003 indicator at the municipality level. The variation behind it is essentially these two maps plotting suitability under low inputs, or understood as before GM soy versus high inputs. And the variation is coming from places that before were orange or dark orange and turned green, specifically this part of the Amazon, but also others here inside. What we do, yes, question.
Why this shock can be thought of as an exogenous measure?
The entry of GM soy, you say?
Or like this soy shock treatment, you're saying that you want something exogenous. Why is this soy shock? Why is it exogenous? Just some intuition for it.
Sure. Not the difference in suitability. Those are observed before and available. But the fact that it was legalized was a key discrete shock that there was some adoption before by farmers in the south of Brazil, but legalization is the key moment where it's supposedly it starts being adopted more widely.
Thank you.
So, yeah.
If I can help him, like this was a technology developed by Monsanto in the US in the late 90s. So it wasn't feasible to produce on the left-hand side. And then something developed in the US, made feasible to develop on the right-hand side. And they started adopting legally. In 2003 was legalized. So the cross-section, I think it's exogenous because it was something developed abroad that wasn't available before.
But this kind of goes back to my point before is, so Monsanto's bringing this technology in, but there's also things going on in the US that is shifting production towards Brazil to produce soy for China, right? And so I don't know whether that factors in here or not, but
To the extent that it's a market level shock, we'll be controlling for it with our time fixed effects, et cetera. Yeah, this will be variation across levels of suitability growth, but let me get there in two slides. So anyway, they did it at the municipality level. Now we're zooming into the property level with this new data in the following standard simple regression, where we'll be looking at outcomes such as running for office, making a donation, having access to credit, et cetera. And with the individual fixed effects, municipality time fixed effects, and we're interested in this beta showing the effect of having access to soy times how feasible, productive, the amount of suitability gain you had before and after. Okay, this is the setting, and here's the first results in 10 minutes. And we're still trying to work through it and understand it, so please have any ideas, do let me know. So first of all, just the average effect, we're actually finding null, and that's relatively precise. If you interact the suitability growth imposed with the size of the property for each person, we find that it still doesn't explain running for office directly, but it helps explain donating, which is consistent with a simple story of if you have a larger farm, you tend to benefit more from soy and become wealthier. The opportunity cost of running is higher, so you prefer to donate and help build a group. So on average, this is the average coefficient over time in event study form. So take what you will, we're working to understand, it's still a zero here, but other outcomes where we start opening up, not just donating to any politician, but you might ask, who do they donate to? And following my story, there would be some evidence of donating to specifically landowners and other signaling being in this caucus. We find some statistical evidence, some statistical significance for having donated to a landowner specifically, and not necessarily to right-wing candidates or other definitions of agriculture-related candidates. If you open this up again, interacting with how big of a farmer you are, we continue finding similar evidence of those effects being stronger for larger farmers. If you plot their access to credit, and here I'm showing public loans, it's more noisy. There's some effects a couple of years after legalization where they start getting access to more credit. Something we haven't explored at all yet is the data shows exactly the purpose of each loan, whether it's for cattle, or agriculture, whether it's to buy capital or other types of expenditure, etc. We still need to unpack this more. Many of these results were coming out literally 2 days ago. This is here. The model predicts a specific timing of events where the landowners would first donate, then get access to rural credit, adoption of soy, etc., through this incentives channel. So here is a simple test where instead of comparing decisions before and after legalization, we do something slightly different, which is comparing soy adoption before and after a donation to a winning candidate to try to really tease out the timing, and connecting to Claire's question before. And here's what we find in a much clearer image of just plotting soy adoption in percentage point terms, looking at pre-post the election of the specific person you donated to, either a mayor or any federal office. It can be a senator, a congressperson, etc. We find a clearer picture. We're still also working on the results on credit and other things, and on subsidies. So this looks cleaner. And what is work in progress, and here I would benefit from your ideas, is the third part of our research program here of the collective consequences. How does the special interest group consolidate? How do these individual decisions aggregate up? So for example, we can study how members of Congress vote differently after their individual rising donations from this group, where you can compare the same person over time as the share of their received donations from landowners grows. We're very interested in a collective action problem. Yeah, thank you. Where maybe smaller landholders free ride on the larger landholders' donations. What about land inequality? Does it make this coordination easier or harder? Who takes the lead? Because we have the identified information, we can really make progress on this. And what we're also working on is the financial resources part, where these farmers could be pressuring and pushing for reallocation of funds towards municipalities for agriculture beyond what potentially land suitability and other fundamentals would predict. This is all work in progress for now. So let me conclude, and if I have time, I'll advertise something in the end for 1 minute. For now, we're working on endogenizing the rise of a special interest group with a simple model, new identified micro data. What we hope to arrive at the end, some key takeaways that are potentially interesting for other countries, such as sub-Saharan, in places in sub-Saharan Africa that arguably have too many small farms and have witnessed a decade-long push for more productivity. The Brazilian case with this gain in productivity could be a case study for a rise of a political group that could eventually start pushing back against legislation for natural conservation, etc. This could happen potentially in other countries as well. And finally, as I've already said a few times, there's still a lot to do, but a key dimension we haven't explored yet is this other side of the agribusiness, which is cattle, that is more closely linked to deforestation at the margin, where the frontier is being pushed. It's not with soy, it's with cattle. And there's interesting data on, for example, the openings and closures of slaughterhouses that can also be used as a shock to the different returns of cattle, like ranching. There's good data on cattle sales at the farm level, where you can map the whole network of who sells to whom, etc. I think there's still interesting questions and a lot to do here. Okay, thank you. I'll take some questions and have one more slide. Yeah.
So, I mean, on this sort of, on the political activity regressions there, you're comparing non-soy to soy areas, right? So, I mean, I would imagine one thing that might explain why you're not seeing much of a difference is if the non-soy areas are still become dependent somehow on the soy production, due to other kinds of sectors or linkages or processing or something, or trade or something. And so then, this coalition, I guess, is broader. The pro-soy coalition is broader than just these soy production areas. And I'm wondering, I guess, if there's some, there's a measure of soy exposure you could think of about where the soy goes, or sort of some broader market access or market exposure type variable, you could maybe try to glean that out. How much of this might just be that there's a bigger group here that's dependent or becomes dependent on this industry?
Let me think about it.
Yeah.
And maybe ask you later.
And just following up on that, how much of the soy lobby is kind of just weakening general deforestation?
Can you repeat, please?
I think I've just thought it out in my head, but I was wondering, if it's just pushing for more deforestation, would you not expect everywhere to benefit from that, whether you're going to grow soy or not? Or is the idea that if you're more profitable under soy, you're going to push for it more?
Well, I think this is exactly what we're still trying to unpack, because this lobby happens at multiple levels, at the local and federal. Successes at the federal level do impact the whole country, on, for example, pardoning pest deforestation in 2012 and other things that weakens enforcement in general. Others happens at the local level, where they can push Congress people to send amendments and to send local municipalities finances for agriculture, etc., which would impact the economy only more locally. So it can go, I think, always. Yes, Chris.
So just one, sorry, Kevin, late, but you're using the Bustos GM soy suitability thing.
Yeah.
So the idea is that suddenly the value of your land that's suitable for soy goes up.
The variation is exactly for farms where the value went up the most because they gained the most in suitability, where previously soy wasn't profitable, and now it is, because they can use more different types of seed and larger scale tractors.
But do you know anything about the nature of the donation, or you just know the amount of money? Why they were donating money?
Well, the why, I think, is the job of the econometrician to infer, but there's some information about it, such as amounts, who exactly goes to, some information on the donor that we don't have from other data sets.
Have you used, in terms of the candidate, have you used the characteristics of the candidate to figure out whether they're donating to specific types of candidates?
Yeah. This I showed a couple slides ago. Oops. Here, so you can classify candidates in many ways, and we do a first view on whether they're right wing, whether they are landowners themselves, whether they self-declare being farmers, etc. I think there's still a lot more we can do. I think, can I go to Chris? We're done? Okay. Sorry. Thank you.
Hello, everybody. So my name is Kelsey Larson. I'm an assistant professor at Indiana State University, and I'm presenting today on my work on selection and conservation easement tax incentives. So I don't need to tell this room very much about how there are current enormous concerns around how we protect biodiversity going forward, and widespread consensus that to protect biodiversity, we need a lot of conservation. Now, one innovative tool to help with this conservation problem is looking for ways that we can help protect environmental values, not just on publicly owned national parks, state parks, etc., but also looking for ways to protect environmental value on privately owned land. One mechanism that a few locations have started using for this is to allow private landowners to place oftentimes either long-term or even permanent conservation restrictions on the land that they own. So in the UK, this has recently been legalized through the Conservation Covenant Law in 2021. France created an environmental obligation system in 2016. And America is the country that has really gone all in on this strategy. These conservation easements were first legalized in the 1960s, and they now protect more than 60 million acres of land, and are subsidized with $3 billion a year in tax breaks, which is about the size as the pre-2025 National Park Services budget. No updates on this year. So there is an advantage to this particular style of conservation, which in large part is its cost. An easement can protect a parcel at a much lower cost than purchasing the parcel outright for adding it to a public park or something like that. So basically, an easement is going to be narrowly constructed to only restrict specific activities that could harm the parcel's conservation value. So you might be allowed to have it to some degree in agriculture, but you're required to keep a buffer of grassland around the borders of any body of water. And you're not allowed to, say, turn it into an apartment complex. Or you might be able to keep a single home on a forested parcel and do some light timber extraction there as long as you keep it as a forest. So in this, landowners then receive incentives that are typically tied to the development value of their easement donation, where the development value is going to be the gap between what the sales price of this parcel would be without any restrictions and what it would be with the easement restrictions. So if a parcel could be sold for $1 million without any easement restrictions and about $800,000 with the easement, then that landowner just made a $200,000 charitable donation by giving up this development right. And so the landowner can claim certain charitable donation incentives and property tax reductions that are based on that amount. So there is a trade-off here, and it is that the government gives up most control over which parcels end up protected. So in order to claim these easement tax incentives, these voluntary private donors just need to meet two requirements. The first is that they need to find a land trust that is willing to accept their donation. And with that comes a certain amount of responsibility to help enforce essentially the restrictions on the land. And these land trusts are either NGOs or government organizations. The second requirement they need to make is that they need to be able to tell the IRS with a straight face that they are protecting some environmental value, historical value, or open space value. What this tends to mean in practice is that your land needs to be largely undeveloped in order to use it. So the potential quality variation we could get in land from this matters because ecosystem services are highly variable across space. Even within the same region, some researchers who have tried to put a dollar value on ecosystem services have found it may vary by 100 times across different ecosystem types, say between very valuable wetlands and maybe grasslands on the other end of that spectrum. And even within the same ecosystem type, in the Chesapeake watershed, certain banks provide 4 times higher water quality and water management services than other riverbanks in the same area because of their location relative to natural areas and human settlements. And overall, there's been very little research into the quality of land that is placed under easement. So I want to explore a few questions in this project. First, how environmentally valuable is the land that ends up protected by private easements? Second, how does the quality of that land donated change when the subsidy rate for donation changes? Can we attract better land by giving more money, or do we end up a little bit worse off? In addition, what factors might drive this relationship? And what easement policies could help more efficiently produce environmental value? So in this paper, I focus on Virginia, which is a state with some of the largest conservation easement incentives in the US. And I'm going to measure the environmental value of land using the Virginia Department of Conservation and Recreation's own map of conservation priorities. So hopefully I'm getting into something that really approximates the function that the policymakers in Virginia have said they would like to optimize through their conservation policies. And I'm going to compare easement lands to both the broader population of unconserved, undeveloped land in the state of Virginia and to publicly owned conservation lands to get an idea of how this is performing. Then to get an idea of how the marginal rate matters, I'm going to use a difference in difference design around a 2002 reform that differentially changed the donation subsidy depending on a land's development value and the donor's income. So I'm going to use my results from that to build a model of easement supply and basically estimate the amount and quality of land that would be placed under conservation if we had a different structure of easement incentives. So what I find, oh yeah.
I was wondering, it seems like selection into this is going to depend a lot on how this gap is determined by the IRS between developed and undeveloped value. Are you going to tell us about that, or?
Yes, absolutely. I will talk about that a little bit further. But basically it's done through a very similar process through how the government assesses standard property taxes in the US, where they will have an assessor who uses somewhat nationally standardized processes to go out and say, this land would be worth about this much on the market, this land would be worth that much. So what I end up finding here, first of all, is that conservation easements have a very wide distribution of quality. There's some good places, there's some less good places, that ends up looking more like a random selection of the entire quality distribution of statewide unconserved lands than having any systematic difference there. So it seems like there's a lot of room for easement policy to do better targeting. Second, I find that the marginal easements attracted by changes in the policy have fairly similar and possibly lower environmental quality. And in particular, they're less likely to be part of some of the prime agricultural areas. And the correlation between high environmental value and low development value seems to explain some of this effect, that increasing the subsidy rate brings in more high development value areas. In Virginia, those tend to be sort of the high development value is closer to cities, maybe more marginal land, whereas a lot of the high environmental value stuff is further away from those population concentrations. And I find that differences in donation screening across land trusts doesn't really seem to be responsible for this. So we couldn't fix the problem by, say, just kicking a few problem land trusts out of the process. And then after I apply some of my counterfactuals to this, I find that a same cost policy that had targeted some of these large incentives strictly at high quality land would be able to attract about 20% more high quality land than the current policy at a cost of about 1.2 low quality acres per high quality acre. Yes.
Do you have a sense if this land that's ended up being in the easement would have been developed otherwise? Like, is the easement basically being any effective?
Yeah, so the overall rate of land development in Virginia in this time period was something around I think it was 2% of Virginia's land was developed between 2006 and 2016. And so in this period, there's not a ton of additionality happening. But an important thing with these conservation easements is that they are in perpetuity forever going forward, barring a few very exceptional possibilities. And I do at least find that these easements are effectively, there's no development happening on them. So probably the additionality during this time period is fairly low. But given that this is such a long-term conservation policy, I think quality of the land that's being conserved probably ends up mattering a bit more than the shorter-term additionality in this setting.
Is it voluntary, if you're a landowner, whether you come into the easement thing?
Yes, absolutely.
So do you have, I mean, what can you say about that selection process? People decide, I mean, presumably they're putting lower quality, high environmental value potentially in retaining the stuff that might be developed.
Yes, so if you put, let's say I'm a landowner who owns 5 parcels that are near each other. This is actually one thing that is dealt with fairly well by the policy, I think. I'm required to disclose to the evaluator that I own all of those 5 contiguous parcels. And they will take into account that, say, if I'm preserving development rights for all these other areas, but I'm protecting this one patch, that might actually make the other parcels more valuable. And then they will take down the assessed value of the donation I'm making. Because they're saying, well, essentially what you're giving up here, you're gaining in everywhere around here, knowing that it's going to have this perpetual open space. All right, so there's a few different strands of the literature that I build off of here. One of them is a number of economists have looked at the impact of these tax incentives on land conservation. And they found a piece of good news, which is that landowners really are responsive to the subsidy rate. With elasticities as high as Parker and Thurman's estimate, which I think is the best in this space, of about -3. The more you lower the price of donating these easements, the more land gets put under conservation. However, here, since I find that this land is of mixed quality and it seems to get a little lower the higher we push the subsidy rate, my work might suggest a slightly lower optimal subsidy rate for easements than some of the pure elasticity work might suggest. Second, I speak to this broader literature that's been building on the quality of voluntary conservation. So a range of papers have found that there's sort of mixed values of these different conservation actions that we ask people to take, both in the US and the world, both in terms of the quality of the land and the environmental value per tree protected, for example, and also in terms of the marginal additionality. Now, additionality tends to be a case of adverse selection. We get the least additional places first, and then it gets a little better if we start offering larger subsidies or incentives. Quality, at least in the case of Virginia, is sort of the opposite of that. We get some of the higher quality donations for easements when it's purely a charitable action, and then the more heavily we start subsidizing it, the more we get some of these more marginal lands. And finally, I speak a bit to the literature on optimal donation incentives. Like with easements, charitable donations are fairly elastic to how much we subsidize them. However, some more recent contributions to that literature have noted that sometimes the charitable donations people make are somewhat inefficient. Maybe they're giving it to NGOs who then spend a large share of their budget soliciting further donations. Maybe they are spending this money in ways that don't translate as nicely to, say, water quality policy as government spending would do. So with easements, more broadly, are a solution to a kind of problem that pops up in a range of areas across conservation, where we can more easily value the costs that someone incurred than we can figure out the benefits that are created. It's very difficult, especially with biodiversity, to put a dollar sign on what the land is worth. However, it's a little bit easier maybe to rank places that are extremely valuable in this versus less valuable. Just can't easily make that dollar sign. So frequently, we end up falling back on this sort of common solution of reducing the quality problem to a binary eligibility threshold. And then we say, well, if you meet that eligibility threshold, we'll pay a share of estimated costs. The real challenge here is that this leaves room for basically paying too much for actions that don't create a lot of value because of low quality, and we might pay too little for conservation in places we would really like conserved. So here, one policy solution I offer is introducing at least a few more of these quality thresholds to say go between a low incentive level and a high incentive level so that we can, and generally this is going to decrease the amount of quantity that we can get for the same budget. We're giving up a few cheap acres, but we might be able to get higher quality out of that. And at least in this setting, that trade-off is worthwhile. So first, I'm going to discuss a bit more about, yes?
Just to clarify, when you said that the firm needs to go to the IRS and say this has value, so the assessment is completely discretionary. Is there any idiosyncratic variation, like who is deciding?
In terms of like the documentation you need to send,
No, like whether this is applicable, whether they approve it.
So you don't actually formally need to get IRS approval beforehand. You just can get an audit and in trouble from the IRS if they look at your documentation and don't like it afterwards.
So there's no screening at all, other than the part of the license.
Yes, I will say the Virginia process did institute a bit of screening. That when they created these large state tax incentives, they wanted to prevent the fraud that has happened in some other states and is less of a problem in my setting. Because they created a board that one checks that you do meet the IRS definition for having some environmental value protected. And two, they have a panel of real estate experts who double check the valuation documents you turn in that say what that dollar amount should be of your development value that you should get tax credits based on. So a little bit of proactive checking that you're at least hitting this minimal bar. So first off, I'll discuss a bit about this setting and some of the facts I find about the quality distribution of land. So as I mentioned, Virginia is one of the largest easement tax incentives in the country. There's, I think, 15 states now that have their own incentives. And basically, they gave tax credits that were equal to 50% of a parcel's development value that you could claim over up to 10 years. And these credits let you reduce tax bills 1 for 1. So if the Virginia IRS said, you owe me $10,000 this year, and I had 10,000 of these credits, now I'm not paying a cent in tax. But these credits could reduce it down to 0, not below 0. And in this, as I mentioned, they included some measures to prevent fraudulent overvaluations. If you're trying to claim too much of this tax, you do have to go through a panel to get that approved. So I'm going to focus my studying on these easements recorded by the National Conservation Easement Database, which estimates that they have data on 98% of Virginia easements. And I'm focusing on the 2,400 that were donated between 1999, when this policy started, and 2006, when some other federal tax changes happened. And from 2000 onwards, these easements have represented the bulk of Virginia's natural conservation spending. So the key outcome data that I use is the VANLA assessment from the Virginia Department of Conservation and Recreation. So basically, the state wanted to understand where are our state's natural resources, are we protecting them, and create something that they could use on an ongoing basis to evaluate lands for conservation. So basically, every single acre in the whole state of Virginia gets a score from 1 to 5 on all of these different variables, where 5 is something that is of outstanding valuable, 4 and 3 are very high and high respectively, 2 is moderate, and 1 is the generously named general. So I analyze these values individually as the maximum score out of all these variables and as sort of the weighted mean score of the parcel. Yep.
Just when we're thinking about parcels, how big are they typically? And is there additional conservation value if it's several parcels like linked together? And is that in here?
Yes, these parcels range in value. I'm not sure of the average acreage off the top of my head, but I would say one that is smaller than 10 acres would be highly unusual. They're usually, I would say, in the triple digits number of acres. And ecological value is influenced by the presence of other conservation in the area. Basically, the ecological biodiversity score prioritizes the core and corridor type system, as they call it, where they're looking for areas where it's going to be connected to lots of other like ecologically intact area that would make it a core, or where it's part of a corridor that it's in an area with a relatively decent amount of green space that is in between two other corridors, two cores, and might facilitate movement of animals and species between them. And they also, in addition to this ecological sort of biodiversity focused measure, they also look for water quality, its value for ongoing forestry and forest health, agricultural value, and recreational value. So, yep.
So how's that agricultural value in the environmental bit? So the land's more valuable if it's suitable for agriculture?
Yes, one of the complicated things about conservation easement policy, I would say, is that it is also used to protect agricultural land, which oftentimes tend to offer some environmental value, and putting an easement on it will both require that it doesn't go from agriculture into full development, and also will ensure that there's certain protections around like any bodies of water that cross through the area and that kind of thing. So this is sort of the policymakers' value function, I think, and it might not always be the same one that we would set as environmental economists. But I will show the results for these categories separately as well. So that's something to keep in mind as we're looking at it. So the first thing I find is that the quality distribution of easements tends to be similar, and in some cases slightly worse, than that of undeveloped, unconserved land. So here I've got a few CDFs. The further to the right, the higher environmental quality this land is in Virginia. So publicly owned conservation is right over here. This is the stuff that might be part of a national park, state park, local government owned, etc. And this stuff consistently is in the very high to outstanding category, a little bit of it in the high to very high, as we'd expect if government is going to invest money in fully purchasing a parcel. And it looks like most of the category 4 to 5 land in Virginia ends up under public conservation. What's a little bit surprising, now we might expect that private conservation would be lower quality than public conservation. That doesn't necessarily mean it's broken, since it's a cheaper form of conservation. But this is the CDF of unconserved land statewide that is also undeveloped. This is the CDF of conservation easement land. So on average, conservation easement land is a little bit lower quality than just average unconserved parcels statewide, which suggests that there's a good amount of this quality, like close to quality 4 land that is not getting conserved, and that we could perhaps better target through the right subsidies. And second, that there's not a ton of targeting happening. I will note that almost all of the land being placed under easement, unless it's specifically categorized for a historical easement, which I'm leaving out of this analysis, is going to be on undeveloped land. So people are successfully meeting this floor requirement that easements are on undeveloped land, but they're not really selecting for quality above that.
And this policy is entirely under the jurisdiction of the state of Virginia?
You get both state and federal tax credits from this.
And does that vary across states?
Yeah, the state policies, yes, states handle this very differently.
Has anybody looked at which works better? I mean, similar to this, but
whether the state or federal tax credits?
The different state policies lead to better outcomes in terms of conservation.
There hasn't been much comparative work, I think, across different state structures and such. It'd be an interesting area definitely to explore.
Are they
further.
mainly these sort of tax benefits or? Are they?
Yes, I would say Virginia takes a very common form of it. And actually has been praised for having better checks on fraudulent valuations than say Georgia or Florida, which I believe Georgia has less than 1% of the nation's land under conservation easement, but takes up more than 30% of the federal tax credits for it every year. And Virginia's is much more sensibly in line with, I would say this is probably fairly typical policy bordering on like would be a policy that a state wanting to emulate, wanting to expand its credits might emulate to avoid the pitfalls of some other
And
states.
are the federal, is the federal, you're just looking at the state policy?
I'm taking the federal policy into account, but I'm using variation in the state policy.
The tax credit, is it on the property rate that is due to be paid on the land or any other tax payable?
So a lot of the variation is in the income tax credit. It can impact property taxes, but since I'm a little short on time, I'm probably gonna have to skim over the construction of it. So this isn't accounted for by different land trust types. There's many different types of organizations that can accept a land trust. And to me, this suggests that there's not a lot of screening going on at the land trust level. However, one thing easements are very heavily used for are for this kind of conservation on agricultural land, both protecting it for ongoing agricultural use and also putting some environmental restrictions in place in areas that have some amount of agriculture, pasture use, but are not fully developed. So with my difference in difference, the main strategy I'm going to use to look at the value of these tax incentives is to compare pre and post 2002 easements that would have faced higher or lower subsidy rates after this 2002 reform. Basically, this reform made tax credits tradable. So some people had previously hit this restriction where you can only use up your tax credits to cover your own tax liability. You can only use them over 10 years. If you have a really high development value parcel or your income is lower, then you're not going to be able to use that up in 10 years. So, okay, we make it tradable. But at the same time, to kind of pay for this and keep it cost neutral, they decreased the claimable share of easement development value from 50% to 40%. So if you were someone who already could use up all those credits yourself, you're not benefiting from tradability. You're bound by this decreasing cap. You get a lower incentive. So basically, this 2002 reform smoothed the incentive rates that different people were going to face. So I'm going to compare folks who got essentially an increase and a decrease in the subsidy level following this this reform. And basically, if I find that folks who would have gotten a larger subsidy incentive are producing better conservation easements after the reform, that suggests that our marginal easement is higher quality than our average one. Whereas if that coefficient's negative, it's lower quality. So first, I find people responded a lot to this development. The number of easements of lower quality brackets shrank. The ones of lower price brackets shrank. The people who were getting an increase in these incentives dramatically increased their donations. And this decreased the average conservation quality that we were getting, but a lot of it came through agricultural priority. The others were fairly flat. And finally, I think of this situation where we do a same cost policy that had as this increase that some of the highest development value brackets received. But what would have happened if we had only given this increase in subsidies to only high priority or only very high priority people and tried to do a policy that would cost the same amount? And when we, the total land, as we add these additional floors, we're not getting this uniform increase. The total land protected declines a bit, but the amount of high or very high conservation priority land we get jumps a lot. And the policy ends up policymaker might prefer a high floor to a uniform floor if a high quality acre is worth 1.3 moderate or general quality acres, which seems very likely given the heterogeneity in values. And they might even prefer the very high floor to the uniform floor if it's worth 1.6 of those general quality acres. So thank you very much.
All right, thanks everyone for being here. I'm very excited to present my job market paper on price regulation of agricultural technology. This is joint work with Felipe, who is a former classmate of mine now at Analysis Group. So low rates of technology adoption in developing countries are a key driver of productivity gaps. And government efforts to close these gaps have mostly focused on promoting the broad diffusion of existing technology. To do this, a remedial policy that is frequently used is price regulation. Price regulation is quite appealing to budget-constrained governments as they try to reduce prices at low budgetary cost. Our paper will explore a potential drawback of regulating prices. Technology providers may adjust to lower profit margins through lower innovation and lower quality provision. So the trade-off we're going to be after in this paper is how governments can ensure the affordability of essential technologies without actually disrupting the supply of innovation. And we study this trade-off in the context of agriculture, where we think it's particularly salient. On the demand side, smallholding farmers are often constrained and struggle to pay for modern technologies. So relying on market prices as the only allocative device for technologies may make this inaccessible to the poor. On the supply side, productivity gains in agriculture have been the result of incremental technological advances. This is because agricultural technologies require adaptation to local geoclimatic conditions. So take the case of genetically modified cotton. This was a technological breakthrough that originated in the US. However, to deploy to non-original contexts like India, you need to adapt it to the local soil and local weather. On top of that, crop varieties also require continuous improvement to adapt to changes in the biological environment. Think about new pests and new pathogens. So in order to keep up with changes in the environment, innovators in agriculture need to keep on innovating and adapting varieties over time. So our research question is, how can price regulation affect both technological diffusion and innovation in equilibrium? And we studied this in the context of the Indian cotton seed market. This is the world's largest producer of cotton, but it kind of levels of productivity are still below the potential frontier globally. Second, India is a very active domestic breeding industry, developing seed varieties that have desirable traits for its local ecologies. For identification, we're going to leverage price controls on genetically modified cotton seeds. These were imposed in 3 states in 2006 and then expanded nationwide in 2015. Since then, there has been a lot of debate about these price controls. On kind of like the supporting side, commenters have pointed out that the high prices of GM crops make these technologies inaccessible to the poor, while opponents of the policy denounce that price controls can deter R&D and so end up being detrimental to the same poor farmers. And this tension is at the heart of a much wider debate. So one example is the pharmaceutical sectors, but if you think about any green technology, we think you face the same trade-off. We want adoption to be fast and widespread, but we also want to maintain incentives for innovators to keep providing new technologies. And so we're gonna combine existing and novel data to quantify the overall equilibrium effects of price controls in technological markets. For the demand side, we use panel surveys of cotton farmers to measure diffusion and related agricultural outcomes. On the supply, we have a proprietary database on seed producing companies. And then we digitized a new data set with the universe of cottonseed varieties introduced to the Indian market and a large set of experimental field trials. So these trials are going to be kind of our main data contribution on the innovation side, as they will give us variation both over space and over time in a direct measure of innovation output. Using this data, we provide novel evidence on the existence of this trade-off between diffusion and innovation. On the demand side, we see that seeds are becoming cheaper, so the policy is reaching farmers. Lower prices accelerate the diffusion of these GM seeds. And we also see that as the cost of cultivating cotton goes down, there is a massive expansion in cotton acreage. Second, we see on the supply side that there are several signs of reduced investment in innovation that results in seeds becoming worse in terms of quality or productivity. Our main result is that agronomic yields of new varieties fell by 30% in price control states as compared to other states. This kind of innovation response, that is the strategic reaction of seed companies, halves the productivity gains from the original genetically modified cotton technology. For all this analysis, we leverage a diff in diff across states. So this will capture relative effects in regulated states as compared to unregulated states. So in the second part of the paper, we develop a structural model of demand and supply for seeds. Compared to the reduced form, this will allow us to quantify the welfare implications of price controls through both price reductions and quality adjustments on the innovation side. We find that price controls increase farmer surplus, and this is especially true among the poor. However, endogenous quality adjustments on the supply side partially offset some of the welfare gains from price regulation. We use this model to think about counterfactual policies, and what we are going to find is that giving firms pull incentives that are tied to the productivity of new varieties increase highest welfare the most on aggregate. So in terms of literature, our paper contributes to a long-standing literature on low technology adoption and productivity gaps. In the context we study, we are going to see that affordability can be an important driver of the diffusion of a new technology. And so these kind of calls for government intervention and suggest that there might be large welfare gains from these interventions. However, market distortions that are introduced through these price interventions seem to curb innovation. And so thinking about the supply side allows us to show some evidence in line with a complementary explanation for productivity gaps. These type of gaps may not only exist because farmers fail to adopt existing technologies, but also because the low incentives to innovate in developing countries limit the provision of improved technologies. Relatedly, there has been growing interest about the role of appropriateness for technology transfers. What we do in this paper is to zoom in on the microeconomic actors who effectively adapt a global technology to local context. And these actors are going to be domestic seed firms that develop seed varieties that are locally adapted for the Indian market. We think that understanding the profit incentives of these intermediary firms is going to be crucial to understand which type of policies, both on the agricultural and innovation side, are best for technological progress and climate adaptation. And finally, our results are also relevant to a more broader literature on price and intellectual property regulation. In this paper, we're going to overcome measurement challenges by using direct measures of both diffusion and innovation output. For identification, we're going to leverage this policy natural experiment and a setting where innovation is incremental, but also highly localized. And so this will allow us to identify strategic responses in innovation output and kind of think about how these responses or how ignoring these responses would lead us to overstate welfare impacts of these policies. So if there is no question, I'm gonna go through the roadmap for the talk. We're gonna cover setting data and reduce form on the main technological outcomes. If there are some minutes at the end, I really hope to tell you something about the structural model that we basically use for welfare and counterfactual policy analysis.
You just explain the innovation bit a bit more, because presumably the patenting and that goes on in much of it outside of India.
Mm-hmm.
So what do you mean by innovation at the state level?
Yes, so we're gonna show that there is one technology. This is developed in the US and is genetically modified corn. However, this technology is not going to be productive unless you adapt it to the local context. And that local adaptation is done by domestic seed firms that have very localized breeding programs. And so it goes down up to the state level or even like some kind of like agroecological area within state.
Right, but then how is that innovation?
So
is that, I mean, so you're saying they put in less effort to adapt the seeds when the prices are lower?
Yeah, and you can think that this is upstream innovation and this downstream innovation, but we believe both are innovation. It's just that this is a global technology that took many years to develop. This is more local technologies that also require innovation effort.
And so just to kind of spell it out, what is the innovation? Let's say we're in Maharashtra.
Yeah. So
what would the local seed companies be doing, which would be described as innovation?
Yeah, it's going to be plant breeding. So they're going to cross different varieties to try to enhance kind of like the characteristics of the offspring. And in that process, they're going to incorporate the genetic trait within their varieties. And this process means running trials, trying to find like good germplasm for the like kind of local Maharashtrian market and testing them and then distribute them.
So if the prices they can achieve are lower, they put less effort.
That's the whole story of the paper, yeah.
You're free to postpone this if you're going to talk about it when you talk about the identification for the reduced form strategy. But if it's so localized, the sort of ability to do this or the incentives to do this, is that something that we might expect to be relevant in the decision about which are the regulated or the unregulated states? How's that decision made across space?
Yeah.
And is that something that we might worry is kind of endogenous to the characteristics that are amenable to innovation or not?
No, yeah, very good question. So here the regulation is going to be at the state level, and it started in Andhra Pradesh, and then other states kind of imposed the same price cap. So it was not coming from the central government. I think what you're saying, and maybe it's something we can think about through the structural model, is that the planner may strategically like kind of regulate different states based on kind of some industrial policy goal. And we haven't really looked at that. We have just kind of taken this state level shock to learn about the diffusion and innovation responses. But there is a scenario in which that is centralized rather than coming from state governments. Don't know if like that addressed or if it was more of an identification question.
Yeah, maybe let's when you discuss the identification, come back to it.
All right, so let's dive into the setting for this paper. We are going to look at India, which is the world's largest producer of cotton, with more than 6 million smallholding farmers scattered across almost the whole country. Cotton areas in India have very different growing conditions. For example, southern and central India are mostly rain-fed when it comes to cotton, while northern cotton is typically irrigated. The types of seasonality and soil and pest environment also vary quite widely across India. And so because of this spatial heterogeneity, cotton varieties require this local innovation and adaptation process. Yields in India have been lagging behind the rest of the world, or at least the world average. You can see that this was true historically. And with the introduction of GM cotton, there was a rapid catch-up with the rest of the world. However, this catch-up kind of stopped a few years after the introduction of price controls. And in the last 10 years, we have seen a downward trend in cotton yields. Now, there are many potential stories behind this productivity slowdown. The one we will focus on today is this kind of like limited development of technologies. So who are the technology developers in this context? And hopefully this also kind of goes back to your question. And first of all, we're gonna be thinking about seed producing companies that are mostly local and medium-sized. They run vertically integrated operations that go from in-house R&D to seed production, processing, and then distribution. Their R&D process consists of plant breeding, which is this crossing of different varieties to improve performance. And these breeding programs are highly localized and tailored to local conditions. The main technological breakthrough in this industry came from the US. And it was the introduction of the BT technology in the 90s. These technologies was developed by Monsanto in the US, and the main kind of benefit is that it incorporates a bacterium known as BT that provides pest resistance across a variety of pests. This was approved by the Indian government in 2002. And the way it works is that Monsanto licenses its own technology to local seed firms for a per packet royalty fee. And then these local firms go on and trying to incorporate their this BT genetic trait into local varieties of cotton. And they will do so across space, and then they will also set the retail price. The BT technology fee was set at 1,100 rupees at a time when a non-BT seed was worth around 500 rupees. And so as a kind of response to this increase in prices and complaints over the cost of these new BT seeds, state governments decided to cut prices in 2006. And so Andhra Pradesh, Maharashtra, and Gujarat imposed a strict cap at 750 rupees. And as a kind of secondary effect of the policy, companies sat down with Monsanto again and renegotiated their licensing contracts. This led to a cut in the royalty fees from 1,100 rupees to 150 rupees that happened everywhere in India. And so let me show you what this meant for prices. You can see in this histogram that there was a large reduction in prices of BT seeds going from gray to the red bar. The reduction is true everywhere in India, and this is due to the cut of the royalty fees on the Monsanto technology. However, if you compare the price control states to the other states, you see that the reduction in prices was much larger in price control states, where all farmers pay at the cap, which was 750 in the first period and 930 for the second generation. In the other states, instead, there is still a significant mass above those caps. And so this right to left variation is going to be our identifying variation for the diff in diff. It will allow us to identify the effects of the state-level price reductions on diffusion and innovation. And then we will use the structural model to think about this reduction going from gray to red that our relative diff in diff will not capture. There was a question there. Sorry for postponing until now.
So how long does it take to change the seed and then, so basically adapt the seed to the local conditions and then diffuse it? Because in the graph you showed basically goes, it increases like right away.
Yeah, so the 2002, when it was approved, Monsanto had a kind of joint venture with a local company, and so they had already been adapting it. So that's why you see this jump. But think about like around 2 years to like breed a new variety.
Okay.
Yeah.
It's just related to that question though. So if in some ways, like after I've already developed the seed, the marginal cost for the firm is really low.
Yes.
So is the story here more that people are not going to innovate? Like they just think the government's gonna do this next time?
So there is a very important feature that is these varieties will decay naturally over time. So it's not enough to develop a good variety and keep selling it. I will show you some results that you're going to lose around 6% of your yields every year. So companies produce a variety, sell it for 5 years, but then they need to come up with new varieties. And so that's where this kind of margin is key.
How small should I think about these breeding companies? I mean, one could imagine if they're vertically integrated, they have operations like Gujarati one could sell to some other states, farmers in another state that have a similar climate. And
there is a mix, some are national. So most of these have a national market and then several breeding programs. So a company could have 6 to 7 programs, one for the north irrigated, one from the north past A and so on. And a few are more localized. And so some really focus on a market, some are national. But there is great variation and we have around 15 companies doing this. Yeah.
A couple of questions to that one. Can you see the seed variety that the farmers are buying and match it to where it was developed? Like, do farmers primarily buy seed that was developed within state?
Yeah.
Okay.
Yeah, so we see like strong like state preference of like farmers buying varieties that were developed by for that state, and there is even a regulatory like kind of rule there that you can't like approve a variety for the north and then sell it in the south. And part of the reason is because it's not going to be as productive in the south.
And then secondly, are you also able to look at the productivity of newly developed varieties of other crops? Because could it just be that these development companies are reallocating effort?
So I would have really wished to do that analysis. We tried to get data. The main constraint was first, there are no other GM crop in India other than cotton. And it was very difficult. I will show you the main data we used to measure innovation output. And it was very difficult to find similar data on other crops. But qualitatively, based on interviews with these companies, they did kind of do that reallocation towards other crops. Yeah. How much time do I have just to kind of think of 8? Okay, so I'm gonna like. So how do we measure diffusion? We're gonna have a small panel of cotton farmers following the same 500 households in 4 states and 4 ways. Importantly, we're gonna have a mix of treated and controlled states so that we can estimate a diff in diff and kind of document reduced form evidence. The main issue is that this data is quite small. So we complemented it with a secondary data set, which is coming from a marketing research company based in India. This will be nationally representative with all the 9 cotton states, and it will measure seed choice with a very high level of data. So we will really see first, variation in seed choice, and second, we will be able to characterize substitution patterns across brands, which is key for estimating the structural model. So going fast on this, I'm just gonna plot event study estimates with 2-way fixed effects, where we compare changes in outcome of interest in states with price controls versus states without price controls. We find that before the policy, there seemed to be kind of evidence of parallel trends in prices. However, after the policy, after the red line, we see a large drop in prices, which is around 40% in price control states as compared to other states.
What's the rationale for the price control?
Was the rationale? So it was mostly political in the sense that there were a lot of grievances about these new seeds coming in and tripling the price. So I think the kind of push for it was mostly political. We think that you can also think about like a second rationale, which is this of technology, like diffusing this new productive technology.
Presumably that's, I mean, in some states, farmers are better organized to force it, so there's gonna be a kind of selection issue, right?
Yeah, so it seems that like you're saying, farmers group pushing for price
Certain
control.
state, yeah.
Yeah, so we feel like at least like we see evidence that before the price controls, it didn't seem that farmers in different states were on different trends. So that kind of, I think, assuaged some of the concern. But this was definitely like a political decision that was quite unexpected at the time. And so we think about this shock as being something that, you know, farmers were not anticipating this to happen. And once it happened, lower prices led to increase in the adoption of BT seeds, which is around 23 percentage points on average, which is 30% compared to kind of the counterfactual mean in those treated states. And so this is our first piece of evidence that affordability can drive diffusion of a new technology. Look at many other agricultural outcomes, which I'm going to skip to show you the results on innovation, but I'm happy to talk more about that later. So for innovation, we are going to hand code the universe of commercially released varieties of BT cotton. This will include seed genetic traits. So think about this as the radical upstream innovation coming from abroad. However, as I mentioned, these BT traits are not productive on their own. You need to incorporate it into hybrid varieties. So we see around 1,000 hybrids being approved since 2000. These are our incremental or downstream innovation that you can think as also local adaptation in India. The main issue with this data is that the approval takes place at the suprastate level, so we can't really estimate a diff in diff and show you causal evidence on this. We'll just show you descriptives that are really in line with a lower product introduction and innovation during this time period. To establish causality, we're gonna digitize the large set of experimental field trials that were part of a national project aimed at testing BT cotton hybrids. We're gonna see around 600 varieties being tested across different states and in different time periods. Think about this as third-party independent evaluation of the regulatory agency and as a measure of agronomic performance that varies both over time and space. So this will allow us to understand how companies are targeting their innovation effort in the aftermath of the policy. So this is just some, do I have more than 5 minutes or?
You have 3 minutes.
3, okay. So we have some descriptive evidence that innovation is going down. And here I'm just showing you that from 2009, 3 years after price controls, there are no new genetic events coming in India. And also the number of hybrids sharply goes down a few years after the policy. Now, as innovation goes down, we also see that farmers use older varieties. And this, I think, answers Dev's question on why can't you just kind of keep selling the same variety as marginal costs are very low. Actually, those varieties are naturally going to lose around 6% of productivity every year. So as an innovator in agriculture, you need to keep updating these varieties over time. And this updating work is done by local domestic firms. So the main question is going to be, how did these domestic seed firms react to the price controls? To do that, we're going to leverage the fact that we see seed varieties being tested across different states. We compare experimental field trials in states with price controls versus states without price controls. And what we see is that yields of new varieties fall around 30%, and these are agronomic yields tested in experimental field station, go down by around 30% in regulated states as compared to unregulated states. And so this is going to be our main piece of evidence in line with the strategic reaction of seed companies to these profitability differentials across space. Now, if I have 1 minute left, I do. I'm going to tell you about the structural model so that maybe later on, if anyone want to talk a bit about it, I can tell you how we work on that. So the main empirical issue is that both prices and quality or agronomic yields are coming down due to the policy. And so to get at the welfare impact of the policy, we need to get at counterfactual choices of farmers under different scenarios. So to get at those counterfactual choices, we first need to get at farmers' preferences, and we're going to do that with a discrete choice model of demand. Second, we also need to understand firms' optimal pricing and quality provision in order to understand how prices and yields are going to adjust in equilibrium. And to do that, we're going to have a supply model with two endogenous product attributes, price and yields. So we're going to estimate that with a BLP-style approach on the demand side and with parametric cost functions that depend on yield on the supply side. And so just to close, these are our findings. Price controls increase farmer surplus, especially for the poor, which are more price sensitive and less likely to adopt BT in the absence of the policy. However, endogenous quality adjustment matter, and so we see that they offset some of the welfare gains. The main alternative policies we consider are going to be subsidies to increase diffusion and innovation. The first are subsidies to farmers. They were great, lower price and prevent yield losses, but they come with a very high fiscal cost for the government. And this potentially explains why state governments that are highly budget constrained went for price controls. Second, giving pull incentives to firms that are tied to seed productivity achieve the highest welfare, but it comes with an equity efficiency trade-off. Governments will have to choose between prioritizing access for the poorest smallholding farmers towards kind of accelerating productivity growth through innovation incentives. That was all. Thank you so much for your comments.
One of the presentations. We'll be having a short break and we'll be back at 11:30.
That was awesome.
Just don't share it on
Sorry.
But because
David,
they,
can you
before they
hear
said
me?
explicitly you shouldn't travel, I didn't wanna violate their guideline on the street.
I can hear you.
We let the farmers decide.
We're trying to develop macro.
I don't know, so I was super excited about the session.
Testing.
Okay, great, yeah. Excellent. Yeah, no, I bet that he was
like
with Zurich earlier this year, so I think they're.
But then why not?
Doing some, Martin's doing some.
Building out the LSE, so.
That's great.
For preservation of the environment.
How was the week?
To help like southern.
Exhausting, there's always a slight tension. Something gonna go wrong and then the visa thing.
Yeah, I got you.
Hi, Anna. Can you hear me? Testing. Testing. Am I coming through, Anna? Okay.
So like, I don't know.
Yeah, it's like Greece is
Indonesia. Like an analogy with
I don't
like
think so.
high
Yeah.
producer.
Hi, David.
Hello.
Hi. And you're sharing your slides, right?
Instead of having that like.
Yes, can you see my slides?
Yes.
Can see when you can hear you now.
Perfect.
Yeah, California.
Europe, I don't get so much money from Europe.
And you hear the room, is that?
It's
already
like
Hanging together sometimes.
Oh, but also, I mean, there's not the agreement between.
I mean, at the moment, there's a lot of background noise, so I see it with the break, but
No, but it's like.
when we start the session, it will be.
Okay, that's perfectly fine. It's gonna be quiet and then when people ask questions, you'll hear fine. Great.
Great.
We'll have another 15 minutes of breaks. So we start at 11:30. We'll have 20 minutes. Can I ask, because I understand the interaction, fine. So I would warn you that you have 5 minutes and 1 minute left. At the front, and please, but I don't see it on the screen. So you can kind of try and work to get the time.
Nobody has soil.
Oh, great. I'm gonna write it.
It's kind of like an old then here, after 2000, whatever. One region has switching. The other one still has no switching.
Maybe it's also, you're always being a bit romantic about the PhD, but. Going home.
Like one.
Maybe my next
No, I appreciate this.
No, and
I'll go back find it. I'll go back find
You will
it.
see.
Kind of Russia thing. They Brexit too late. Steak.
Something.
Europe has been much more huggy and rubbing.
True, because of the security issue. Well, but then the protests in the weekend, right? But is this mostly just like outside, people coming into the city?
I think that.
Going to the airport, I have to go around 6.
Isn't popular.
Very complicated.
paper presentations. We're gonna start with David, who's presenting online. David's gonna present for about 20-25 minutes, and if we can ask questions, leave questions for the end, so we don't not interrupting him on Zoom all the time. And then we're gonna go into the second presentations before we break for lunch. So go ahead, David.
All right, well, I'll start with the typical audio check, make sure I'm coming through.
Yes,
All right,
yes,
good.
yes.
And also, I can hear you in the room. So if you have comments and want to interrupt, please go right ahead. Okay, so thank you very much first to the organizers for putting this paper on the program. I regret that I am not able to be there in person, but I'm very excited to talk about this paper. I brought a prop with me, which, if you can see the camera, so I got my water bottle, which I filled up with tap water in my office building, which is to emphasize that this paper is going to be focusing on drinking water, the stuff that we get from our homes, our tap, at places of work that we drink. Okay, so the paper is called Waterworks: Causes and Consequences of Safe Drinking Water in America. This paper is joint with Dave Kaiser at UMass Amherst, Bosch Mazumder at UC Irvine, Joe Shapiro at Berkeley. I'm David Molitor. So clean drinking water has long been of central concern to public health. John Snow in the 1800s established modern epidemiology when he linked contaminated drinking water to cholera in London. And then in the 1910s, municipal drinking water treatments became widespread throughout the United States. And in 1974, the US Congress established the Safe Drinking Water Act, which was intended to protect the nation's drinking water from harmful contaminants. Okay, but today, clean drinking water remains a major concern. Actually, every US Gallup poll since 1990, Americans have cited clean drinking water as their top environmental concern, and some have raised alarm bells. If you look at federal violations of the Safe Drinking Water Act, this is what happens when it's reported that drinking water has violated one of these standards. Those violations doubled from 1980 to 2015. And now about 10 to 20% of Americans annually drink water that violates these standards. But a big question, of course, is what has caused these violations to double? Is it because pollution is going up, or is it because the standards have been tightened over time? And unfortunately, there has been no comprehensive national data on drinking water pollution concentrations to inform this question. So in this paper, we make a series of contributions. The first is that we compile new and comprehensive data across the US on drinking water pollution concentrations. So these data include over 200 million individual pollution concentration readings on over 1,000 different pollutants. They span 48 states and decades. And we acquired these data through Freedom of Information Act requests and other types of requests directly to states through web scraping. And then we engaged in a large harmonization effort to make all of these data comparable over time. And so one of the outputs of this project is that we will be releasing these data for public use in the hope that it will encourage more research on drinking water. Okay, so then what we do with these data is we do a few different things. The first is to evaluate levels and trends in harmful pollution levels across the US. Kind of related to this question of, violations have been going up. What about pollution concentrations? We actually find a very positive story. We find that harmful pollution has fallen dramatically in the US by more than 60% from 2003 to 2019. So this kind of mirrors other types of improvements in the environment in the US and other developed nations over this time period, with air quality getting better, and also rivers, lakes, and streams becoming cleaner as well. So we find kind of a similar qualitative pattern that pollution in drinking water has been declining dramatically. Okay, then we ask, what is the role of the Safe Drinking Water Act in contributing to these trends? And we look specifically at one component of the Safe Drinking Water Act regulation, which are federally subsidized loans that help fund drinking water infrastructure. So they'll fund treatment plants, treatment facilities, and delivery systems. Okay? And what we find is that loans that are given out as part of the system are very cost effective. They reduce pollution at an implied cost of $30 per person per year to eliminate drinking water violations. And we also find that that these loans reduce mortality for the senior population, adults age 65 and older. And because of the large value of life, we estimate very large benefit to cost ratios on the order of about 20. So this is a similar order of magnitude to benefit cost ratios that have been estimated for the Clean Air Act, which regulates air pollution. This benefit cost ratio is orders of magnitude larger than what has been estimated for the Clean Water Act. So for what's the difference between the Safe Drinking Water Act and the Clean Water Act? So Safe Drinking Water Act is regulating what's in the drinking water systems, the water that we drink. Clean Water Act is regulating wastewater. It's regulating pollution that's in bodies of water. Okay, so that's kind of a brief summary of our results. What's new in this paper? So the first thing that's new is evaluating these trends in drinking water pollution over time. There have been a number of papers that have looked at trends but have focused not on pollution concentrations. Instead, they have focused on rates of violations, which again, violation rates are a function not just of pollution concentrations, but also how tight the regulations are. They also depend on compliance in reporting a violation when it occurs. And binary measures of violations also do not capture changes in pollution concentrations that are happening above or below those thresholds. So that is the first thing that we do that's new. The second thing is that we provide the first ex post estimates of the impact of the Safe Drinking Water Act on pollution concentrations themselves, as well as adult health outcomes. There have been a number of other papers that have looked at the role of safe drinking water. Most of it has focused on the US in earlier decades or other developed or developing nations. A lot of that has focused on also on infant health. By contrast, we're looking at adult health. And the other thing that I think is kind of useful to think about is we're estimating the impacts of a large environmental regulation, Safe Drinking Water Act. There have been similar types of evaluations of other major environmental laws like the Clean Air Act, the Clean Water Act, which again differs from Safe Drinking Water Act in regulating rivers, lakes, and streams, the Environmental Species Act, etc. Okay, the last thing is contributions to discussions about environmental justice. So trying to understand which groups of people are most exposed to harmful pollutants. And one of the things that we do, and I'll show you some results today, are to compare how pollution concentrations differ across different groups by race and also by poverty status. Okay, so just a brief background on US drinking water systems in the US. There's about 150,000 systems that serve 90% of the US population. 150,000, this is distinct drinking water systems. That struck me when I started out on this as just a very, very huge number. There are about 3,000 counties in the US, so that's about 50 different systems per county. So there's many different systems. And what these systems do is they draw water from groundwater sources or surface water, and then they treat them for harmful pollutants. There's lots of different bad things that can end up in the water. Many of these you've probably heard of. Things like microorganisms, that'd be viruses, bacteria. They can cause cholera, dysentery, typhoid fever, very, very bad things. And so one of the ways that you treat for these microorganisms is you filter the water and then you add disinfectants like chlorine. Okay, when you add chlorine to the water and other types of disinfectants, it can interact with organic material like leaves and in the water and result in other types of harmful products called disinfection byproducts or DBPs. It is also organic and inorganic chemicals. So inorganic chemicals are things like lead and arsenic. Organic chemicals, by the way, like we often use the word organic, in typical language to refer to good food. This is organic food, it's good for you. Okay, but organic chemicals are bad for you, and we're talking about pollution. It means there's carbon in the material. This comes through like pesticides, industrial solvents, things that are bad for our health. And then finally, there are radionuclides. These are radioactive particles that typically come from mineral deposits. They can also come from nuclear energy. Okay, so these public water systems treat for these different types of contaminants, and then the Safe Drinking Water Act applies health standards. There are health standards for about 90 different distinct pollutants, and there are a number of concerns about these health standards. The first is that violations are common. Sometimes they persist. A system will be in violation for many years. Enforcement is limited. The other concern is that there's only standards for 90 different pollutants. The U.S. industry, there's over 42,000 chemicals that are recorded as being used in U.S. industry, many of them very harmful for health. There are only standards for 90. So one concern about the Safe Drinking Water Act is that the stick of regulation is somewhat ineffective at getting people to provide clean water. And so in 1996, Congress introduced a carrot, which was to provide subsidized loans to encourage drinking water systems to build out their infrastructure and improve their drinking water treatment. So these are subsidized loans to fund capital aimed at addressing the most serious risks to human health. And these are called waterworks, which is the title of our paper. It's meant to be a pun, both in reference to the type of infrastructure that these loans fund, but also because we find that these loans work at reducing pollution and reducing mortality. Okay, so we collected a bunch of data for this project. The first set of data was data on drinking water pollution concentrations, which we did through requests to each state data scraping. We got, talked a little bit about the data already, over 200 million readings, many thousands of pollutants. There's many ways to analyze these data. So for the purposes of this paper, we focus on a few different categories. In some cases, we look at all pollutants together, where we weight equally across the categories I discussed before. In some cases, we focus on pollutants that have health standards that are regulated directly under the Safe Drinking Water Act. We can also look at pollutants that do not have health standards to see how those are changing over time. There are priority pollutants that the loans that we analyze specifically target. And in some analyses, we simply pull out some important pollutants that often are discussed directly, things like arsenic, lead, nitrates, total coliforms, trihalomethanes, and uranium. Most of our analysis looks at the outcome is the percent of readings that violate health standards, but that's only possible to do when we're looking at pollutants that are directly regulated and have a health standard. So for other analyses, we look at standardized values, which are z-scores of the pollution concentration. We also collected data on these federally subsidized loans that went to different systems. We have all loans that were given out from 2009 to 2019. It's about 9,000 loans representing a total value of $32 billion. And that represents about 13% of all water capital investment that occurred in the US over this period. The typical loan is about $3 million. It's a $3 million project. And the project or the system that the loan is going to, on average, serves 74,000 people. It's useful to think about the timing because I'll be showing you some event studies. From the time a system gets a loan, how long does it take for the project to actually complete? The average construction duration is 2 years. It typically ranges from 1 to 4. We also have a bunch of other data. We have maps for each drinking water system. So when we have a drinking water sample, we know the boundaries of the system and the population it serves. We also have, and this is crucial for our health analysis, we use health data that come from Medicare, that's the US system that serves the adult population age 65 and older. So we have the near universe of adults in that age range, and we have their 9-digit zip code of residence, which is a very precise measure of where they live that allows us to link them precisely to these drinking water systems. And I'll just emphasize here, this is one of the values of having precise geography, since there's about 50 different, on average, 50 different drinking water systems in each county. If you just have county level health records, that's a kind of a great degree of aggregation. You're averaging over many, many different systems. It's much more precise when you can link people directly to the system that serves their home. Okay. All right, so let me start with show you our main results. Okay, the first main result is about pollution concentrations. How do they vary across the United States? So this is a map showing, on average, across our major categories of pollutants, what share of water violates standards. And you can see that there's a decent amount of regional variation in the share of water that violates standards. What I want to note about this map overall is that if you look in some of the US major cities, places like Chicago in northeastern Illinois, or Los Angeles in California, those places have relatively low pollution concentrations in their water. This is in contrast to what we often think about with air pollution, where air pollution tends to be highest in urban areas. Here we actually see that, that drinking water pollution concentrations tend to be low in the most populated areas. If we look at specific pollutants, those are shown in the maps to the right, things like arsenic. This is a nice sanity check, the quality of the data. So arsenic deposits tend to be high in the western part of the United States, where we know that there are arsenic concentrations are high in the west, where there are known arsenic deposits. Nitrates tend to be relatively high in agriculture areas like Central California and the Midwest, where there's a lot of fertilizer used. And finally, disinfection byproducts, which those recall occur when you have an interaction between disinfecting agents and organic material. Those tend to be highest east of the 100th meridian, so the eastern part of the US, where rainfall levels are higher. We can also look at how pollution levels differ according to the characteristics of the population served by the systems. And one of the things we find is that if you look by race, for example, pollution concentrations are actually lower on average in places that have an above median share of Black population. If you simultaneously control for the population of the service area and race, that kind of difference between Black and other areas goes to zero, because the very persistent finding is that large, highly densely populated areas tend to have low drinking water pollution concentrations, probably because there's returns to scale to treating drinking water. Another interesting thing to look at is the share of the population that is poor. Regions that have an above median share of the poor tend to have elevated pollution concentrations in their drinking water. Okay. Here's what's one of our main findings about trends in pollution. We look at the share of drinking water pollution that violates health standards and how that share has varied over time. And we estimate that in 2003, about 2.35% of drinking water samples violated health standards, and that share dropped to less than 1% in 2019. And I just want to note, because this is very important, that when we are calculating the share of drinking water that violates standards, we're using current standards as of 2019. So we're holding those standards fixed and seeing what share of pollution concentrations violated the current standards. And so we get a finding that the share of violating standards has declined by roughly 60, this kind of 60%, very dramatic decline over this sample period. You can also look at, that's pollution levels overall have declined. What about specific important pollutants? We find that arsenic levels have declined, lead, trihalomethanes, uranium, and to some extent, nitrates. All right, the next thing we do is we estimate the impact of the Safe Drinking Water Act on these, we see a trend overall, but did the Safe Drinking Water Act have anything to do with it? We look at the impact of these loans. So these are the loans federally subsidized loans that are given out to individual systems to fund capital investment, to fund waterworks. And we do event study estimates where we compare systems that received one of these loans to systems that did not. And what we estimate is that in the years prior to loan receipt, we see roughly no difference in the share of pollution concentrations in those systems that are violating standards. But within 2 to 3 years, kind of 0 to 1 years after loan receipt, the pollution concentrations appear to begin to decline. They decline even further by years 2 to 3, and then they remain stable all the way out as far as we're able to look, up to 10 years after loan receipt. So just remember that it takes about 1 to 4 years for these projects to be completed. So from the time a system receives a loan, it could be up to 4 years later before that project is complete. That could explain why the pollution impact doesn't happen all immediately after loan receipt. But it's also interesting to note that the pollution levels remain persistently low in the years after. There have been some concerns that maybe these loans are going to fund projects where the project is not maintained effectively over time, and so maybe either a pollution impact isn't realized at all, or at least isn't realized persistently. We find that not to be the case. These loans appear to have persistent impacts. And we do a cost effectiveness calculation. It's all laid out in the paper where we estimate how much money would you have to spend through this particular mechanism, through these loans, to eliminate all violations of Safe Drinking Water Act standards. And we estimate the loans are quite cost effective, that it would be about $30 per person per year to eliminate pollution that exceeds current Safe Drinking Water Act standards. Okay, we do a bunch of other stuff on looking at how these loans impact different categories of pollutants. We find more or less that these loans are effective at reducing many types of pollutants, not all. In some cases, the loans will list the pollutant that they are targeting. They might target disinfection byproducts. They might target inorganic chemicals. Anytime a loan says it's targeting a particular pollutant, we estimate that those loans are extremely effective at reducing the pollutant that they are targeting, and they have no detectable effect on other non-targeted pollutants. So this is perhaps a nice sanity check that the loans that say that they're targeting a particular thing really are effective at that. They don't appear to have broader benefits in reducing other pollutants. But I will also note that it's roughly 90% of the loans that are given out are generic. They are not targeting a particular pollutant. So they are not meant to just reduce one pollutant. Okay. We also look to see, when you have a loan, are they reducing pollution kind of across the board? Or are they reducing pollution in systems that started out with very high baseline levels of pollution? So we do an analysis where our outcome variable is not just does the loan violate current health standards, but we say, or does pollution violate current health standards, but rather does pollution exceed a certain percentage of health standards? Like does pollution exceed 200% of the health standard? And what we find is that the loans are very effective at reducing pollution in places that have high pollution concentrations. They don't have much of an effect on places where pollution concentrations are already below standards. So they seem to be quite well targeted at reducing pollution that violates standards. Okay, the final thing we do is to look at the impact of these loans on mortality. And here we're focusing on mortality of adults 65 and older. These adults are linked to the system that serves them. And we do a similar type of event study analysis. And what we find is that systems that receive loans experience declines in mortality. They're somewhat more gradual. They appear about 4 to 5 years after loan receipt and continue to, the mortality reductions continue to grow over time. We estimate that the cost per premature death avoided is about $114,000. And if you compare this to the cost of the loans, the benefit to cost ratio using an age-adjusted VSL is about 21.4. Okay. You could compare these benefit cost ratios to other life-saving interventions. So this is similar benefit cost ratios to average medical intervention in the 1990s. It's much smaller than the municipal water treatments that rolled out in the 1910s. Presumably that was low-hanging fruit. Like you start by doing the very first type of cleanup of the water, generates very, very high benefit cost ratios. Ours is lower than that, but it's somewhat similar as this bar chart shows. Our estimate of 21.4 is shown in the orange bar to the right. It's a similar order of magnitude to benefit cost ratios estimated for the Clean Air Act, shown in the middle, 15.2, and much, much higher than estimates for the Clean Water Act. Okay, so just to conclude, we add a modern chapter to the study of the health impacts of U.S. drinking water, or just drinking water in general, especially in the U.S., right? So there's the classic history, starts in the 1910s with municipal treatment, and then goes to 1974 Safe Drinking Water Act. And we estimate the impacts of that act on pollution concentrations and health. We provide new comprehensive data on drinking water pollution concentrations that we hope others will be able to use in their research. We find that drinking water pollution has declined substantially over time, and that the loans that the Safe Drinking Water Act funds is highly cost effective at reducing pollution and generates mortality benefits, large benefit cost ratios. So I will stop there, and I'm happy to take questions.
Thank you for the talk. I just wanted to ask if you have any evidence of whether changes in water quality were priced in any ways. Like this would change interpretation of incidents if who paid for like improvements.
Oh, that's a great question. We do not have measures of the prices that people are paying or how this impacts the price of, like, if I understand your question correctly, it's if a system gets a loan to improve their water, do they end up paying more as a result of that improvement? I will say that the cost of, like, the utility cost of drinking water is a major concern in the U.S. Those costs have been going up much faster than inflation over time, partly because of the cost of improving drinking water. So it's an important question, but I don't know the answer to that.
Thank you.
Okay, sorry. So have you considered the other channels than drinking water where the water pollutant can enter your body, such as crop consumptions? So I was thinking of the situation where, like, for the counties that consume a lot of like rice is like, they are really water intensive and they absorb a lot of arsenic, and that could be another channel how arsenic can enter your body, and especially for your outcome, considering like the mortality impact, that could be another, that could be a little bit, that could change your result.
Yeah, so there are many contaminants that are in the environment that can affect us in many ways. Arsenic is a good example. PFAS is another big one. People are talking a lot about these forever chemicals that are in the environment that can end up in water systems. They could potentially end up in food. If you're growing crops, they can end up in the drinking water. I think what's helpful about our study is that we're directly looking at the systems. We're looking at systems that serve drinking water to people, and we're looking at loans that go directly to those systems. So what we think we're doing is we're estimating the impacts of cleaning up drinking water systems on health impacts. So we're not looking at the impacts that are happening through other, likely not happening through other channels. But it's of course very possible that like arsenic contamination in an area could be affecting people through through channels other than drinking water. It's also interesting, of course, to think about if you have a lot of arsenic in an area, then that arsenic ends up in the drinking water system. They may have to spend more money trying to treat it. So there's a very interesting interaction, of course, with how clean our surface and groundwater sources are and what the impact that has on the cleanliness of our drinking water.
Yeah, I guess I was wondering how these loan repayments are financed. Are they through property taxation? Because if they're coming from local taxes, then you'd imagine that the ability to take on one of these things is going to vary a lot, rich and poor places.
Yeah, that's a great question. So the way that these loans work is the subsidy is just through the interest rate. So the average interest rate is less than 2%. And so the idea is to provide kind of cheap financing to systems, local systems that may have a hard time they may not be able to issue bonds, or they may have, not have great access to credit markets. So that's the main channel that these things are working through, is giving them cheap financing. But at the end of the day, the principal cost of the loan, the system still has to bear. I don't know all the details about how states and local municipalities kind of share in those costs. But I know that there's, in the decision rule, when this basically states, this is a federal program, money is given to states, and then states decide how to allocate that program across the systems that have greatest need. And greatest need is up to the states largely to define. So that could be that pollution is really high in an area, so they target that. It could be that it's a large population, often though they consider things like it's a low-income population or a place that would otherwise have a hard time funding this type of infrastructure investment.
Yeah, we have time for one more question. I was wondering if you have any information on private wells, which are important drinking water sources in rural communities, and if we know anything about those trends.
Oh, so well water is not in our data. They're not federally regulated, and states sometimes do, and local regulations sometimes apply, but it's a small share of the US population. I think our drinking water systems that we have in our data cover 90% of the US population. Of course, 10% is still a large number of people, and we don't have any data on those systems. But that would be very interesting to know how that's changing over time as well. It could be very different from what we find.
Yep. Thank you so much, David.
All right, thank you, everybody.
Where that is. Click blue in the US. I think it's true that it's okay, there's no dilution. Yeah, it's very
Hello, everyone. Thank you so much for having me here. I'm Rashmi Barua. I'm at Jawaharlal Nehru University in New Delhi. I'll be moving next month to the Indian Statistical Institute in New Delhi. Prarthana was a student. Now she's teaching at IP University. Debushpita is a PhD student at Calcutta University. And I have to say that I feel under pressure here. The reason being that I think I'm the only one who's crossed an equator, and also some development indicators to be here. So when I looked at the profile of everybody else who's presenting in a session, so I'm glad that this is one from the developing world. I've traveled all the way from India to present this, and I'm also happy that the previous speaker sort of stopped at arsenic, because that's what we're going to talk about today. So that sets the stone for this talk. Okay, so how do I motivate this? So there's a low uptake of development programs, and this has been well established in the literature. And when we think about the reasons of these development programs, whether it's health, whether it's sanitation, whether it's cooking gas, electricity, water, there's some reasons for it. There could be lack of awareness. People would have a low trust on governments. There's issues with not knowing the eligibility criteria or the administrative procedures. And of course, there's unreliable supplies. So all of these together imply that there's low trust in government infrastructure. And as a result, there's also low uptake. One of the reasons that is often cited is, this link between information barriers and transaction costs that limit the effectiveness of these government policies, in particular in areas where the trust in these infrastructure is already low. So what's the context I'm going to talk about? I'm going to talk about a context of severe environmental risk. This is groundwater pollution in one of the most polluted groundwater regions in the world. And the policy backdrop, so I'm going to look at the effect of an intervention that was implemented with the government of India. So this is the Jal Jeevan Mission. The Jal Jeevan Mission is the flagship program of the Indian government in supply of water. So we worked with the government partners. Before water was provided to households, so this is a large scale, national level tap water program that was started. We provided some information and some support with procedural application process for water. And so that's the background. And going forward, 2 years later, once water actually starts coming on people's taps, we look at some long run health outcomes as well as, and these are administrative health outcomes that I'll be showing you. Okay, so let's start with, what David stopped with and the question there about, rice production. What is arsenic? So arsenic has been called the world's largest mass poisoning in human history. More than 230 million people are exposed to arsenic in groundwaters. What do we mean by exposed to arsenic? So the WHO says that anything above 10 micrograms per liter. So note that the previous speaker, David, was showing you figures where we were talking about 6 micrograms per liter in the figures. I'm going to be talking about a region with 1,000 micrograms a liter. And the WHO says it has to be below 10 micrograms a liter, above which it is poisonous. And the short-run effects of this is vomiting, diarrhea, muscular pain, and in the long run, it is a known human carcinogen. It has affected every possible part of your body, from diabetes to neurological difficulties to cardiac issues. So everything, every possible part of your body is affected, and no wonder that Agatha Christie used this in her, she's written 66 murder mysteries. And if you followed her books, then, 30 of her characters died, out of which the first main poison was cyanide and then followed by arsenic. So it used to be her most favorite. And the reason being at that time, it was used as in rat poisoning. And also because, in World War I, she had worked in a dispensary and she was familiar with how these poisons work. And there are other books, ABC of arsenic in the Victorian death. So there is, a pretty large literature talking about this and why it is the king of poisons. Okay, so how does this work? So we talked about surface water in the previous talk, and unlike surface water, which is through pathogens or what David called as organic chemicals, what you have in groundwater is heavy metals or inorganic chemicals. So some examples are arsenic, fluoride, sulfates, nitrogen, and chlorides. What is the source? So in the India, Bangladesh region, South Asian region, we know it's from the Himalayan belt. We know it's from the Indo-Gangetic plains. We also have evidence in Bolivia in the Andes. We have evidence in Argentina of the occurrence of arsenic, and usually these are in areas with alluvial sediments, in sediments of rivers, major rivers, and in the Himalayan. So that's the reason why it's naturally occurring. However, what we do know is that, if you want to write a paper looking at the effect of arsenic on health outcomes, that's endogenous, because we know that arsenic levels tend to increase in your water content, in your water supply, when water tables drop. And the reason is that, as you have more exploitation of groundwater, the levels of arsenic, which is right at the bottom, tend to come up, and you have more of it, more concentration in your drinking water. So what we do know is that human exploitation, as well as climatic influence, because climates would change the hydrology, it would change the soil quality, and eventually that will change the concentration of heavy metals, also has an effect on rising levels of arsenic and other toxins in groundwater. Now, the focus of this paper is on a different group. We are going to focus on the most vulnerable group, which is children, and we are going to focus on pregnant women. There were a couple of reasons for this, but one of the main reasons was because, we worked with the government agencies. We wanted to get administrative health records. And this was really the low-hanging fruit because this is data that is collected by, the Indian government. So why is this so important? Because for child outcomes, there's vast epidemiological literature that growth affects everything from height to weight is affected by arsenic. Neurological effects on children. There's also evidence, my own paper, where we find that this affects on education outcomes amongst children. We have a differences strategy there. What about women? What we know is that in pregnancy, if you're consuming arsenic contaminated water, you tend to have more stillbirths. You have children who are born with lower birth weight, and you have lower maternal hemoglobin and higher blood pressure. So what is the solution? Unlike in countries where you can afford to have some kind of a mechanism to remove arsenic, it is really an expensive process. So what Bangladesh did in the 1990s when they found arsenic in the groundwaters is to move everybody from those wells to safer wells. So that's the first strategy. You have to switch source. The second, in particular, with this context, which is pregnant women, breastfeeding can protect children from drinking arsenic contaminated water because one of the other benefits of breast milk is that arsenic has not been found in breast milk. So even if you are consuming water that is polluted with arsenic, you are unlikely to pass it on to your child through breast milk. So what we could do is potentially to tell women who are pregnant that if you don't have an option, at least you could increase the duration of your breastfeeding. And there's this lovely paper in the Restart where they find that after an information campaign in Bangladesh, women who tended to breastfeed their children longer found them to have lower mortality rates and lower rates of diarrhea. So here's a map of where do we find arsenic in India.
I just ask on your last bullet point there on source switching. Maybe misremembering, but was there some evidence of trade-offs in source switching with surface water sources that then are more prone to diarrhea?
Yes, so Benier et al., they find that when you make people switch to surface water, they actually the deaths increased in Bangladesh because children died of cholera or other waterborne diseases.
So the source switching that you're going to be trying to induce is not to surface water sources?
No, so that is one of the sources, but we give a very extensive information about when you switch to surface water, what should you do? How should you treat your water? How should you boil your water? So we give very extensive information in our. So this is the part, the Indo-Gangetic, the Brahmaputra, that's the river that flows from between Bangladesh and India, belt where you find a lot of arsenic. So these different colors correspond to different data sets, but the greens are the one which is consistently found in all the different data sets. So this is the state of Assam, which is in the northeast of India. And then you have West Bengal, you have Bihar, you have Uttar Pradesh and Uttarakhand. So these are the main states which have very high levels of arsenic. Now, let me give you a little bit of policy background, the Jal Jeevan Mission. So in 2019, the government of India launched its flagship program known as the Jal Jeevan Mission. Jal means water, Jeevan means life. So water life mission. The objective was by 2024, every household should have rural household should have tap water. In reality, this is far from what has happened on ground. But yes, so according to government sources, over 440 million rural households have already got tap water. What's interesting is that it's a bottom-up demand-driven process, which means that households at the panchayat level in a village would decide whether the village wants water, and then they manage the entire water system. So the JJM has introduced this to ensure long-term functionality. But that also means that there's a lot of pressure on the households to be able to know how to run that entire process. So these are pictures taken by us. So this is an example of what the JJM is doing. So this is my geography of interest, which is the state of Assam in Northeast India. That's the river Brahmaputra. It's one of the longest, widest rivers in the world. And you can see that there are 11 tributaries. So this is a very water-rich state. So surface water is really abundant in this state. And through these tributaries, here's a pipe water scheme. The water comes to these facilities where it is treated, and then it is sent to households. And the households only get 2 hours a day of JJM water. So then you control that through this meter. In addition, every household has a stand pump where also there is a meter, a switch meter, so that they don't over extract. Yes.
Sure, context question. What's the interaction with SBM here? So are all these districts, like, is SBM completed?
So now SBM is an old program. So, I mean, we love to launch programs in India. And so this is, JJM has taken over the Swachh Bharat mission.
So this is a context where like free sanitation access subsidy has been given.
Yeah, so they just call it, this is a part of the Swachh Bharat mission.
Okay.
So one of them is the Jal Jeevan mission, but yeah, we don't use SBM anymore. Okay, so what did we do in this paper? It's a cluster RCT. We partnered with 2 government agencies, the Ministry of Health and Family Welfare, who are, for those of you who've ever worked with Indian data, you may have heard of our frontline health workers, which are the ASHA workers. So essentially, these are the people who employ the ASHA workers. They are the ones who go to every household, make sure the children are immunized, the mothers are taking their prenatal supplements. They monitor, the women have to go to the ASHA workers 4 times during their pregnancy to get their bloods tested for hemoglobin levels, for their blood pressures, to ensure that it is a safe birth. And the second organization that we partnered with is the Public Health Engineering Department. So the PHED is the rural body that provides water to each government household. So the Jal Jeevan mission, the government of India's flagship program, is managed by the PHED in all rural regions in India. So those were our 2 government partners. And what's interesting is that because we worked with the government, the intervention was rolled out before the actual water supply started, which happened sometime in the end of 2022. So this is beginning of 2021 when we started our own intervention, before the campaigns about JJM had started in this part of the country. The treatment 1 was arsenic-specific information and awareness about alternate safe sources of water. I'll come back to this in a bit. And in treatment 2, we provided the same information. One of the reasons why we did that is because information was so low at baseline that we just had to provide that. And of course, for researchers, that's problematic for me because I don't have a pure procedural support treatment group, but it was just so important to give this information. And we also had budgetary restrictions. So we don't have a group for procedural support alone, but we have the information, and then we have the second, which is the information plus helping people with applying for water. Yeah.
Just to clarify, once the decision to participate in the tap water program was at the panchayat level. So, and then once the panchayat had decided to enroll, every household got the tap water.
Correct, but
or access, yeah.
Yeah, so it's they put the stand post, so you have to manage the last mile infrastructure. So they will put that stand post outside your house, but for you to bring the water to your taps, you have to spend. So that's how they incentivize people to keep the infrastructure. So not necessarily that everybody would put in there, because this is a really rural, very poor part of the country. Okay, I'll skip this in the interest of time. I will show you this region. So this is Assam. And in Assam, I'm going to focus on this particular district. So that's the smaller administrative unit called Jorhat. And the unit even smaller than that is called Theta Bor. So this is the block. So we have the state, we have the district, and we have the block. This is the block that I'll be focusing on. Why? First, because why Assam? It has the highest infant mortality rate and maternal mortality rate. Well, MMR, the highest in the country, and it's the 4th highest infant mortality rate in the country. Why Theta Bor? Why this particular geography? Because one, the average arsenic levels are between 200 to 500 micrograms a liter. And the whole block has been labeled as arsenic. There's no part of the block which they haven't found arsenic. So it is really very much prevalent. There's low trust, existing trust in government infrastructure. I'll talk about this in a bit. The baseline information about arsenic was very low. Only about 20% at baseline knew that there was arsenic in their groundwater. The time cost is really high. As you see, this is the region, tea gardens and rice farming. 92% of the population in our sample is doing one of these two. So the time cost is really high for this group, and they're all daily wage earners. And then there was very low procedural knowledge. Only 35% of people at baseline knew that what it takes to apply for a tap water connection with the government. So this is at the time of our piloting. So that's an ASHA worker. So they helped us sample they helped us get our sample. And so this is a typical home with ASHA worker who's there in the picture. Okay, so it's a cluster RCT. There are 110 villages with no existing pipe water connection. So we go to areas only where there is no existing pipe water connection. Final sample from those 110, the ASHA workers gives us the database of everybody that she is servicing in that house. So these are children and pregnant women. So children between the age of 0 and 6 and pregnant mothers. And then the randomization, of course, is at the village level. It's clustered at the village level. And the final sample is about 2,075 households across 83 villages. Okay, now what's the intervention? I think it'll be easier for me to show you with the picture. So in addition to the videos, we showed to each house, so this was a door-to-door campaign. We showed each household a small video. It was about 7 minutes long, but the same information was also given in a pamphlet. The households were given that and said that, show it to other members of your family. So this is the kind of information we start with. So those of you who read, if there's anybody, Indians here, South Asian who read Bengali, this is the same script that we use in Assam as well. So that's showing the kurtosis, the skin diseases that are caused because of arsenic. That is showing that it affects every part of your body. This is telling you that particularly for children, it affects their height and weight. This is telling you, you can drink surface water, but then in the video that there was a doctor who talked about how do you filter that surface water. This tells you that you can use water being supplied by the government, but do not drink brown water, do not drink water from tube wells. And then we had a whole lot of, there was a doctor who talked about pediatrician, particularly a gynecologist and a pediatrician who talked about the benefits of breastfeeding if you are living in an area with high concentration of arsenic.
How do you keep the arsenic out of the tank water?
So the Jal Jeevan Mission, most of the water comes from the rivers. So the earlier, so this is the source of JJM water. Assam is a water-rich state. So unlike the rest of India, there is, unlike the rest of North India, there's very...
So that water doesn't contain...
No, there's no arsenic in surface water, only in groundwaters. How am I doing with time?
We have 8 minutes.
Okay. So this was the first intervention, which was a video and a pamphlet. In the second intervention, the same video and pamphlets were shown, but in addition, we gave them details on the Jal Jeevan Mission program. And remember, the government had not started their campaigns yet. So we told them about what the JJM was going to come with. We told them that, these are the procedures, these are the paperwork you need. We helped them fill out their the letter of intent forms, which was designed by the government. And then we, of course, told them that you could give it to us, but because we didn't have ethical approvals to get the application, their identity requirements that they needed, most of them decided to submit them themselves. But because we don't have similar information for the control group, I'm going to show you demand outcomes, which are going to be self-reported, but I'll show you supply outcomes, which are administrative. Okay, so this is the timeline. I just want to point out here that the end line was done after 2 years of the intervention. So we had 2 years in between that. Sometime in the end of 2022, the JJM water supply started to come in the region. It was still very low rates, but it did start coming to households in the region. So I'm showing you midline results, which are more behavioral. Those were right after the intervention. So that's somewhere here, number 3. And then I will show you end line results, which is 2 years later when households now, some of them, a very small proportion of them, have access to water in their homes. I think it's a very simple RCT, so I don't need to. The only thing I would like to say here is that in the end line, I'm also going to show you the total treatment effects. The reason being that by 2022 end, the government started its own campaign on the JJM, not about arsenic, but about the JJM. So there is some contamination in our control group as well. So I will only show you results. I mean, I would focus on results which are showing you the total treatment effect in the long run, because I can't really, even the control group is exposed to the transaction cost, if you may. Okay, so the first thing I want to show is things that we would expect, right? The behavioral changes. These are some, there are a lot of variables. For example, can you remove arsenic with boiling? The answer is no. So we make an index out of these. We use a usual Anderson index. We control for multiple hypothesis testing. And, we find nothing surprising. We find that it increased in midline, but there was a sustained increase in end line as well. Okay, even in the end line, and you can see that these two are not significantly different from each other, the treatment one and treatment 2. So we continue to find 2 years later also, households are more informed about arsenic. Then remember, the second treatment gave them information about the procedures. So as we would expect, this difference is significant. It's only in the second treatment that people were more aware of the paperwork and procedures. But 2 years later, that goes away because now the control group is also aware of the paperwork and procedures, because that was what the JJM did.
Sorry, how difficult are the paperwork? Like, what does that entail? And are there also financial costs involved?
So the paperwork would tell them, yeah. So the water is 100 to 150 rupees a month. So that's, it's like a pound a month on an average salary of about 150 pounds, 80 pounds in the month. So that's the cost in terms of, but there is a time cost because you have to take this paperwork to the office, which is, this is a really big geography. So you have to go to the nearest office and you have to submit. So there's some time cost as well. You have to get your, not everybody has the Aadhaar card, which you need for submission. So you have to do some paperwork if you don't already have the Aadhaar card. So there is quite a substantial.
There's no connection fee, it's just the monthly charge.
There is no connection fee, just the monthly charge, yes. But they have to put the infrastructure on their own. So they have to get the pipe from their homes till the stand post. So the stand post is located, yes, because it's a bottom-up approach. They want people to take ownership of the infrastructure. And the other thing I want to really show you, which is really nice, is this water safety index. So these are questions on, have you tested your groundwater for contamination? Are you taking any remedial measures at home, like switching to an alternate source? And how often do you filter your drinking, cooking water? So these are water safety measures, and the index shows up to be positive even 2 years later. So people tend to continue to take safety measures. More importantly, the information intervention by itself was sufficient for people to invest in these water safe behaviors or practices. So here's my really interesting result. The demand for water all comes up in the second treatment. So while people become informed, they are taking water safety measures with just the arsenic information. It was with the nudge that the demand increased, right? So, we looked at some reasons for this. This could be because it increased the trust or credibility with the government, because here's somebody who's coming and telling you that these are the paperwork and procedures, there's water coming. Yes.
Can you just remind us what demand for water means exactly?
Oh, this is self-reported demand. Have you applied for a water connection? Yeah. Because we don't have admin data on demand submissions from the control group. Yeah.
Sorry, what's the kind of a very rough estimate of how much it would cost a household to do that last connection to the standpipe, like out of a monthly or yearly wage?
Yeah. Yeah, so I would say that, so this is an option. The JJM also gives people option of putting in your labor hours in the construction of so, they've kept it really very, I have a minute, so I will take all the questions after this. And so, we have other reasons. It could have decreased the cognitive burden. There was a social learning from neighbors, and there's an opportunity cost. So we are able to study all of this in our data because we have asked them that why did they apply? And what I want to tell you here is that most of them did not apply because their neighbors applied. So it was not social learning. They were not applying because it was costless. So I presented this 2 years ago in Mushfiq's conference in Jamaica, which is the midline results. And that was one of the questions that was coming very often, that this is costless, people will just apply. We don't find that. And it is mostly driven by health safety concerns and time costs. But here's the interesting thing. There was a similar program that was launched 15 years ago. And that had a lot of leakages. There were a lot of corruption, because of which it failed. This was known as the Greater Titawar Water Supply Scheme, GTWSS. What we do is we look at just the sample of households who had applied for the GTWSS 15 years ago, but did not get water. And we find that even for them, it is the second treatment that's increasing demand, which tells us that the intervention potentially increased trust in government infrastructure. And this is administrative data on the supply. So this is 2 years later, there was a 40% increase in supply, but you can also see the rates are really low. So even 2 years later, only 13% average households got water connections as promised by the government. And out of that, the treatment was 40% more likely to get a tap water connection. But because I'm really running out of time and I would love some comments on this, I want to show you the results for breastfeeding, because I think that's really the most beautiful result in the paper. Everything in the second treatment. And these are administrative outcomes. These are not self-reported. So what we find is that administrative data tells us, ASHA worker data tells us that in the second treatment, women are about 2 months more likely to breastfeed their children.
So why? Like,
So
thought there should be
so
information.
one theory that we have here is because, both the treatments told you about the benefits. But it was only in the second treatment that we gave you a time cost. We told you that, there's water coming, JJM is coming, and breastfeeding is expensive, right? Because these are laborers, they are tea garden workers who are mostly females, and potentially what the second treatment did is also made you think about that the cost is not too much. I mean, there's also this behavioral explanation of hope, but we cannot rule out which one of them it is. And if you give me 30 seconds more, I will just show you one last set of results, which is from the mother-child health cards. So the ASHA workers keep these mother-child protection cards, or the MCP cards. So all of these women, there were about 1,200 mothers and child pairs in our sample. Out of them, a small portion, population, about 14% of them were pregnant at the time of the intervention. So we study whether those pregnant women who delivered births after the intervention, there was any differences in their administrative health records like anemia, blood pressure, hemoglobin, birth weight of the child. Note that this is just 1.5 months after the intervention, so we don't expect much. So the results I'm showing you is more, so this is a diff and diff. We look at, was the child born after the intervention, interacted with the treatment dummies, and what we find is that the women who were, I think this is the only one where it shows up. Everything else is economically significant coefficients, but given the short time window, it doesn't show up. But there's a very, there's a very established literature on arsenic reducing hemoglobin levels. So one of the first things it does on women who are drinking arsenic contaminated water is it works with, it messes up with your hemoglobin levels. And what we find is an increase, and again, administrative health records, there's an increase in hemoglobin levels amongst these women. And I don't want to stress too much on other health outcomes because it shows up somewhere. Most of them are insignificant because of course, the short time window. But yeah, just to sum up, we find an increase in breastfeeding duration, a decrease in musculoskeletal symptoms, but that's potentially because they switched to other sources of water, which would have reduced exposure to other contaminants. And we also find an increase in maternal hemoglobin during pregnancy. So I'll stop.
We'll go straight to lunch and we'll be back at 1:30.
You're moving to ISI.
It feels like.
Yes, I heard Shruti has been telling me.
to be on more structural G models. But they're going to address a similar set of questions. On the monetary policy side, there's an increasing recognition that amongst policymakers, regulators, academics, and central banks concerning the influence of climate on the financial sector. But in a recent article, in a survey, showed that out of 135 central banks, only 12% have explicit sustainability mandates, while 40% are mandated to support government policy priorities, which mostly include sustainability goals, but they're not explicitly built into the mandates of central banks. So to speak about monetary policy and climate, we have two excellent speakers. The first speaker is Swati Dhingra, who's an associate professor at the London School of Economics and is seconded to, the first speaker is Diego Kanzig. Diego is an assistant professor of economics at Northwestern University. He's a faculty research fellow at the NBER and a research affiliate at CEPR. He's doing very interesting work trying to estimate the social cost of carbon. He's been using innovations in global temperature rather than local temperature to produce those new estimates, and that changes the calculations on whether countries should decarbonize or not. And he has all kinds of interesting bells and whistles which speak to agent heterogeneity in these models and what kinds of fiscal transfers should be directed to poor agents or rich agents to minimize the effects of climate change. And Diego is also the associate editor of the Journal of the European Economic Association. Our second speaker is Swati Dhingra, who is an associate professor at the LSE and currently an external member of the Bank of England's Monetary Policy Committee. She's primarily a trade person. She works on international trade, but she wears a monetary policy hat now as well. So we'll be asking you some interesting monetary policy questions. She's also the director of the Review of Economic Studies and has served on several national advisory panels, including the UK's Trade Modeling Review Expert Panel and the Economy 2030 Inquiry. So with that, Diego, you can start. Thank you.
Thanks so much, Adam, for the very nice introduction, and thanks to the organizers for bringing me in the program. It's a great honor to be here, and I'm glad that I could make it despite all the headwinds across the pond. And thank you all for being here. I'm excited to share some fresh perspectives on climate macroeconomics. And to start this off, let's just assess together the state of current climate macroeconomics. And I think it's fair to say that over the last decades, the dominant approach to climate macro has been structural. What do I mean by that? This approach amounts to write down integrated assessment or computable general equilibrium models to study climate change and climate policy. This is obviously an extremely important research agenda. It's about how to jointly model climate change and the economy, and in the end culminated in Nordhaus Nobel Prize. With these models, you can do all sorts of exciting stuff, right? You can use these models to compute the social cost of carbon or assess the welfare impacts of climate change, or also do cost-benefit analysis. But to be able to do this, we face a key challenge, right? We have to discipline key model parameters and objects. And there's been a long-standing debate in this literature on the discount factor that is appropriate to do this. Won't have time to go into much detail into that today, but there are other important objects, such as the climate damage function, the abatement cost function, and the elasticity of substitution between, say, different energy inputs or between energy, labor. So how did the literature approach this? How did they discipline these important model objects? Traditionally, they relied on an influential literature that has exploited variation at the micro level. So micro meaning facilities, firms, regions, in some cases, countries. And I don't have any citations here because it's impossible to give justice to this literature on one slide. We have seen some fascinating work this morning, and obviously in the audience, there are people who have done really seminal contributions to this. Robin, Claire, Ben is there, I see. So, what's the key appeal of this approach? It's that it allows for credible identification, right? Because we can absorb potential endogeneity or confounding factors using fixed effects. This is great if you want to study heterogeneity and also if you want to speak to certain specific mechanisms. But in the end, what you will estimate most of the time are microelasticities or relative effects. So just as an example, in the context of carbon pricing, typically these studies will compare regulated firms, so firms subject to the price, to comparable firms that are not subject to the policies, right? So it's a relative effect. This nets out any market-wide general equilibrium effects via electricity prices, for instance, right? Only under some very special circumstances, that is, if these general equilibrium effects cancel out, these microelasticities will actually correspond to the aggregate, to the macroelasticities. And this is what we call in macro the missing intercept problem. Why is this a problem? Because in macro, the key object of interest are macroelasticities. So let me briefly talk about the missing intercept problem, and I couldn't have said it better than Ben. So I borrow a bit on his excellent material on this matter, illustrating this with a simple example, right? Suppose we want to answer the following question: how does government spending impact output? And we observe data on local government spending. So I here is a region, so I observe XIT, which is government spending in a given region I. And the aggregate government spending is just the sum over all the regions. Similarly, we observe local GDP, which is YIT for region I. And the aggregate is again capital Y, which is just the sum over all the regions. Now let's assume the true local relationship is given by this simple equation. So we relate local GDP to local government spending. So beta here is the effect of higher local spending relative to other regions. But in addition, there is also an aggregate effect, a spillover effect. So there is capital X entering here. This captures spillovers from aggregate government spending. These can arise in settings where we have trade, mobility in labor or capital, demand linkages, etc. Now let's aggregate this local relationship, right? So we would just sum over all the regions, and then we would arrive at a relationship that looks like this, right? So aggregate Y is related to aggregate X. We can also take the first difference of this equation, and then we would see that if you want to assess how a change in aggregate government spending affects aggregate output, this will be given by beta plus gamma, right? But if we estimate this equation locally, so basically estimating a version of this, where we have time-fixed effects, the X gets absorbed into the intercept, right? So this intercept is alpha plus basically this term that is related to aggregate government spending. What are the learnings from this simple example? It's that cross-sectional variation identifies beta, the relative effect, but not gamma. Why is this important? Because in this literature, exploring these identification designs at the micro level, oftentimes referees push you, okay, what are the macro implications of this? And then the calculation that is tempting that many people do is just to scale up the micro estimate, right? To basically get an approximation of the macro effect. But it's important to realize that this calculation is only true under very special circumstances. It's only true if the gamma is exactly 0. But as we have seen, this is generally not the case. Obviously, this is a very simple stylized example, but the intuition follows through in more complicated settings. One that I will speak about just next. And it's an example where basically we don't observe all the local XITs that go into the capital X. How do we approach this missing intercept problem? In short, we need to impose more structure. The dominant approach in the literature has been to write down a structural model to map these micro to macro effects. This can be either a fully specified model, or recently an influential literature has proposed to derive sufficient statistics that are estimable from the data, and these are consistent with an entire family of structural models, right? So here we impose somewhat weaker structural assumptions. An alternative that relies on even weaker structural assumptions is to exploit time series variation directly to estimate the aggregate effect of X on Y. Now, obviously, in general, this is very challenging because of endogeneity issues. But in this talk, I will try to make the case that this approach has a lot of promise, especially in the climate environment context. Why do I say this? If you think about it, in empirical macro, the canonical application is identifying the macroeconomic effects of monetary policy shocks. This is an extremely challenging task. Why? Because monetary policy systematically responds to economic developments at a high frequency. So there is very pervasive reverse causality issues here. If you think about climate, climate is something that moves much more slowly. It takes a lot of time until an emissions pulse eventually translates into higher temperature. So it's easier to estimate the effect of temperature on GDP, at least at medium horizons. Okay, so I hope I could motivate the approach. Now I will illustrate this with some examples based on my own work. And the first one is about estimating climate damages. If you talk to your friends or a climate scientist, climate change is often portrayed as having major economic consequences. Yet if you look at the available empirical estimates, they typically imply only moderate damages in the order of 1 to 2% GDP losses by 1 degree C warming 5 to 10 years ago. But it's important to notice that this literature almost exclusively focuses on within-country local temperature variation in a panel setting. How can we reconcile these views? Are the economic consequences of climate change moderate most, or is local temperature perhaps only a partial representation of climate change? In this work, which is joined with Adrian Bilal at Stanford, we propose a new focus on global temperature. Global temperature is the key summary statistic of climate change, as used, for instance, by the IPCC, and an important distinction to local country level temperature that people have studied extensively is that it includes ocean surface temperature as well. Reassuringly, there is quite a bit of time series variation in global temperature that we argue is unrelated to economic activity. And here we think of natural climate variability, such as El Nino, solar cycles, volcanic eruptions. So what do we get from this approach? Before we go to the results, we have to first discuss how we operationalize this. Because if you look at these two time series of global temperature and economic growth, both have been trending over time. And it's not a coincidence because we have grown. Part of the growth is based on producing greenhouse gas emissions, and these eventually feed into higher temperatures. This is the greenhouse effect at work. But this jointly trending behavior may bias the effects of temperature on output. If we were just to naively project world GDP on temperature, we would spuriously get a positive association between these two variables. That's why what we're going to do instead is to focus on so-called temperature shocks. So what we do is basically to filter some deviations from temperature around these trends. And that's the variation that we're going to exploit. And then in the next step, we will estimate the effects of these shocks on outcomes of interest, in particular GDP growth cumulatively. This is not very different to what the literature has done before. Say with local temperature, you can plug in this shock here, and then you will see it's actually the same. It's just regressing on temperature levels when controlling for sufficient lags. And this is what comes out. So on impact, we can see that there is an effect. It's not huge yet. It's around 2% fall in GDP. But this is not it, right? Over time, this effect builds up and reaches a peak in excess of 10%. Now, obviously, there is estimation uncertainty around this, but still, I mean, this is pretty sizable impact. We do a lot of robustness. I spare you with this for today, but I can refer you to the paper if you're interested in some of these concerns that can come up. In our view, this turns out to be a very robust related. Important question is then, how do global temperature shocks compare to local country level temperature shocks? There is a lot of previous work, as we discussed, exploiting this local variation, but obviously sometimes they use slightly different data, different specifications. So we really want to make sure that any difference is not driven by differences in specification or data choices. So we're going to re-estimate this here. So what we're going to do is just replace the global temperature shock in our local projection specification with the local temperature shock. And this is what comes out. So here we reproduce again the effects that we estimate for the global temperature shock together with the one for the local temperature shock. And what comes out for local temperature is that on impact, GDP falls by around 0.5%. The effect builds up somewhat and reaches a peak of maybe 1% after 5 years. This effect is not super precisely estimated, so it's usually not statistically significant at the 95% level. It's really stark here, right? So you see that On impact, maybe the difference is not that huge, but then over time, this difference really builds up. And here, difference is also statistically significant from each other. So global temperature shocks have much larger effects, and these are also statistically significantly different from what we estimate for local temperature shocks. Reassuringly, what we find for local temperature shocks is very much in line with the previous literature. So why is it the case that global temperature leads to this much bigger impact? The way we think about it is that global temperature is just a better summary statistic of the entire state of the climate system. In particular, it includes ocean surface temperature, and because of that, it better captures the frequency, the intensity, and the distribution of extreme weather events. This is what we illustrate here. So here we do a horse race. So we just focus on ocean and land temperature, and for both we construct these shocks, and then we estimate the effects of these jointly. And you can see that the big effects that we document are really driven by ocean temperature when we do this horse race. Obviously, the two shocks are correlated with each other, so if you just run this with land temperature, you'd also find somewhat bigger.
What's the reason for that?
I'm going to come next. Yeah, so that's an excellent question. So the reason is that global temperature, in particular the oceans, help to predict the incidence of extremes down the line. So here is basically what the global and the local temperature shocks predicts in terms of extreme heat, drought, extreme precipitation, and extreme winds today and several years out. You can see that global temperature shocks lead to a substantial increase in all of these extremes, whereas for local temperature shocks, we find much more moderate or even only insignificant impacts. What we also show in the paper is that these extremes themselves are also damaging, right? So if you estimate the GDP impacts of these extremes, they are non-negligible. And if we do a bottom-up calculation where we add up the effects of local temperature and these four local extremes, we get this red line. So we don't get all the way, but based on this mechanism, we get close to 2/3 of the aggregate effect cumulatively that we estimate in the time series. So there is still room for other explanations, but we think this is really an important mechanism. There is a question.
I'm sort of interested in the timing of this, that it takes sort of 4 to 5 years for this to play out, especially given the fact that a lot of the impact on these extreme events kind of, other than drought, I guess, happens very early on. And
It's a great point. So I don't have the picture here, but key to this is that the temperature shock that we're capturing, it's not a one-off shock. It has an effect on temperature today by 1 degree per normalization, but then it stays elevated up to 10 years out at a level close to 0.5 degrees Celsius. And this persistent that you observe here exactly also works through the oceans, which take much longer to warm, and then basically leads to these changing weather patterns down the line.
Okay, very nice questions then. So I'm a little trying to figure out what to make of this. It's like if this is driven by ocean temperatures, a lot of that could be like El Nino versus La Nina cycles. That feels like that could be more cyclical variation. And is that necessarily going to be the variation that we want to think about if we're thinking about global climate change? Is that like
so we do want
the same, or is that something totally different?
No, that's a great
I hadn't realized till I saw all this other stuff happening.
Yes. So we do one exercise where we try to net out all the variation driven by El Nino, La Nina in our global temperature shocks, and our results don't change. So it seems like these other sources of natural climate variability have comparable impacts. So maybe that helps alleviate some of the concerns, but I think you make an important point that there is always some extrapolation here, right? And the extrapolation is that this natural climate variability that we're exploiting here is representative of the damages that would also occur to slower moving warming. But that's different from the
you're basically trying to say that actually this warming thing is just like a proxy for all of these big global changes of the climate system.
Yeah.
That maybe that extrapolation from temperature, which some of us buy in the local context, for example, may not be necessarily the same in terms of global context.
One thing that we also tried is so we just looked at the trends of temperature and the incidence of these extremes and computed sort of elasticities, and these broadly lined up with the ones that we estimated conditional on the shock. So that's why we think this is at least somewhat representative of the trend. It's a very good point. Can I just push forward and maybe leave questions for the end? Sorry about that. So that's what we do. And then we have a model where we use this reduced form evidence to translate this into objects that we're interested in, such as the social cost of carbon, the welfare cost of climate change. You look here at the business as usual warming scenario of additional 2 degrees C by the end of the century. And you can see, if we estimate the model with our global temperature shock evidence, we really predict quite substantial impacts. Output falls by around 40% by the end of the century. So does consumption. And in terms of present value welfare loss, that's like a minus 25% loss today. And the social cost of carbon in excess of $1,300. On the other hand, if we estimate the model with the local temperature shock evidence, we find much, much smaller impacts. Let me briefly talk about the second application, which is about estimating abatement costs. The looming climate crisis has put climate change at the top of the global policy agenda. Carbon pricing is increasingly used as a tool to mitigate climate change, but so far, still relatively little is known about the effects on emissions and the economy in practice. In particular, are these national carbon pricing policies effective at reducing emissions? Are there short-term economic costs? What are the distributional consequences? Now we have in excess of 20 years practical experience with carbon pricing policies across the globe. So what does the data say? Challenge is obviously that carbon prices are not set in a vacuum. Policymakers respond to macroeconomic developments when deciding on climate policy. In addition, if you look at cap and trade schemes, these are market prices, right? They respond to demand and supply, which makes the identification challenge even more acute. On the upside, though, institutional features of these carbon markets, they allow for, I'm biased here, but relatively credible identification in the context of macro of carbon price impacts. And what's the idea here? It's based on my job market paper. The idea is the following. So cap and trade regulates quantity instead of prices, right? This establishes a market price for carbon. At the same time, we have very liquid futures markets on these allowances where these are traded. So we have very liquid markets and a good price mechanism. At the same time, regulations in the market have changed considerably over time. Now, this is an ideal setting for so-called high-frequency identification techniques. And the idea here is to isolate some exogenous variation in the carbon price by measuring how carbon prices change in a tight window around these regulatory policy events concerning the supply or allocation of these allowances. And the argument is to the extent that these regulatory use, to the extent that the state of the macroeconomy is known and priced by the markets, by focusing on this tight window, you would just isolate some variation that is driven by this policy use. And that's what I do in the context of this European carbon market. So this is just the price, and then I collect a comprehensive list of regulatory update events in this market. These include decisions of the European Commission, votes of the European Parliament, or judgments of European courts. So I was able to identify 114 relevant events in the period from 2005 and 2019, and then I measure the high frequency change in the carbon price around this event, and this is what comes out. So this is sort of this carbon policy surprise series, and if you believe the identifying assumptions, this is some plausibly exogenous variation in the carbon price that I can use as an instrument to estimate the effects of a change in the carbon price. In macro, it's hard to estimate this just based on a simple OLS regression, given the short sample. So I rely here on VAR techniques. You can do it using local projections. It's just a bit more noisy. So the shrinkage from the VAR is useful to get more precision. The point estimates actually don't change that much. But the identifying assumptions here are basically the same as you're used to from the applied micro context, right? We have this instrument that we know by C, and we have this structural carbon policy shock that we want to identify. So we require that this carbon policy surprise series, this instrument is correlated with this shock of interest, but uncorrelated with all other structural shocks driving the economy. And then there is an additional assumption that relates to the VAR framework. It's not that important for today. Let me just say we can relax this and we find similar impacts. This is what comes out. So here you can see basically the macroeconomic effects of a carbon policy shock that leads to an increase in the HICP energy price by 1% on input. And you can see that the policy works as intended, right? It increases energy prices, increases them persistently, and this leads to a reduction in greenhouse gas emissions. But this also comes at an economic cost, right? So industrial production falls significantly, output falls, the unemployment rate rises. We can use this estimate to do a back of the envelope calculation and estimate a marginal abatement cost. If I do this based on this data, I find a cost in excess of 100 euros per ton of CO2. This is higher than many engineering estimates and also higher than the average ETS price over the same sample, which is like an order of magnitude lower. This just shows that market prices, as firms trade them, do not necessarily internalize all the G effects that come with them as they pass on higher costs to consumers, and this affects consumption, employment, etc. down the line. So these are higher economy-wide costs of decarbonization that is just suggested by this ETS price. And obviously this is important when we want to do cost-benefit analysis. And with that, I want to end so we can use this new evidence to update cost-benefits analysis. You can use the marginal abatement costs that I just showed you. We can alternatively use estimates for decarbonization costs based on policies in the Inflation Reduction Act. And the key insight is, right, if we use this traditional worldwide social cost of carbon estimates, which are around $180 per ton of CO2, this is obviously higher than the decarbonization cost. So we would like to decarbonize. But the US policymaker, especially these days, they don't care about the worldwide social cost of carbon. They care about the US only domestic cost of carbon. And this is quite a bit lower. This is only about $35 per ton of CO2 under these traditional estimates. So from this, we will conclude that unilateral non-cooperative policy is not cost effective. But our estimates, when we use these global temperature shocks instead, they reverse this trade-off, because then even the US only domestic cost of carbon is in excess of $200 per ton of CO2. This is higher than the cost of decarbonization. So unilateral, non-cooperative decarbonization policy becomes cost effective, at least for large countries or economies such as the United States or Europe. And we illustrate this actually in this follow-up paper. So this is from our AAPMP, where we basically estimate this domestic domestic cost of carbon for Europe and the US and contrast this based on a marginal abatement cost curve. And this suggests that for these two economies, already today it would be effective to decarbonize slightly more than 80% of their economies, which is sort of the silver lining. I've maybe depressed you enough with these big damage estimates, but on the upside, it could be a way to break out of this prisoner's dilemma that we have been stuck for decades and with limited progress on climate policy globally. Because if the big players move unilaterally, it's much easier to get everybody to comply. And that's it. Thanks so much.
Perfect. Thank you so much. So let me just start with saying I'm an infiltrator to both fields. This is not really where I live, but then you do learn from people around you, like Robin and like John here in the room, who've also become environmental economists from other fields. So I think I'm trying to do the same. What am I going to talk about? I'm going to try and sort of I would have hoped to give what was actually the kind of presentation that Patrick gave yesterday on the wildfires, because it was so well understood what the precise effects are going to be. This is not what we're going to see in this literature. And in fact, a lot of what I'm going to talk about is what have we learned from some of the literature that's out there, and what have I learned from policy, and what are some of the key questions that are coming up. I'm going to try and synthesize them to give you a sense of why this is an important topic to be thinking about. So I'm going to start with just talking about why we need you all to be thinking about and working on these issues of climate and macro. And particularly what I'm going to focus on is central banking. I'm going to then say, what is it that central banks are actually thinking about at the moment, and how are they thinking about them? And finally, I'm going to try and sort of pin down some of the questions that are still very much unanswered, and where are things that, really need progress to be able to make some kind of progress on both the sort of academic side as well as on the policy side. So this is my one slide to try and convince you that this is really important. And today morning I got handed a nice bounty by Financial Times, so that's going to follow on another slide. But this is basically to say that central banks are the ones, when you're thinking about all of these big natural disasters and these short-run disruptions, it's typically going to be the job of the central bank to be thinking about those issues of stability related to it, as well as many of the short-run disruptions that happen. It's central banks that manage it. It's not quite necessarily the fiscal authorities alone. The second reason, loads of you yesterday in particular talked about climate finance, the investments needed. We heard the 1.8 trillion number several times now. Where is that money going to come from? Well, it's the central banks that are going to provide the regulatory steer for what that financing looks like, as well as they have very large balance sheets on their own. There's some very controversial policies out there in terms of should you do, green policies through the central bank balance sheets or not. There's also the third, and this is really what I'm going to say is, we still understand a bit more of the natural disasters literature, and because lots of people have studied what the implications of that are. We also understand a lot more about the financing side for the reason that there is a lot of prudential policy already in place. There's a lot of finance policies, and particularly financial stability side, which is already starting to think about this. And, just like Patrick and Jeanne talked about, the insurance market tends to be really important here. And those effects are the reasons we understand these things better. The third one is where, at least in my day-to-day working, I have found that we really, really need a lot more knowledge building here, because these shocks I'm going to show you in the next few slides, are going to be really important to think about. So when you all talked about, can we get financing? Can we get financing that's relatively inexpensive to be able to do these large changes in the economy? Well, one of the key steers for what that financing cost is going to, of course, also come from central banks through their rate setting functions. And that's also what most central banks are doing these days, is inflation targeting. So that's also going to matter for what the price signals in the economy are. So you might be thinking on one side, I'm going to see, it's great if price of energy goes up, people might reduce consumption, but that's also what the central bank is going to try and suppress, because that's really what's going to cause inflation as well. So these things are going to, not necessarily always go in the same direction. And then finally, this is what I'm going to try and sort of quite independently of Diego's presentation. I only saw it today morning, but we both independently came up with the same point, which is that we really need some credible research design here, because a lot of what has happened in this field is thinking about the modeling side of it, but not so much about how we're going to discipline those models and how we're actually going to make progress on thinking about what the policy implications of these things are. So luckily, Alan Beatty today morning wrote this article. I originally come from international trade. I've been asked numerous questions about what the Trump tariff war might do, including yesterday evening at dinner. And now today morning was this article where Alan Beatty is saying that it looks like inflation is coming, and no, not from tariffs. It's actually coming from the power sector, 7% increase, because electricity price is expected to go up from the Inflation Reduction Act subsidies being withdrawn. So just to tell you, this is really sort of first order. This makes it to the front page of the Financial Times, because almost every economy, inflation just becomes headlines within moments. I'm going to now sort of start to show you, hopefully I've motivated you. These are important questions you should be thinking about. And this is a conversation that central banks are having within themselves, but not really with as much input coming from the academic community. So I'm going to talk a little bit more about why is it that central banks actually care about climate change? And Chetan mentioned a bit earlier about how barely 13 or 14 central banks actually have it in their mandate to think about climate change. But the key point is, even if it is not in your mandate, it actually is really important for most central banks to be thinking about energy as well as climate shocks. And I'm going to try and sort of show you some of that evidence. So I'm going to start with price stability, which is typically the most, almost every central bank's mandate these days is going to be price stability. whether defined through an inflation target or through some other method, etc. So this is the UK from 1940 to 2021. And what you can see here is UK CPI inflation. That's what we target at the Bank of England. So what are these orange lines showing you? And this took a lot of work to do. We went and every time there was a peak in inflation, we went and dug up, were there any energy price shocks during the period? And what you can see here is at times when inflation matters, which means you get these really large inflation spikes, and at times when inflation, when monetary policy really matters, because you're really trying to curb inflation, which can lead to really, very sharp cost of living crises. Those are also the times when these energy shocks have played a role. So in that sense, this is somewhat, first order connection between those two things and things that most central banks are going to worry about. So luckily for me, I came in exactly at this point. So I'm going to show you a fair amount of stuff on what happened with the Ukraine war. So this is also to give you a sense of it's not just through energy, but what is really being noticed now is that physical hazards are affecting price stability largely through the food basket. And food in most, economies, and everything I'm going to say is going to have somewhat of a UK-centric focus to it, because that's really what I occupy my time with. But of course, as you can see, for most emerging market economies, that's a really, really big issue because the budget share of food is just so much higher. But this is just to give you a sense of what are the different big inflation food price shocks that have happened. And many of these have been large enough, despite, not necessarily each of these budget items being really large in the share of the consumption basket, but the spikes have been big enough that they've actually shown up as inflation going above target. What has also happened at the same time, and why most central banks have now started to pay attention to some of these topics, is because climate policies are now starting to affect price stability. So here what you can see is what the EU emission trading scheme is doing to inflation, to CPI inflation in the UK. And this is sort of what really kind of struck us in the MPC when we had a climate meeting about it, is that this is the Ukraine war peak that happened. Food inflation at this point had gone up to 18% after already the energy price inflation. And by this time, we were looking at really high levels of inflation. 1 percentage point of CPI inflation could be explained by the pro-cyclicality of carbon prices during this period. Just to put that number in perspective, yes, when inflation is 10%, 1 percentage point doesn't seem like a big number, but 2 percentage points is what the entire energy price cap scheme, as well as the energy subsidies of the UK government, did to cut down in terms of inflation. So we're talking about, these are not trivial magnitudes anymore. So they're starting to show up in headline inflation. What else is going on? So most central banks are taking note of the fact that these things have become macro relevant already, and going forwards are likely to remain macro relevant and probably become bigger. So this is just to give you, a broad overview. I'm using different quality levels of papers. I'm not going to defend all of them. That's the reason we need you people doing that sort of work to be able to inform us better. But this is broadly what comes out of various reports, that now it's going to start to matter, that food inflation is going to be really impacted by climate shocks in the future. I can also show that more systematically for what's happening with climate policies in terms of, as we go further, this is the UK ETS policy reform, more and more sectors will start to come up. I don't know why the colors here are not coming up, but this is to say green is mostly free permits, yellow, orange, and then not covered. So all of these sectors are going to start to come into the EU ETS policy, and what is expected, at this point, sort of around this period, we're talking about 38 pounds per ton. And we're going to expect to go somewhere around 100 pounds per ton. So this starts to really sort of have an impact in terms of what the carbon prices and hence what the electricity prices in the country are going to be. So I was somewhat still skeptical whenever people used to talk about investments, because I just thought, we keep hearing about how there's such a lack of investment, but some of these changes have started to happen on the ground. So this is the decision makers panel of the Bank of England, as well as this has been verified by the general network of agents that the bank has around the economy, that many of the firms are now starting to tell the agents or starting to respond in these surveys that they are taking they are putting investment plans in place to handle to make climate-related investments. I'm sort of gonna go from here to saying, why am I bothering to give this talk now? One, because of course, Robin twisted my arm to do it. Other than that, I think this is the key point when a lot of central banks are actually doing framework reviews of what they are going to cover. So if you want to make, if you want to have influence in terms of what are the toolkits that banks use, what are the questions that they're thinking about, this is the right time to be putting those forward and to be thinking about them. And these reviews are probably going to go on for a few years because nothing moves fast in central banking world. So here's what's happened. I think that was the reason that I would say that the Bank of England also took notice of some of these issues for monetary policy purposes, which is to say that what many banks are concerned about is, and particularly after the pandemic, after the Ukraine war, was most of them saw major failures of their forecast machinery. For obvious reasons that you've got a massive, large shock to the economy like that. None of the macro models, mostly based on linearities, are going to be able to explain those sorts of effects. That was one reason, but I think what was troubling from most central banks' point of view is that it wasn't just that they missed the shocks and they couldn't explain the shocks, it's just that the errors were persistent. So every new forecast that came out for months on end kept still making the same forecast errors, so you had systematic persistent errors, and that's what most central banks don't want to do. So we can look at whether those forecast errors, some of them are correlated with carbon prices. And here you start to see that during the free permit period, they weren't really correlated. There wasn't much explanatory power. And as you get further on, at least as far as energy prices are concerned, you start to see this effect that you can explain some of the errors through the carbon prices that prevailed at the time. So in that sense, they were systematically not counting some of these pro-cyclicalities with carbon pricing and energy that were going in, and that was starting to matter for inflation. You can not quite fully see that in headline inflation, but there's some suspicion that this is sort of going to become worse and worse, and that's when central banks are going to start to take even more notice of these things. So from here, I'm going to move on to sort of giving you a little bit of an idea of how do most central banks actually go from here to thinking about climate change, as well as, let's not just say environment more broadly, because we're not there yet at all, but at least some of the climate change aspects are in here. So I'm going to talk first about physical risks, then about transition risks. So in terms of physical risk, here's broadly the model. So if any of you are interested in more the macro side of things, which is, this is the Network for Green Financing Schemes. I always forget the acronym, but I think it's somewhere around that. And they're going to think about it like this, which is physical hazards, acute and chronic. They're going to think about supply channels here, which is, when a disaster strikes, what happens to physical capital, all of these sorts of things. And that is fairly sort of, I think many of you have already sort of presented a lot of papers that have tried to think about those things. Yesterday, we saw a lot more work about this aspect, which is the financial channel aspect, thinking about asset prices, what happens to them, insurance markets, all of those things. This is much less well understood still, which is what happens to wealth, what happens to volatility in particular. Are we just going to end up in a world where there's more volatility? Are we not? And then finally, that channel and how all of this stuff feeds into economic activity and inflation. I think there's more work on economic activity, much less on inflation, and which is the point that Diego was making earlier as well. So that's one aspect when they're thinking about physical risks, but a lot of them now are starting to think much more seriously about transition risk, just because it seems so imminent that all of these climate policies are going to go into place. So this is the sort of broad way of thinking about what the short-run impacts might be from the point of view of the UK economy. We put in place carbon pricing. There might be some subsidies and investments. Subsidies and investments are usually thought of as expansionary, and the carbon prices are typically thought of as inflationary and contractionary, which means if they go too inflationary, the central bank will step in to think about whether those price signals need to be dampened or not. So in that sense, when you're talking about all of those various good things that carbon prices may do, they're also going to have to take into account these other channels, which are going to be moving in another direction quite likely. So we're also then sort of worried about, maybe not anymore, but generally about what are the green subsidies that are being put into place in other countries, because as a small open economy, those are knock-on effects that are going to come on to the UK economy as well. So let me give you just broadly, where is this literature at? I've shown you lots of channels. It looks like lots of great thinking has gone into that, and there has. And a lot of almost 100 central banks are signed up to this network. So this is not, you know, this has really big global reach and everywhere. I think this Lars Hansen quote from 2022 kind of sums it up. I don't have to say much more than that, which is it's all very well. Qualitatively, we understand which mechanisms could come into play. What we don't have are any really firm numbers on these things. And that's really where, you know, if you want to have one of the steers that was given to me for the talk was, please do something useful. So this is the useful thing I want to sort of talk about. If you want to have an impact in terms of policy, the qualitative models are just simply not going to cut it. You've got to start thinking about quantitative aspects, because for the person who's going to be making that decision, calibrating that is actually what you're really sort of thinking about. If you have bounds which are, you know, one of the instances I remember at the bank when I first came in was within the same confidence band, there was 4% unemployment and 8% unemployment. I will not take any of that seriously, and for obvious reasons. One is disaster and one is everything is great. So how do you make policy based on that? So you've got to have much more of a steer, much more firmness in terms of what the impacts look like. So of course, I'm going to say what you might expect me to say as I started. More of you should infiltrate this debate, and bringing some of the IO trade tools would be excellent. Diego already showed you some of the macro work that he's been doing. I'll talk a little bit about that. But bringing all of those to understand some of these key questions, I'm going to pick a few examples now, for the reason that I think it's going to sound very abstract if I just talk about questions in generality. Because of course, I mean, I want you guys to be doing the work to thinking about how you would formulate those questions correctly as well as answer them. But I'm going to give you some examples of what has happened in day-to-day sort of policy making, where if I were, you know, when I ended up with that situation, I wish we had better answers to some of these questions, that we would be able to do policy better. So one is, of course, energy security. Energy is going to be an absolutely critical feature here. Understanding what the climate shocks are and what their transmission looks like. I think that is really, really key. And that's not just key for climate shocks alone, for any pretty much shocks. Those are the things we want to be able to understand about them. And finally, I think this is more the zeitgeist of the day, which is that, you know, we want to be able to think about what is the interactions of the climate shocks with supply chains and with other geopolitical shocks. So I'm going to talk in detail about some of these, or rather not in detail. I'm going to show you some pretty pictures and say, please help us understand those things. So, and then finally, I'll kind of wrap up with a more broad kind of, here are some questions that I wish we had answers to. So let me start. This is when I entered the Monetary Policy Committee. This is what happened to UK energy inflation. Energy bills in the UK rose extremely sharply. So when you have this kind of an energy shock, you know, there's almost, you have to wonder, can monetary policy actually even do anything? And that's some of the work that's emerging now, that what are the other policy levers that should be activated in those circumstances? What has happened at the same time, and this is, you know, one day we'll finish this work. This is looking at LNG tanker data, trying to understand what happened to the LNG gas market as a result of the Ukraine war. So if you look here, what has happened is that we need to be able to understand why this price spike was so high. This is a little bit what Patrick Bolton was talking about yesterday, that even though we have the energy single market, you ended up with this kind of situation where prices absolutely skyrocketed within moments. And one of the reasons was that supply was tight, and then thank God we had a mild winter and the US started supplying capacity. So that's why you end up seeing the situation where now what we are faced with is a much bigger, you know, we have much bigger supplies of LNG, but that also means we're buying just about as much as we did before from Russia. Russian LNG was not sanctioned. It was Russian oil that was sanctioned. So this feature is simply not going to go away. And as Chatham House puts it, we used to think about energy and how you wanted to move away from energy, and the buzzwords used to be energy transition. That has got completely replaced by energy security. So that's what most governments are going to be thinking about. After that very nice dinner on Monday night, I woke up the next morning to see this, and my immediate thought was, oh God, now they're going to blame us again for all the inflation that's happening. Well, turns out the next day, PIMCO came in and said, no, actually, we don't think the UK is going to be an outlier compared to the rest of the euro area. Why are we outliers? It's actually mostly two things that's doing it. One is administered prices, of which water bills, and you've just seen the session on water before. Our water companies are in a mess, and as a result of that, water bills are going to go up 25%. So even though water is not a massive component of the CPI basket, when you have 25% increase, meeting a 2% target is not going to be that easy. The second reason is this, which is if you look at, why is everyone sort of getting so upset by the inflation numbers, given we've seen this before? Why does it matter if now we're here? It's because we're diverging from the euro area. So the question is, why are we diverging? And one reason, of course, are these administered prices, which are UK specific. The second reason is food inflation. We don't seem to look like the euro area anymore, and that's caused a lot of concern. But why do we not look like the euro area? Actually, it's mostly these three commodities that are driving it. And the moment you start looking at food inflation in the UK versus Ireland, you get them pretty tightly bound together. What's happened on the other ones? The other ones are mostly chocolate, which is, you all will tell me, that's West Africa, weather shock. What's happened to beef and veal correlated Ireland, UK price shock. So, that would be great if I could stop here, but the problem is that's not what's going to be important for monetary policy. The problem is, what if this is not the only isolated shock we're going to end up with? What if there are more and more of these, and that creates persistence? And then the central bank would probably need to step in. Should it not? Of course, I want you guys to tell me whether that's really the right thing to do or not when you have these kinds of weather-related shocks. The second thing, when I first got in, one of the key questions that was being raised was, well, the UK has got a serious problem of domestic inflation. It's not imported inflation in 2022. And one of the reasons was, look at services inflation, how high that is. That is a very typical metric that most central banks use. Or let's look at core services, which means we're going to strip out airfares and things like that out of it. And the point was, these are much more driven by domestic labor costs. And therefore, if you're seeing really high inflation in these outcomes, it must be because of domestic inflation and not because of imported inflation. So, this is not rocket science. For those of you who are from trade or IO, you're used to working with input-output tables. This is just saying, actually, if you look at the UK consumption basket, how much of that is energy, that's about 3.5%. But once you start counting up what the indirect energy reliance is, as well as what the indirect import reliance is, you come up with a number like 40%. And this is very different from what the US looks like. And since so much of monetary policy comes out of the US, that, we don't take the international dimension of it seriously. We don't take the climate exposures of it seriously enough. And for US, this number is around 10%, actually probably a bit lower. 10% is the most recent number I've seen. So overall, these are just basic tools you can bring in. And I wish I didn't have to do all of that analysis myself. I don't want to have to go through 200 IO tables when I'm also sitting on the Monetary Policy Committee. And I want you guys to have done this work. I know Aurelian's here, he's done that work. So let me sort of wrap up with saying a few things. So I think some of these are key questions which central banks need to understand when they're thinking about climate change. And every time I've read the literature, I've had at least 3 PhD students do massive lit reviews. And really, we haven't been able to come up with good answers to some of these questions. So Chetan's work is looking a lot more from an emerging market economies point of view. I haven't thought about those issues, and those issues, particularly of exchange rates, become much more salient there. Diego and others are looking at some of these other issues about how you would think about transmission, how you would think about optimal monetary policy in your new work. So these are just key questions, and most central banks are not going to be able to answer them because one, they don't have the time and energy to be able to do it. And second, many of them are not allowed to talk about these things because it is not because you don't set your own remits. So I'm going to sort of end with this particular slide, which is to say, there's been some work which is related to these things, and this is coming from different areas of economics, macro, trade, IO, so on and so forth. They're speaking to some of these questions, but we're still very, very far from being able to answer them. And I think these are some of the questions we should be thinking about. So I'll stop here. Thank you.
Thank you both for those very interesting talks. It's remarkable we're talking about food inflation so much in the context of an advanced economy. So that's
I feel like we've become a developing.
an emerging market economy problem. But so we have a couple of minutes for questions. If anybody would like to ask any questions to both the speakers, they can do so.
So I guess, Diego, could you just kind of drill a bit more into the ocean thing, because that seems super interesting. So it's the idea that the ocean absorbs and holds heat for longer, and then
it takes much longer to warm and keeps it for longer. Yeah, and then this changes evaporation patterns down the line and can affect all these outcomes that we look at quite persistently.
So presumably that's quite heterogeneous across the ocean. So people looked at sort of.
But even like ocean temperatures far away from you can matter for the local climate. Yeah. So that's because but that would be interesting. Yeah. So that's something that we were thinking about. Maybe we could build temperature measures that include your land temperature plus some of the oceans surrounding you, and see like how far we can get with that compared to like having all the oceans in there. That could be an interesting intermediate degree of aggregation. Yeah.
One question maybe to both of you is that when you have a supply side shock, you have these trade-offs because central banks have to trade off the variability of inflation with the variability of output. And with climate change, you're going to get these repeated supply side shocks. So you did speak about credibility, but is that going to become an issue for central banking going forward? How are they going to navigate that trade-off with climate change?
I think that's the big question. And Marcus Brunermeyer has a nice chatty piece which says that actually this might start affecting inflation expectations, and then of course more central banks will start to really worry about their credibility.
That's like a methodological question for the Diego perspective. So just when you were framing it, and you put the kind of
yeah.
I think there's this really good article about 40 years ago by Zvi Brillikis, looking at spillover effects from research and development into productivity at exactly the same problem, and raises the same issues. I think the way that literature has gone is that there's another way you can think of how to identify things by thinking about how the spillover mechanisms work.
Absolutely.
So, think about networks, think about closeness and other kinds of space. And that way you can include time dummies and still identify the way that shocks reverberate through a system by exploiting those kind of network relationships. And that actually, I think, is a it's an intermediate way of doing what you did, but it avoids the problems of going to a purely macro point of view, where you throw away all the cross-section variation that you have. So I would just, in terms of positioning your identification, I've skin in the game because I'm an econometric article.
No, I mean, I think these approaches are very much complementary to each other. In some sense, what Kotz et al. In their Nature paper do, or also we in this bottom-up exercise, is precisely that, right? So we go to the local level, but go beyond local temperature and look at other margins and then try to add up. I think the nice thing about the time series is it's very hard to figure out what are all the mechanisms that are going on. So it's useful to sort of have a benchmark estimates, and even by adding up all these local chances we consider, we only get like 2/3, not the entire story. The disadvantage being of the time series that you don't know what's going on, right? So that's why you have to do both. So
okay, I think we're
exactly on time. So I'm going to stop the session now, but you're welcome to speak the speakers after this session. So let's give both of them a big round of applause. Now we're going to get into the policy session, and that'll start in a minute. We have an online speaker and another speaker who is here. I don't see Sam. Oh, he's here. Yes, great. So you can maybe come up to the. So just give us a minute to assemble on.
And I have from this access going to be online fast.
Oh, okay.
Yeah, for the old one.
You want to see it?
Yeah.
What do you want?
Yeah, I asked him, but hi, this is Anna. Here, I can see you on Zoom. Are you on Zoom? I can see you on the list. Is your name? Oh, okay, we found you. Thank you. Let's just try to. Hi, Mr. Tabaro, could you please unmute yourself?
Hello, can you hear me?
Perfect, we can hear you clearly.
Okay.
Thank you so much.
Well, they want to see the speakers.
Oh, yeah, fine.
Yeah, absolutely. Okay, so welcome back to the policy session on climate and macro. So this is going to complement the previous session. And we have with us Sam Magumbe, who's the Assistant Commissioner of the Ministry of Finance, Planning and Development of Uganda. Sam's here. And we have Didier Tabaro, who's an economist at the Ministry of Finance and Economic Planning in Rwanda. I wanted to say a few things more because they're both involved in the IGC projects a lot in their country. So Sam is, as I just said, Assistant Commissioner for Macro Policy in the Uganda's Ministry of Finance, and he's the incoming co-chair of the Coalition of Finance Ministers for Climate Action. His work centers on the integration of climate priorities into fiscal and macroeconomic policy, with a strong focus on sustainable budgeting, debt sustainability, and resilient public financial management. He's a leading voice on the idea that resilience should be treated not only as risk management, but as a source of long-term economic and social gains. Great, Sam, thank you for being here. And the second speaker is Didier Tabaro. Didier is going to join us online. Didier is an economist at Rwanda's Ministry of Finance and Economic Planning, where he leads the macro modeling and forecasting team. He has also worked with the IMF as a special appointee and with GIZ as a macroeconomist. His work focuses on building models and analytical tools to understand and forecast economic behavior, supporting Rwanda's macro policy and long-term development planning. So the way the session is going to be structured is that Didier is going to give some comments on both presentations that just happened for about 10 minutes. And then I'm going to ask Sam a few questions about macro modeling and macro policy in Uganda and how climate is integrated into it. And then we'll just open the panel to a set of questions that I will ask, and I'll open it to the floor after that. So Didier, would you like to start with your presentation, please?
Yeah, thanks. Actually, it's a presentation just to kind of frame the works presented by the two presenter in terms of how it can see it in Rwanda. I mean, it's very interesting to see that climate is still very hard to incorporate climate in macro modeling. I mean, in the sense of central bankers and even more for the Minister of Finance. And the last presenter said that there is plenty of qualitative, I mean, materials out there, but quantifying this impact is quite difficult and still needs further work on that. And in Rwanda specifically, physical hazard, particularly natural disaster, show a direct inflationary, do a kind of have a direct inflationary pressures and currency instability. As most of, I would say, a large part of the population actually do agriculture for subsistence. So this natural disaster affect a lot the population and even our export because of the two major cash crop, which is tea and coffee, is affected, and even the tourism through the natural-based tourism, I would say, in Rwanda. So all that's why in Rwanda we kind of very interesting in all the work around how to incorporate climate matters in the macro modeling. And the central bank has already started doing so by incorporated climate data and module to improve their estimate toward their price stability mandate. And this is more on qualitative and quantitative data. On the qualitative, which is much easier, it's kind of a survey to agriculture and to see how they see their output, their upcoming output, and how climate, I would say, weather condition will affect their output. And this actually helped them in terms of doing their forecast inflation, particularly the food price inflation. And on the other hand, in the ministry, looking at the global picture of the country, we see this hazard affecting agriculture, I was saying production and so on. But in the ministry, analyze the exposure actually of these risk to the budget. And this all we include even spillover it could have on some SOEs, PPPs, and so on. And we're trying to base on the best practice in terms of tools and data to use. And one of the tools we've kind of managed is the QCraft, which is an IMF tool which assess the long-term impact of climate change on different macro variables. But again, we actually partnering with the central bank and the World Bank to kind of customize their CGE model they manage to Rwanda so that we can have it in Rwanda to be able to do to see the impact of mitigation and adaptation and new technology actually in Rwanda. So this actually goes in frame actually with the presentation our two speakers were saying. So in the central bank, these days we work hand in hand to see what fits better for Rwanda, which data could be actually starting to be collected and engage different stakeholders. Like we have even what we call agriculture working group, where we have Matteo Rwanda, which gives us data on Rwanda weather condition and so on. And this helps us to kind of put a name on some of the what we're expecting as climate disaster or weather condition on Rwanda. This is a natural what I could say on Minecofin and related to the topic. Thank you.
Great, thank you. Okay, Sam, welcome to the. So, Sam, tell us a little bit about your IGC work first. I mean, just as what you do with the coalitions and Ministry of Finance, what's their scope, how many countries are involved, and just
Because I want to jump into topic right away. Interesting presentations, really look at me. I'm like I said, I'm Sam Mugume. I'm from Macroeconomic Policy Department in Uganda. The big part is that Uganda now is the co-chair of the Coalition of Finance Ministers on Climate Action, 100 countries and Ministers of Finance, and all our target is to see how we can get the climate action discussion and parameters into the core mandate of Ministers of Finance. We work within 6 health principles. Is looking at planning first. How do we align the climate change plans with our national planning frameworks? How do we go into budgeting and planning and fiscal policies, into cash management and debt? You know, the objectives of revenue collection and the rest. So we keep sharing knowledge, knowledge products. We deal with institutions of higher learning like LSE and others. And so that is it at that level. And the probably can't talk much about that later. But for Uganda's case, we do have a lot of things we are doing in terms of research with IGC, with LSE itself, you know, working through the coalition and other agencies, World Bank, IMF. A lot of partners are working with us, first to understand climate change itself. What investments do we go to? Adaptation and mitigation. What are the risks and what are the opportunities? We are trying to use models you've been talking about here. It's and the last year with IGC, we do have what we call Economic Growth Forum every year. We had one in September where we discussed what we want to do out of research. And researchers come and present like that, and we say, we've done it roads, we've done it agriculture, we've done it gender, but climate change has come up strongly, which informs our budgeting process. And we are keen really to work with researchers because, like you said, we want that information. But last, you know, you put a point and said, the data is not there. That's number one. The last one was about monetary policy. It came out from me strongly. Alone cannot do. True, and you're right, but these are things. What else? What other policies can we have? We are trying policies, and so briefly, that's what it is.
Okay, great.
Coalition level and in Uganda.
And in the central bank, can you tell us a little bit about how these climate risks are being incorporated specifically into the models? So a big issue with Swati was talking about this, that one of the reasons why the forecasting goes wrong is because of turning points. That's a kind of lingering issue in the forecasting stuff. So is that something that you were able to tackle somehow?
I could tackle from the Minister of Finance angle strongly what we're doing and related at macro level related to the central bank, what is being done. But right from the onset is our central bank has not been really, hasn't used any of the tools that are available to the central banks in terms of inflation that comes, in terms of shocks, in terms of investments, you know, to control. From my end, what I know is that because these shocks for us, like, let's say inflation, because it comes from food and energy strongly, when there's a drought or a shock, then there is less production and then prices may rise. It takes a short time because our changes, you find there are 2 seasons, the next season is low. So it's really moving like this. And the central banks have, rightly so, our central bank has kept has kept quiet, and that probably has helped us, and people, the speculators are not coming in a lot. But it is coming out now clear, central bank is now understanding, the kind of understanding how do we risk, like interests and interest rates going investments, how do we support banks? We're talking now of new financing, modalities for climate change. So what does this mean? So it's getting interested, and they're still at initial stages of getting involved in the risk assessment, stress tests. So these are things they're working on.
And on the prudential side, like on the banking side, are there priority sector loans that banks have to give a fixed percentage of their deposits to let's say the agricultural sector or the micro, small, medium enterprise sector, right? So
we not really strongly in that way, but we do have, we've capitalized our development bank. And this bank has, we have a taxonomy, we want to give, there's funding that goes to the banks. There are two banks, private banks that have started it. Look at, I'll call it green financing, get money but low interest rate. The problem, the uptake of this money has been low. And basically because of the investments that you're going into. So these are things we've been looking at, and we don't understand properly what to do. I would say at that level, when it comes to it, we would get interested to know more. We're trying it about things, but we still need to know more. Our banking sector itself and the central bank involvement.
Okay, thanks. And something about public debt. What are the debt dynamics like? Is there fiscal space for redistribution? Is there subsidies that can be redone to?
That's a good thing, and I related to climate change.
Yeah, related to climate change.
What I was looking at, because we've seen really, I will go back to the presentation itself. The presentations, we've seen these things happening in the real sector, the economy, GDP going down when this shocks. We've seen that. So the point is what we do when we invest is key. The problem is productivity. We put it go down clearly. Out of 1 acre, you start getting less. And then the heat stress hasn't become very, very strong, but we see it in our numbers. It may work, it may come up. That's from the productivity side, but also we see it also from the fiscal, fiscal and budgeting. The revenues go down. They've gone down. We've seen increased expenditure in this, and there's increased expenditure, and this is competing with the things that we want to invest in, social services. You want roads, you want healthy. And now there's a flood, there's a drought, you have to give out some money for a set of people. So debt is where we run. We have to get debt. And we've seen our fiscal deficit sometimes bigger, 5, 6, 7%. Fiscal small business is putting out at 3%. So that is high. And then concessional financing is going down, where you go very fast. Domestic or banks that are ready to give you money at 13% or 14%, very high. So it is a problem. And then lastly, what comes after is that the rating agencies are coming, you're doing a debt assessment at this report, the agencies are coming at, because for sure, when you look at ourselves and stand the other side, you are, if I rate this country, I would rate it low, because you get money. Are you able to pay it with all these risks that are facing you? But now what we're trying to do there, we're working to see the debt sustainability analysis report tool, how do we put in adaptation and resilience factors in there? And we're talking with the World Bank.
And how would that work exactly? How would you the adaptation and mitigation?
It is that we're starting it first as a coalition, but Uganda we have someone from here working with us from LSE. She's not in here. And we are doing a tool, and we have it will produce two reports, parallel reports. One, the standard report, the one that we discussed with rating agencies, fine. But on the side, we're looking at within our development plan and realistically, what are we doing as far as adaptations long term? And if, when there's increased resilience, and factor it in and put, delta climate change things either positive or negative, one or two, and then we see what's the difference. They will not take it as a report because the standard report different standard tool. So we're saying this is going to help us with the narrative. When we're putting down narrative, the rate comes down, you say this, but then you start asking, are you doing anything? And that's going to help us to produce a narrative that can, for the time being, be used. But looking forward is everybody will come to understand that we need, when you invest in adaptation, key for African countries and our country in particular, it's going to give you more, make you more investable and more better in terms of rating. We are looking at that way. That's one way where we're doing some more, but we are also doing other areas.
So what is the sovereign credit rating of Uganda at the moment? Is it investment grade? I mean, so that means
we are actually be negative, not very sure, not to be quoted here, but we're not good. Not good.
Okay, thanks.
Yeah.
Thank you, sir. Right. Do you have any questions for the two panelists here in terms of their work?
No,
not the coalition of finance ministers could benefit from in terms of, their expertise.
There are a lot of things. Understanding the risks and opportunities is key. And getting the numbers is a big question. I'll tell you, we try to do the impact of drought on agriculture and infrastructure. Within our models, we have a social account matrix. We've extended it. We put in the matrices for land use, for energy and pollution and water use. So we ran, but then we had a paper, and then when we were trying to say, yes, this is it, we remembered we didn't have the damage functions, and we don't have the numbers, we just put it under. So these are things that many countries in the coalition are lacking. We have a whole HP4 working group with Denmark leading us. So we can join hands to look at such a things. That's number one. There is another area that we look at, the carbon markets and carbon pricing and how they can help, the evaluation of wealth within countries, natural capital, how can it be brought in here? The pricing itself is a question that we have. I saw you putting ETS and saying this is $12 per ton, but is that realistic? What does it mean? Understanding it is key. These are things that we can work on together. Climate financing is what is the best climate financing way? And when you get this finance, where do you put it? We're writing with IGC, we're writing a book. It's called the 10 Green Investments that can spur involvement in Uganda. We'll put things, but we can look at a lot of things and direct investments we're talking about, short term and long term. Can they be bought in by the policymakers and the politicians? The big question is that there are quick gains that I wanted. I want a school with as little money as possible. I want a road, I want this very fast. And you're talking about the one that is more resilient and will take more money and will take more time. So explaining that is very, very critical and key. And there are a lot of things I can talk about. Let me first stop here.
Okay.
If you allow me, I'll talk about other things here.
Sure. Well, maybe we'll come back to
some of those issues. Because I want to talk about trade is another area that's very, as developing countries and other cases, it's really when there's.
Sure. Why don't you make the point on trade?
On trade, really, yeah.
Okay.
Because what we're seeing is with climate change, if we run out, we depend on exports a lot. Coffee is one of the things that we do. And we're saying, okay, if there's temperature increase, this is likely to happen, activity and loss of coffee. So go down. So And we know there are areas, like CBAM, EDR acting on this and wanting it to make it better. But what if other countries don't do it in the region? What happens to our market? With carbon pricing and carbon tax. We've been discussing this. Is it being done in the region? We still what can we do? And so those are some of the things we would like to look at. Related to credit infrastructure, communication. Last year ago we had floods and roads were washed out. There's no communication. We lost the magnitude of loss is not known, so would like to measure such losses. And many countries really in the coalition would want such a help and work to be done in terms of losses and how they can recover. Then lastly, the new ways of doing things and the advantages. If you talk about less fossil fuel use, how we transition. This is a common question, really, but separate question for a continent like Africa, where you have energy deficiency and people are saying, there's a growing industrialization, how to use clean and renewable energy. A lot of questions and topics to be looked at in this area.
Thank you. Thanks. Just so here's a question to all four of you. I think you partly addressed this but just from your own areas, maybe Diego, I'll start with you. What are the research gaps as they apply to EAMEs in terms of climate and macro research? What are the burning questions you think need to be addressed? The work that you sent that we read had estimates for the social cost of carbon. They were very different once you looked at these shocks to global temperature. And the decision to unilaterally, kind of decarbonize makes sense once you begin to take those numbers into account. How do you use that work to address EME macro and climate and macro questions that's relevant for developing economies? Any thoughts on that?
No, that's an excellent point, because even in our evidence, this previous evidence, what came out on the local shocks is that the average effect is pretty modest, but this masks a tremendous amount of heterogeneity, right? And many of the emerging economies are located in hotter climates, are poor and tend to be more exposed to these shocks. And same heterogeneity we also document for the global temperature shocks. Just a bit less pronounced, we find more homogeneous impacts that are negative, but also these regions tend to be the most affected. Now, in our work, we really focus on business as usual warming scenarios. So this leaves out adaptation. But if you look at any reasonable projection, right, we are on a trajectory that it's just unavoidable that there will be a considerable degree of warming. So I think thinking about adaptation is really important, especially in emerging market economies that are already located in hot climates that will be more affected by all these effects.
And you showed that the welfare costs of these business cycles were huge. And that, in fact, he didn't have time to mention that, but he said that they were comparable to the Great Depression, except they were permanent because you permanently went down to. So is there a role for policy here to mitigate that? Think that
absolutely. So I do think, mitigation is important, but just like given where we are currently on the trajectory we are currently, I think we have to talk about adaptation as well, because mitigation is no longer going to cut it.
Swati, any thoughts on research, trade, relevant to policy, relevant to EMEs?
So beyond what I said, I think I'll add 2 points. One is that a lot of the work more recently, when people have, particularly out of central banks, when they're thinking about climate change, they've really focused in on transition risks. And then it's all about CBAM. We all know how to measure that better and so on and so forth. But I think more recently, you can see a lot more coming out of, and James Talbot's one of my colleagues at the Bank of England, he has an excellent sort of piece out there saying that actually what you need to be thinking about is that those physical risks are much more important to be thinking about, because if you don't take care of those, the transition risks are much smaller and they're kind of, they're sort of more short-lived. So in that sense, unless you start thinking about dealing with those risks that are to come, you're really not managing to, you're only basically postponing the main problem. So I think that's starting to now get into the mindset. So we're seeing a lot more discussion around these things more openly. But of course, there's a very sensitive aspect there, which is that if it's not in your remit, the only reason you need to be worried about it is what it does sort of to short-term or long-term price stability. And I think ultimately that's where I want to be able to see more work happening. And particularly in the context of emerging markets, if they're in hot climates and they have bigger food shares and many of them are energy importers, that toxic mix then just kind of amplifies the issues. And then you throw in what, your topic was, like, here's also exchange rates in the middle of all of this. So I feel like that's a pretty hard problem to deal with.
Okay, Didier, do you have any thoughts? Sorry. Is he there?
Yeah, sure. Me.
Yes. Did you hear the questions about what you think is relevant for research based on where you are for macro, for developing countries, generally on climate? Just a couple of thoughts.
Yeah, definitely. Yes. As my colleague from Uganda said, so there is kind of lack of actually a better understanding on how to incorporate these climate shocks into modeling and forecasting our in the models. So I think we still, even in Rwanda, we having the roadmap of doing a kind of a capacity building in kind of before even incorporating climate modeling, but understanding a very good understanding of a computer heterogeneous equilibrium model, and then add after with the help of stakeholders how to better customize what is actually a climate model which is customized to Rwanda to better understand the effect.
Yeah, sure.
So actually just following up on what Sam said, and I think this is really important to make a distinction between what EMEs are facing and what the developed world is facing. The developed world is mostly facing what is an import shock, a consumption shock. It's not really typically a production shock. And with large agricultural sectors, a production shock together with a consumption shock, I think, I mean, that is a very difficult problem. And I don't see much on that. Mostly when we think of even sort of when people have looked at weather shocks and how it matters for inflation, it's very much from the point of view of here's the consumption basket, what's happening to that.
Yeah. And those are Keynesian supply shocks. You talk about that in your work. And I think in the notes that you had in your presentation, you were saying that one of the ways to think about this is that there's a huge production shock and then that has income effects. And in Diego's work, he says that, look, once you do the general equilibrium very carefully, then prices change, wages change, employment change, you get these additional effects that, so you really need a full-fledged model to kind of pick up all these different effects and different households with different marginal propensities to consume will be impacted differently. So that kind of guides fiscal policy because it tells fiscal policy that, look, these are the guys that are hit the most. Here's the target for fiscal policy, give them the transfer the most because their consumption losses will be mitigated. So all that stuff is very useful to help motivate, the demand side and so the initial kind of shock is on the production side, but it's a demand side kind of hit, and so to speak. Diego, do you want to say something more about that? Because
yeah, absolutely. Like better understanding how these physical and also transition risks propagate to the macroeconomy is really essential, especially because a lot of the analysis focuses maybe more like on the immediate or the like more static impacts, but the dynamics are really important because these effects, they build up over time and they propagate through indirect general equilibrium effects, and it's important to take this into account. So that's also when we do this cost-benefit analysis, right? If we just do this partial equilibrium, we may get an answer that may be correct, but we have to verify that the general equilibrium doesn't overturn it.
Yeah. Okay. Yeah, sure.
Just one point on which did come out from. I think about it is the stranded assets and the stranded capability in human the capacity we've given and what happens tomorrow as we do these policies and the adaptation mitigation things. It's something, a big area to look at in terms of and especially in my country and many countries. I hope this is it's future what happens. It's our question as the Minister of Finance, but we're not answering it.
I think that's one of the big things that the NGFS is thinking about, in fact, which is, what are the productivity implications? What are the other implications of stranded assets, and how do you actually do the phase out? And I mean, the political economy of that is, of course, extremely difficult.
So that's what's happening.
So far we've been dealing with boring closed economy stuff. What about important open economy stuff like exchange rates and current accounts and challenges for current account management? Any thoughts on that?
We lucky as a country.
With these climate risks.
Yeah. We've not seen that this happening in Uganda really. Our inflation has been because of, we know there's food but the imports, like you said, the balance, it's opening up and the imports are increasing. We don't know. But we think it's more of trade, global trade, and coming in of other people produce things that comparative advantage. That's what we think, and it's coming, and our openness as a country. And the exchange rate is, like I said, central bank hasn't come in, but our exchange rate it's been stable for some time. And if we're appreciating the currency is getting over time, you see it appreciates a little. We've not felt it yet, but we think it may come. It may come because we are an agriculture country. We depend on exports definitely. So if there's a big shock, it will bring us to problems, the exchange rate and the that's something if you look, we talk about it, we've not put it in our numbers to put a policy that kind of manages. I would say that. But other countries are facing it.
So I think there was this discussion last night about the tariffs, and you're the person to ask all this. Is the entire discussion on tariffs going to affect the debate or urgency on climate change? Is it going to, and how is it going to impact capital flows, growth, all that, exchange rates? Because, well, one of the things that will happen is there's an exchange rate offset, right? So the dollar appreciates, let's say, then the EME currencies depreciate. So that could be one mechanism, but the tariffs are going to have all these effects. Is there something you want to?
So I have a somewhat developed country centric version of this. So I know this is not directly applicable in smaller economies, but broadly speaking, till now, what we've seen in terms of what has happened to dollar with the tariff situation is actually somewhat counterintuitive. The typical trade story would have been that the dollar is going to appreciate, and what we're seeing is this kind of somewhat slow offloading of dollar portfolios, probably something which might be a somewhat good headwind in terms of imports for most developing economies. Similar thing in the UK, similar thing in the Euro area. And I think what is going to be different here in terms of, I think what would really play a role in terms of how the exchange rate dynamics go would be what would be critical there would be how integrated are you with world financial markets? And that's really something which is so understudied. I mean, most international finance people are only now starting to look at some of these exposures through the financial channel as opposed to the trade channel. The trade channel is studied to death, but actually, if you live in a country like the UK, you realize the trade exposure channel is tiny compared to the financial market exposure channel. So, for countries like, maybe it doesn't matter what necessarily only happens to the dollar from, say, Uganda's point of view, but I think what happens to the rupee or what happens to the yuan and all of those other things start to really play a role. And I'm just going to say, never I tried predicting exchange rates once, within seconds behind me, the pound crashed. I'm just not even doing that.
Didier, do you have some thoughts on the exchange rate?
Yeah, sure. As this is as Rwanda, it's kind of climate risk and physical hazard actually put pressure on our exchange rate because of the effect it has on productivity in the agriculture sector. So we have to import more foods, which is what happened actually in the last I think 2023 we had a flood, and after that, we had this really high exchange rate depreciation due to some of the imported inflation we had coming from food importation to actually supply the domestic market because of the wipe of most of some of the production. So. And the central bank actually, that's why the central bank now we kind of in all this projection and forecasting cycle do this survey to see if this risk, how high is it, and the probability for this to happen. So at least to help them to prepare and to have a sound policy response.
And you see, the interesting part was that as that was happening now with our neighbors, we were lucky we had maize production was high, good season. So it was moving, we were exporting, and the prices were rising also our end. So it's a whole regional thing. Yeah.
Diego, do you have any thoughts on the exchange rate?
One thing that I wanted to bring up is the discussion of the carbon border adjustment mechanism, because I'm curious to hear your perspective, because currently the way it's designed is that it doesn't have like any exceptions for developing countries, and that may be perceived as a bit unfair. And yeah, I was wondering how it's perceived, yeah, from your perspective, and yeah, how we could maybe improve the policy.
Yeah, it's a good question, and we've tried to analyze it. Once it came out, even for the CBAM and the EDRI, let's analyze this. For my country, the CBAM really, as of now, nothing. We don't have exports that fall in that category. So, but there are countries that way also, and I will tell you, it really just it's not a popular. It's not very popular. But on the other side, we sit and say, yeah, we're living, it's a global world we're living in, and we're trying to control these are policies to make sure. But I think the phasing out and the way they're going to be implemented matters a lot for our economies and understanding. I'll talk about EU data, which affects us as a country because it is crops, coffee, cocoa, the rest, and that one we've taken it head on. It's not popular still, but we know it has come and it will stay. We need the European market definitely. Whether it's people are told by going, they must find the market and going elsewhere. But we think it's the right thing to do. So what we've done is we've looked at some of the requirements, like mapping and registering farmers. It's good for us, reducing formality. We've seen that, and we're saying, okay, and the partners have come to help us do that. So we as other people are not coming in very fast, we're saying, no, we still did market this market and we're moving. And for me, that's about also all about climate action and the change, in terms of the going forward. The first actors are going to benefit, and it's a revolution. It's coming. So you have to prepare yourself to benefit from such things that come in terms of global policies. You can't stop them. And for me, in the coalition, is how we as member countries get ready for such. Phasing, yes, is good, but you have to get ready. If we have to meet the objectives, that's what we're about.
Yeah, India and the UK just signed a trade deal, but these are once CBAM applies, as he was saying,
Yeah.
in 27, then again, the whole calculation will need to be made again, so.
What about in India? How popular is CBAM?
I don't know about CBAM, but the trade deal was quite popular because the Scotch tariffs, those immediately go down to 70%, and over 10 years, those go down to 40%. So India is going to be exporting blended whiskey, and Scotch is an import into it. So Scotch becomes a capital good and a consumer good. So. Okay, well, we have about 12 minutes or 13 minutes for questions. So I'll open up the floor. Just please introduce yourself.
Hi, I'm Claire Barboni. I wanted to ask Sam, that this is maybe stretching the bounds a bit of climate and macro. We've kind of touched on related topics in the climate finance as well, but I think it's relevant. If you could say a little bit about, from your perspective, the ministry, but also with the coalition, how you're thinking about natural disaster or climate risk and insurance or reinsurance, sort of macro level risk transfer, and if that's something that's on the coalition's agenda and how you're thinking about that.
Yes, it is. It's on. We do have HP5 as more climate finance. Good enough is UK, one of the leading countries, UK, and they're doing a lot of work. I'll say that in terms of understanding. That's the first thing, and countries sharing with each other. I'll stop there. Thank you.
Any other questions here?
I think at different points, and I'm Lucy Hackett, I'm a PhD student at Berkeley. At different points, people have mentioned these kind of catastrophic tail risks, like the collapse of the Atlantic Ocean current or tipping points that could dramatically affect coffee's ability to live anywhere. Both the probability of those risks is difficult to model, and then I imagine the modeling of the consequences like that comes with a ton of challenges. Are those kinds of risks even worth thinking about from y'all's perspective, or should we be focusing on the more systematic advance of risk with increasing temperatures?
Diego, I think you're the person that's addressed to.
I think it's definitely important to think about these things. Historically, fortunately, we haven't experienced any global tipping points, right? We had local tipping points. So from the analysis I showed, this wouldn't incorporate these risks, but absolutely, I think it's important to think about these, especially if you talk to climate scientists. Obviously there is different opinions, but some of them may view them as more probable than others. And you're right, there's just tremendous uncertainty about these things occurring, and then also the economic consequences. But that shouldn't deter us, I think, because after all, I think most of us are risk averse. And if we convert this to sort of a certainty equivalent, the numbers are still relevant, and we should take them seriously.
So, Sam, do you want to address this question about probabilities of these?
No.
Didier, are there any thoughts?
Yeah, sure. On the probability, and I think for Rwanda, we look more on this systemic one, which occur and which has the high probability of occurring, which we have kind of 2 to 3 which are more likely to happen. So we have a kind of which we call fiscal risk register, which we use in assessing climate risk and effect on long-term macro variables. So we list them, and then we have kind of probability, but most of it is by probability to occur, which is for us is flood, drought for agriculture mostly. So this is what I can say about how we look at this.
Yeah, sure.
Yeah, so just sort of related to that point, so what role do you see for more sort of interdisciplinary work between macro econ research in climate and climate science itself? 2 things sort of struck me today. One was Ben Olken's point about the sort of cyclical effects of El Nino and how to extrapolate that from the model, and then also the point about oceans heating at different rates compared to land. And it seems to me that it is important that we do more cross-disciplinary work. And so just your thoughts on that, on whether there are examples of that. Is it growing? And if it isn't growing, should it be growing? And if it should be growing, how should IGC sort of take a more active role in encouraging that? Lots of little questions.
Yeah,
sure.
So I think that would be a huge public service if IGC took a role in that. I mean, I can't tell you how many times I've tried to talk to scientists and water engineers and others of the like. And, this is something that being at a public institution is easier to do because everyone's willing to talk to you, but still you're rarely ever speaking the same language, where I think actually, even if you read the articles that they write and we write, the level of evidence is different across the two. How much breadth we want to cover versus how much they are willing to cover is also very different. So I think if you were able to link us up with people who we were able to talk to, I think that would be fantastic. I mean, that would be a really big public service.
For me, yeah, well, it's a great question, and I was reflecting on it this morning. We run a risk of, because you said it, of underestimating the impact or the value that we would attach to things that we're doing. Because really bring the scientists and us, the macroeconomists, statisticians together. There's a way they understand things. For example, I was looking at we presented at AGF at the value of investing in forestry for the macroeconomic objectives, production, GDP, and what we're looking at is just extent, covering more forest, having there. But for a scientist, he'll look much more and look at the services even that forest is using, which is hard to get in terms of numbers and values. The point I'm making is that there's great need for us to work together and be able to reduce the gap in terms of estimates and expectations. Yes, civil service is good, but it's going to be hard through civil, like for my country, Uganda, Ministry of Water and Environment and what. We do natural capital accounting together, yes, we have a technical working group. But the academicians also from the academic world, for me, I think strongly that should come from there. How you, if we're economists, macroeconomists, how we're relating with the scientists themselves, how we're taking the numbers, how critiquing them, some of them are really overly. So do we have that? How do we bring us the discussion for us to come together as critical point? Thank you.
And one of the things is that I think research capacity in central banks generally tends to be much better than treasuries. Treasuries have in-house teams and they, don't really, at least that's my experience. And I think where IGC can really make a dent is by kind of reaching out to the treasury, reaching out to finance ministries, because I think that's where a lot of the capacity for subsidies and things like that, for setting up carbon markets, for amending laws is needed. And I think that outreach needs to be, I know you're already doing it in a big way, but somehow it needs to be more impactful and lead more results. But that would be a good outcome if the IGC effort leads to that.
The other thing within academia, I feel like the incentives are not great to do interdisciplinary work because I'm a assistant professor on tenure track.
Yeah.
And I don't think it will be rewarded as highly, especially if it's published in journals that people are not familiar with in econ. So that's just an incentive structure that maybe deters some of the interdisciplinary work on top of sort of the communication issues that you mentioned. I think we can all work on, because I agree, great to have more such work.
And partly because it's looked at as though somehow you're going to the lowest common denominator, as opposed to understanding that you're actually trying to do something that's more than the sum of its parts.
Any other questions? Yes, please.
Hi, I'm Eddie. I'm a PhD student here. This question is for Sam, but also to all of you. What do you think policy coordination across sectors, like what's your view on policy coordination across sectors when some policy actions could have cross-sector impacts, like for example, electrifying transport could have important impacts on exchange rates, but also it could really affect the carbon mitigation pathways that Uganda and other African countries might achieve.
Yeah, very cool. I totally agree. And for me, user report it is this is a social, political, economy wide. So what you do, I'll give you a good example, like the one you put, having e-vehicles. We are doing that. We're trying to have an industry produce vehicles, e-vehicle, but we know we're investing in fossil fuels at some point. So how do we reduce this and put it together? How do our road network is not yet as good enough. We don't have the points themselves, the power where to charge from. So it's the whole of government. This way, I think this is what you're asking about, and it's not easy to bring it to work to think about it that way, but that's the ideal situation where we should go to, that you do something that's going to affect the whole chain, the whole economy.
Okay, I think we're more or less, we're a couple of minutes before time, but if there are no further questions, I think we'll wrap up. Is that yes? Okay. So let me thank Swati, Diego, Sam, and Didier from Rwanda, Uganda, Switzerland. It's a truly international panel. Thank you to Shahid and the IGC team and you for all your organization. Thank you.
Thank you.
Today, guys, we'll take a 30-minute break and we'll be back for the last two presentations of environment week.
Really appreciate you.
Thank you.
I don't think
Not even a seat.
Yeah, sounds good.
Yeah, they had a few plans. Yeah. Just so hopeful for the Easement.
Okay, thanks everyone for sticking around. So we're gonna have two 30-minute presentations. Feel free to ask questions for that again. And I'm gonna start with Ruozi.
Thank you, everyone. I want to express thanks again for sticking around for the end of marathon. And then today I'm going to present a project about environmental regulation coordination. I will define a little bit later about what do I mean by coordination. And I'm Ruozi, by the way, I'm an economist at Development Research Group of the World Bank. And this is a co-authored work with my classmate, Xiong Fei from University of International Business and Economics. So we have, throughout the conference, I've heard a lot, to make impact on the climate, we need to get all OECD and non-OECD countries involved, and then to get everybody on board to make the impact. But the core problem of climate change is also that we have a collective action problem. So a lot of the cost of abatement is at very local level, but the emission benefits are actually at the global level. So how we can get everybody's incentive aligned is very important to understand. So that's why a lot of unilateral policies, even like EU ETS, they probably will create leakage across the globe if people are not on board, or even may not mitigate emissions as much as we expect. And then to really mitigate the leakage, we need coordination. But then to back up a little bit before I understand the coordination, we need to really think about what are the incentives or what are the regulators thinking from the developing countries' point of view. And especially we're thinking we want to get non-OECD countries to get on board. We need to think about, even before getting them on board voluntarily, whether they are also doing something to mitigate the emissions at the local level. So essentially, the project is trying to understand, the bigger question here is trying to understand foreign climate policies can already trigger some domestic policy responses in another country context. So more specifically, in this paper, I'm going to look at how the impact of EU ETS affect the local environmental regulations in China. So by local environmental regulations, I don't really mean the design of the policy itself, because it doesn't really change that frequently to really allow me to understand the changes in the regulation itself. But here I'm going to focus more on the enforcement of regulations, especially those enforcement is going to be at a very local level. And it's also where the local pollution and local emissions are from. So that's why it's also important to understand the local perspective. So in terms of the design, just a preview of the project, I'm going to use as you can imagine, a shift share design. So the shift is going to come from the carbon burden shock from the EU ETS side, and the share is going to come from the local trade exposure from Chinese firms' perspective. And here I will specifically look into both export and import from Chinese firms' perspective to really understand how that trigger different responses in terms of the local environmental regulations. I'm going to combine data both from EU side, trade, and then the Chinese environmental outcome side. So I will talk more about the data, but on the high level, we'll have carbon prices and also multi-regional IO table in order to incorporate the emissions from the whole production network. And we also have Chinese custom data to understand the trade exposure and trade linkage. And eventually, we also have the enforcement data, which is show up in the environmental penalties at the local level, and also the overall outcomes in terms of pollution. And what do we find? First of all, just from the first stage trade and whether EU ETS does have an impact on trade to China. This is the first thing we want to understand. If it doesn't really have any impact, then we wouldn't expect any policy response here. So we do find there is an impact from the EU ETS in terms of the trade from Chinese firms' perspective. From export side, we see that higher EU ETS, or basically higher carbon price in EU, leads to more export from Chinese firms. So, and this is mostly driven by the quantity change rather than the price. So intuitively, this is saying that when exporting firms, or like when EU firms are facing higher carbon prices, basically higher burden from carbon policies, the counterpart, Chinese exporting firms in the same industry, they gain relatively more advantage and they are able to export more. And they are exporting more in terms of quantity, not really the price. And we also look at the importing perspective from Chinese firms. So we also see if the Chinese firm is importing from EU firm that is facing higher carbon burden, we find that their importing value also increases. But this kind of increases is mostly driven by the price change, like price is increasing rather than the quantity. So it's also this is actually, there's some asymmetry here between trade and between export and import. And we can see the import here is a little bit less elastic, or there's like a lower substitution between EU import versus some other countries, so that we actually see a price increase for the import, but we don't really see like countries or like Chinese firms trying to substitute with other imports from elsewhere. So this is the first stage, and how does this trade linkage, trade impact translate into the regulations and environmental outcomes at local level in China? So here we establish this linkage here that we also look at from both export and import perspective. So if you look at in terms of export perspective, when the exporting firms in China face higher exposure to EU carbon costs, the exposure basically means their counterpart EU firms in the Europe actually facing higher carbon costs. We found that this triggers stricter local enforcement regulations in China. And on the opposite, for a Chinese firm who face import carbon exposure, we see a more lenient local enforcement in China. And based on these results, we'll have a little bit more discussion towards what does this mean for local regulators' objective function? How do we understand the objective function from this strategic or targeted enforcement at a very local level? And hopefully we'll have some policy implications for the unilateral policies which are very common now to deal with carbon emissions.
You might get to this later, so feel free to postpone, but are you thinking about mechanisms as well? Like I can think of more intuitive mechanisms on the export side in terms of just producing more, there's more pollution, there's more local revenue. And on the import side, so you're going to speak to that as well?
Yes, so I was speaking a little bit more towards that, but on high level, from the importing firms, you're basically increasing their input costs. So we actually do see the production of the importing firms reduce, and that's why from a local government perspective, you're actually facing a negative economic shock. So that's why they're giving more leniency in terms of the enforcement of local regulations. Right. So I will just go quick on the literature. So where are these things like a very emerging literature on carbon, like especially environmental policy coordination? So on one side, we really need everyone to really coordinate and get on board. On the other side, we want to understand how to get them on board. And then how this, like Alan Shell had a paper on food policy, but also other policies, how we can really trigger coordination across countries. And here we want to look at in a voluntary way through trade, how does one country's environmental or carbon policy affect the enforcement actually at a very local level in China. And also this speaks to the environment and the trade literature, especially on carbon leakage here. And lastly, there's also a growing literature on environmental regulation enforcement at local level. This is especially important for developing countries where there can be relatively weak capacity. Maybe China is not a really good example here, but it's very important to really understand what the difference between the design of the policy versus the actual implementation of the policy, and how that on the ground affect the environmental outcomes. All right, so I don't think I should speak too much on the context of EU carbon policy, but essentially we are basically making use of the variation in the carbon prices here, and then we construct sector, country, and year level carbon cost exposure from EU firms, and then use that as the shift to construct the shift share. I'll talk more about how I construct the shift share later on, but just to give you a sense, we're looking at the period from 2005 to 2020 here. And then there are 3 phases throughout the period, and more and more countries entered the EU ETS system. So that's why there are also like a country variation in terms of carbon price exposure here across time. And more on the environmental regulation in China's side. So there are 2 major kind of regulations. More is like a command and control policy. The other one is more like a market-based instrument. So we have both emission standard as well as emission taxation. But both of this, and also the design of policy are at a relatively central level. So it's even at the provincial level, but not really at the local level. But on the opposite, the enforcement of these policies are really at the local level. Because, for example, for the emission standards, we know in the US, for example, there was a very specific guideline to tell inspectors that, oh, you need to visit the factory 4 times a year. And it's very particular, very specific. But in China, as well as a lot of other developing countries, you don't really have this kind of very strong, clear guideline in terms of how to enforce the policies. So the enforcement actually can vary a lot at the local level and vary a lot in terms of their effectiveness. And there also are well-documented literature trying to talk about how local regulators strategically respond to the emission standards and how they can actually evade or go around the regulations and do not really generate environmental benefits. And lastly, since the environmental regulations I talk about or strategic responses I'm talking about here is mostly through the enforcement, I'll talk a little bit more about enforcement here. So the enforcement here, I mean, whenever the local inspectors visit a factory and found some violations, if they decided to issue some penalties, they can do that through so-called administrative penalties. So they can either issue fines or even have require the factory to temporarily shut down or sometimes even permanently shut down. So this is the local regulators tool in order to really enforce the emission standards. And the figure here basically shows the environmental penalty issued from throughout the study period from 2020. And if you know a little bit context of China, you'll see the trend here really picked up after 2014, because that's when the government's really interested or really trying to enforce the environmental regulations and to do something against the pollution. So that's why you started to see more and more penalties after that. And I said that, so we put together these 3 kind of high-level data here. The first one is carbon cost in Europe. And here we collect both carbon prices as well as the global input and output table in order to take into whole emissions from the production network into account. We also put together transactional level export-import data from China as well. Here we only get data from 2013, and we are working on the process to get data more after 2013. And lastly, we got this universe of penalty data, this administrative penalty data issued by the government or local governments here. So that includes fines and other enforcement activities. This allows us to really get a sense of how the stringency of enforcement is at the very local level. And we also collect a bunch of pollution outcomes at the very local level. And lastly, I will touch a little bit this as well. So every 5 years, the governments announce the 5-year plan, and they have a very official government documents talking about different targets or important priority areas they are trying to focus on in the next 5 years. And we collect the documents and trying to look for things related to air pollution and put together this text-based regulation stringency. This is another way to really understand whether it's really the stringency that is changing here.
Can I just ask whether the sort of smaller literature on endogenous monitoring is relevant for how you're measuring outcomes here?
Yes, totally. But that is more from how you target particular firms in order to make the emission look better. And here I'm less about that. I'm more looking at how this economic shock from trade.
Oh, absolutely. I just mean in terms of measurement. Not
exactly. Yeah. So basically, a lot of them are using very similar data. So like a penalty data, but then they're more looking at, for example, how your location towards the emission monitors affecting the chance of you being targeted. Yeah, so the outcomes are very similar.
Right, but your measurement of environmental outcomes wouldn't be subject to these
I
sorts of.
see. Yeah, I see. Yeah, totally. So that's why I will, so for, especially for the PM, we are basically use the satellite-based PM rather than like the pollution outcome reported by the government. But I would say, and also it's documented in the literature that after 2014, the pollution outcomes are more credible. Yeah, especially there are like a lot of continuous monitoring systems that were governed by the central government. So it's really, there was less room for local regulators to really manipulate. Yeah. And also another difference is that here, because I also look at the penalty data. So this is like real activities rather than like some fake way to really avoid the emission readings. So these are real costs for by the firms. A little more on the shift share construction. So in the shift here, it's very standard construction following Joe Shapiro's Trade and Environment handbook. So we basically use the inverse Liang-Tick matrix to incorporate the whole production network emissions into the carbon burden measurement. And then we have, so the I here is the inverse Liang-Tick matrix, and we are integrating this over the whole production network. That is in the input-output table to a particular sector particular sector K at the country J level. And this is the annual level measurement as well. And E here is the emission intensity, and tau here is the carbon price. And then the shift share. So we have the shift here, and then the share is basically constructed from the trade exposure at Chinese city sector level, depending on our outcome variables. Because for the outcome variables, sometimes we have CDC and year T level outcome. Sometimes we have CDC, sector K, and year T level. So that's why we construct these two kind of shift share instruments at these two levels here. But essentially, they are very similar. So what they are measuring here, for example, for this measure here, we are basically measuring how important is export from EU or importing from EU is important to a particular CDC in the sector K here in a particular year. Sorry, this share is not a particular year. The share is the pre-ETS share. So we are using the 2004 trade exposure as the share here.
Version of your overall research question, but how should we think about complementarity or substitution in environmental policy across cities? Is it the case that there's trade linkages across cities, or firms are substituting, or policymakers are coordinating?
I see. Here I'm treating each city level regulator as an independent decision maker, because what they care is also just about local pollution. But of course, from economic point of view, they care about GDP, and then the GDP may have some interaction between different cities. But here, because the exposure here I'm constructing is basically from a firm in CDC towards the European firms. It's not really like exposure, or I'm not really looking at firms' relationship across, like within a city or across cities. So I'm not really taking into consideration of that. But actually in the follow-up work, we are trying to also look at the like upward and forward linkage of the Chinese firms here and how they're affected as well. So you can also try to see how this carbon costs from EU firms propagate across the production network in China as well. But that's not focus of the work, because it's more on the production side than the regulation side. That is the focus of the paper. Yeah. So main specification. So we have two different levels of regressions here. The first one is more at the city year level. So if we think about, let's say, air pollution, we can only do it at city year level rather than city sector year level for those kind of outcomes. But then for the trade outcomes, we can also do it at the city sector year level. That's why we have the second specification. And it's a very straightforward specification. Like at city year level, we control for bench of city year level control, and also city at year fixed effects. And for the city sector year level results, we have city year or sector year fixed effects to control for either sector level, sector specific demand, or shock and also city-specific development trend. So we first look at the impact on the trade. As I mentioned, we throughout all regressions, we'll see we have two separate measures here. One is exposure to export, the other one is exposure to import. So the export exposure basically means for a firm in China that is exporting to EU, I'm calculating how the EU counterpart's carbon burden is. And the import exposure here is basically for a firm in China who's importing from EU. I'm calculating how the firms that are exporting to China, how they are facing their carbon costs. And then we see first, if for a firm in China that export to EU, if their EU counterparts face relatively higher carbon cost, we see the Chinese firms actually export more. And the 1% increase in the export exposure increases exporting value from a Chinese firm by around 0.08%. But this kind of value increase is mostly driven by the quantity rather than the price. So this is saying that, like, if EU counterpart is reducing their sales, the Chinese firms that will step in, but they cannot really raise the price, but mostly by raising the quantities. If we look at the import side, when the Chinese firms is facing higher import carbon exposure, we also see that their import value increases. Remember, these are the Chinese firms who are importing from EU. These are like increases in their basically input costs. We see the input cost increases, and this kind of increase is mostly driven by the price, really not the quantity. So you can see there is like very little elasticity of substitution here, because even if the import is getting relatively more expensive, but we don't really see a drop in quantity. It's mostly directly increasing the prices here. And then we look at, so since we established the first stage, there is like an impact on the trade dynamic due to the higher carbon cost burden faced by the EU firms. Now we look at how that translates into the environmental regulations. So here we look at a number of penalties here issued by the local governments. We look at the total penalty here and also the average penalty here. So you can see various things. So where also like oppositely, for Chinese firms who are facing higher export exposure, they are actually facing higher penalties as well. And also the total penalty amount is also increasing. But this kind of penalty is not really due to like for each firm, they are getting more penalty, but it's more like extensive margins. So more and more penalties are issued. It's not like every penalty is larger. And on the opposite, for a Chinese firm who is facing higher import exposure, we see a more lenient enforcement in terms of the penalty. So basically you see they face relatively lower penalties, and then the total penalty amount is also reducing. And this is also driven by the extensive margin here, rather than like you're issuing lower fine, but you're also issuing, you're not on average issuing lower amount of fine, but you're really issuing less fine to less firms. And how does this translate to environmental outcomes? So remember, so we also split this into export versus import exposure. Remember, so for the export, we see an increase in the value or in the production here. But throughout the different pollutants, we actually do not really see much pollution changes. So this is the result of two things. So first, we see a production increase because those firms are able to export more. If they have the same emission intensity, let's say, we should see an increase in pollution. But at the same time, they also face more stringent environmental regulations, more stringent enforcement. So because of that, their emission intensity also drops. So that's why, on average, in general, we actually do not see much emission change or pollution change this is at a city year level. And from the import point of view, remember we see that import is also decreasing. So this is again, like this is because the firms are importing more expensive inputs. That's why they have to drop their production. And then we actually see that through the carbon emission point of view, firms are dropping their carbon emissions, but they actually do not really drop their pollution here. So also, again, like this is a result of two factors here. Firms are reducing their the production, but at the same time, they face relatively less stringent enforcement. That's why their overall pollution actually do not change as well. Yeah.
Do you see any evidence of sort of the Chinese firms swapping out their inputs using domestically sourced ones or unregulated sources?
Yeah, that's actually very similar to
I guess, yeah.
in a sense that it's going to be another paper because
Okay.
this is mostly focusing on the environmental regulation responses rather than like firms' production responses. But but it's also very interesting to see whether firms are substituting, you know, between the EU and rest of the world or even domestic. Right, we also did a bunch of robustness check. I'm going to skip here since we only have 5 minutes, but essentially we tried different fixed effects. We tried to adding more lags here, and also we tried to actually the carbon cost put together by Diego Kanzik, who's just talked here, that if you don't really believe the carbon price is exogenous, then we also use the carbon price surprise as the alternative shift here to make it more exogenous. All right, so after we see this kind of policy responses, what do we learn here? So here I want to discuss a little bit more in terms of the policy response, where does the policy response come from? So first, one question people may get is like whether we see it's just mechanical change or it's really some strategic responses. So in this table, what I show is not just like the total penalty changes, but it's really penalty intensity. So it basically means given the same amount of emission or pollution you're generating, what is the penalty you're facing as a firm here? And we see similar trend here, even though like the export exposure is no longer significant, but I will show you a little bit more later, like why this is not significant anymore. But we do see it for the import, they're still facing relatively more lenient enforcement. Now we basically look at the interaction between the exposure, but also the GDP here. So the hypothesis here is that for a relatively richer city, they are able to enforce more stringent regulations when they care more about either because they care more about air pollution or because the cost of abatement for the firms is relatively lower. So we want to test this hypothesis here. That's why we are having this interaction term between the exposure and then the GDP level. Here, the GDP, we also still use the 2004 GDP, and then we basically use above median or below median as the indicator.
How is the regulators financed? Is it based off, say, a local revenue base, or is it a national revenue base? Because that could be another reason why you would expect, you know, high GDP areas are more able to like keep monitoring up, even if some industry.
Right. I would say so the fiscal system is basically split. So they have some revenue from local government, but also some revenue from central government. Especially after 2014, where the air pollution was an important issue, is that all these regulators are directly reporting to the central government, like upper government. So they are getting more resources from upper government. So I don't think the resource is something that is playing a role here. It's more about what's their trade-off between economic and the environment.
Is that essentially a sort of transmission mechanism from the buyer's interest, such as an insistence on greater levels of compliance, which is teasing out issues of pollution that are leading to fines and court cases, or maybe other kinds of pressures from like large global buyers, like Nike or Adidas, insisting that the municipality takes water pollution. I see. Is there a mechanism like that that could be applied?
I have to dig in more in terms of heterogeneity here, because here I'm looking at the very sector like city year level. So you can have both small buyers and big buyers. I'm not sure how much is dominated by a big buyer, since this is like a sector level result, but we can dig in more in terms of how big the buyer or market power of buyer is. Yeah. But just a quick word on here, I think so the first two columns, first two rows are talking about if you have relatively low GDP, then you don't really do much if you have a relatively positive economic shock. Basically means your exporting firms actually gain an advantage. You don't really enforce more stringent regulations, but you only do that if you get richer, if you're a relatively high income city. But instantly, if you face negative shock as a low income, relatively low income city, you become more lenient in terms of enforcement. But then for high income cities, you stop doing that anymore. So the takeaway here is that for the development growth is actually still a key for really enforcing the environmental regulations here. So you're able to do that when you get richer. Lastly, sorry, I only have 1 minute. Lastly, just a little bit more discussion in terms of what is really the objective function of the local regulator here. Here, I just put together a very simple conceptual framework. So there are two candidates here. So the first one is more about weighted average, like regulators care about economics, but also care about environment, and then eventually this is weighted average. So the 1 and 2 here basically is the tradable sectors versus non-tradable sectors. So the reason why I look at these two sectors is because I'm able to look at the outcomes through the two sectors to really disentangle whether it's more like the 1 or more like a 2. So the first one is weighted average between the overall GDP from both tradable and non-tradable sectors minus the emissions cost. And the second one is more like I care only about GDP, but then there's the emission cap I care. And above, if the emission is below this cap, I stop caring anymore. So we want to see whether it's really, the objective is more like the first function or the second function. And then the optimization of these two kind of objective functions is very different. So the first one is really about, so the tradable sectors and non-tradable sectors, they are not really affecting each other. So you just want to equalize the marginal cost of abatement to the benefits of emissions for each sector. But then for the emission cap, you actually do see this kind of interaction between tradable and non-tradable sectors. That's why we look at how this results translated into both tradable and non-tradable sectors. We see before 2016, we don't really see much things happening in the non-tradable sectors. That means the regulators are more like a weighted average. Sorry, 30 seconds. The regulators are more like caring about the weighted average between environment and the economic growth. But after 2016, you started to see something in the non-tradable sector. So that means the regulators started to care about the cap here, emission cap here. And why I use the 2016 here is actually the time when the central government decided to put whether you meet emission target into the promotion system of the local regulators. So that's why you also see this shift in their objective function. So I'm gonna wrap up here. So yeah, maybe a quick word, we do see some local strategic responses from the regulators, and we do think it's important to think about the incentive or objective function from the local enforcement point of view to really understand the whole spillover from the carbon policies. Yeah, thank you very much.
So thank you very much for staying until the end. I was not expecting a full room. And thank you very much to the organizers for having me. So I'm Jeanne Astier, I'm a PhD student at Crest. And let me just say that I'm not on the market this year, but I will be next year. So any idea you might have, I have 1 whole year to implement. So all comments are very much welcome. This project is about the impact of climate change on transportation and trade through the channel of climate-induced weather shocks that can create congestion in ports. So every time I present, I try to find the most recent piece of news about a port being disrupted by bad weather. So this is from earlier this month, where the port of Fremantle in Australia was disrupted because of bad weather. So you might think on this as like a very localized events. In fact, it can have much bigger consequence. First, because maritime freight is super important for international trade. It accounts about for 80% of internationally traded goods. And those weather events that are impacting port, they are frequent. It's again the port of Fremantle being impacted. And so they induce non-operability days for the ports during which their operation are either partially or completely disrupted. Why? Because, for instance, when you have very strong wind, the cranes that are supposed to unload and reload the ships, they cannot work. Or when you have too high waves, the platforms, they are flooded and so cannot operate. And so the ships, they cannot be unloaded and reloaded in the port, so they end up being queuing in the ports. This creates congestion that's dramatically increasing shipping costs, as shown by Boccaccio and Kelsey. In addition, the way shipping works is really in a network fashion. That is to say, ports, they are connected to each other, and some ports play the role of a hub. So when you have one port being disrupted, it can actually, the effect can propagate to many other ports, and it can lead to congestion to related ports. So from one local event, you can have a potential ripple effect with global consequences. And finally, those weather conditions that are impacting ports, they are expected to become worse with climate change and sea level rise, as shown by the IPCC. So that's why the objective of this project is to study the global impacts of climate change on ports in the context of the shipping network, allowing for propagation of shocks. So to do so, I first combine detailed shipping and weather data to estimate empirically how weather shocks can affect port efficiency and hence raise transportation costs. And I then include this mechanism into a structural model of international trade with a shipping network that's featuring endogenous port congestion that would allow for propagation across ports. And so with this model, I can estimate counterfactual scenarios. So first, I can just play with the model to contrast the effects of a port's own local weather on its efficiency and the effects of indirect shocks coming from other ports in the network. And the ultimate goal is to use projections of how weather at sea will evolve with climate change to be able to predict the global effects and heterogeneous spatial distribution. So why does it matter to look at shipping? First, looking at the effects of climate change on transportation costs, I think it speaks to the literature that's looking at trade as a potential mitigation factor for climate change impacting productivities. Because if trade can be a mitigation factor, well, if trade itself is made more expensive because of climate change, then it might affect its ability to be a mitigation factor. And also there is a policy implication in terms of infrastructure investment, because there are some infrastructures you can build to protect ports from bad weather, like seawalls or stuff like that. Where you should locate them optimally is not so obvious when you have some spillovers, because it's not necessarily on the ports that are most directly exposed to bad weather condition. It also depends on their position in the network. So this project is speaking to trade literatures as trying to include transportation in the model. So this literature is originally trying to model transportation on land, like highways or railroads. And there is a part of literature that's going towards modeling shipping transportation. I try to go further into that direction and really modeling specificities of the shipping network as opposed to land transportation network. I will present to you this data I'm using, this shipping AIS data that's increasingly used. And so I speak also to the environmental literature that's trying to quantify impact of climate change and weather shocks. So I try to uncover a new channel that would be the impacts of weather shocks on transportation, and specifically the impact of weather shocks happening on sea. So not only in weather shocks happening at land. And finally, so there is a small literature looking directly at the impact of weather on ports, but that's very reduced form. So I tried to go further and including this model, this mechanism into a structural model to estimate the global effects. So I'll be briefly presenting the data and some reduced form evidence, the model, if there is time estimation of structural parameters, counterfactuals, and then I will try to present to you what I'm currently working on, which is work in progress, but that I hope to develop. So the shipping data I'm using, it's called automatic identification system data. So the ships, they have transponders that send their exact position at every point in time. And so from this, I get a data set of port calls for container ships. That is to say, every time a container ship enters a port or leaves a port, I get the exact position and the exact time when this happened. So I have this for the whole universe of container ships for about 1,700 ports from 2015 to 2023. And so from this, I can build measure of how efficient a port is. So the main measure is port dwell time. It's how long the ships spend in the port to be unloaded and reloaded again. So of course, the quickest it is for a ship to go in a port, the less costly it is, so the more efficient the port is. I can also compute just the number of ships that are entering in the port every day, the number of entering calls. And I match these port efficiency measures with weather data. So ports can be affected by a wide range of weather outcomes, by high waves, by strong wind, by storm surge, precipitation. I'm focusing on wave heights as a sort of proxy for all these aspects of weather that are very correlated. So I'm taking average daily wave height from ER5 dataset that I'm matching to the port's location. So that then I'm looking at the direct effects of a port's weather on its efficiency. So for a port I on a day T, I look at its efficiency, so either measured by its dwell time or by the number of entering call, and I regress it just on wave height in this port with a bunch of fixed effects. And I find that when there is higher wave heights, it decreases the port efficiency in the sense that ships, they have to spend longer in the port, and there are less ships that are able to come in the port. Yes.
Do you have a sense of how correlated the wave shocks are across space and whether climate change is changing that relationship at all?
Yeah, so of course there is a spatial correlation. You have some, I will show you a map in the counterfactual. You have some zones with worse weather than others, but there is also a lot of heterogeneity at a very local level, because how ports are affected, it also depends on their very local characteristics. For instance, a port that's directly at the ocean is going to suffer way more from high waves. At the port which is inside a harbor is going to be much more protected. Also, just if you've been building seawalls, you're going to be much more protected. So there is spatial correlation, of course, on a global scale, but also lots of heterogeneity at the very local level. Yes, Carl.
Can you give any sense of how much of the just general uncertainty in how ports arrive and how ships arrive to port is just absorbed by this kind of environmental uncertainty, or is it, is there just a lot of general uncertainty in sort of how many ships will be around?
So I'm looking here at a specific case of container ships for which there is not so much uncertainty because they are not super flexible. They really operate like buses. That is to say, they have what's called a service, so a succession of ports that are supposed to go through, and at each port, like a station, containers can go out or go up. So they cannot really deviate and choose to go to another port last minute. So the flexibility they have is that they can slow down on the routes to arrive a bit later at the port. They can change the schedule, but not so much the trajectory. And so what I can see is that this effect of wave height on port efficiency is mostly driven by extreme events. It's really when wave height is higher than 2 meters, 2.5 meters, which corresponds to 5.1% of wave heights, that's I find the biggest effect. Yes.
Just on timing, so is the unit of time a day?
Yeah,
and do we expect that any disruption is largely resolved within a day? Or could there be temporal spillovers?
So here this is a day, but there can definitely be temporal spillovers. So I ran an event study. So looking, well, here this is when weather is greater than the 99th percentile. I also have its weather greater, wave height greater than 2 meters. I can see that so this is the timing, this is days. This is the day where wave height is very high. It increases dwell time not only on this day, but even before. And for the number of calls for the traffic, it reduces traffic on this very day, before and after. And then there is a slight catch-up, but not enough to compensate. So yes, indeed, the effect is a bit lasting over the days. And this is essentially because congestion. Even when the weather is good again, you still have ships that have been waiting that you need to process. So this shows that port efficiency can be impacted by local weather. What I show also is that there can be some spillovers, and the efficiency of a port can be affected by weather in other ports. So to do so, I compute the downstream wave height of a port, which is just a weighted average of wave heights in downstream ports. So from a port's point of view, a downstream port is where the ships go after they leave my ports. And an upstream port is where the ships come from when they go to my ports. And so from the shipping data, I can see the exact trajectory of ships and which port they go through. And so I can build indicators of how important a downstream port is for an upstream port, looking at the flows. And so that I can regress the efficiency of a port on its own wave height, downstream wave height, and upstream wave height. And what I find is that, so as we already know, a port efficiency is impacted by local wave height, but it also seems that what's happening in downstream ports is impacting the effects of an upstream port in the same direction.
So why? Like, if you look at these ports, like ships hang out at sea all the time.
Yes, so
like,
yeah, so first, indeed, this is a lower bound of the effects because ships hang up at sea. That is to say, so no, first, let me answer in the other way around. Why? My intuition is that because the ships that are in the ports, they see that the next port is being disrupted, they might decide to stay a bit earlier. They kind of anticipate and adapt their behavior.
Or the port can't just kick them out.
Maybe, but I mean, I still find that,
whatever.
I mean, another mechanism, I mean, what they do in addition is that they slow down on the routes between the ports. This I can see in the data. I cannot include this in this effect, but I see that when you have bad weather in a port, it increases the time that ships spend before to go to the ports on the sea. So it means all my effects I kind of lower bound.
Yeah. It's kind of related, but this is what you're defining as downstream here is kind of the first order link. So
Yes.
I wonder if there's some variation in kind of second order that you can skip a port or something like this, and whether
Yes,
that can give.
yes. So I've been working on this for the past week, but I could not get like super strong results. But indeed, I can. So I'm just looking at the direct downstream and upstream, but then can go further into like the all the ports before and see like an effect that's kind of depending with the distance to the ports. Yeah.
No question. So are ports, forgive my ignorance, are they scheduled the way that like airports are scheduled, or is it kind of just like whenever ships, they don't really know who's showing up, and whenever the ships come, they kind of just dock or whatever? Because like this, the disruption effect are going to be much larger if there's sort of like tight schedules.
Yes, no, there is a schedule. There is actually a paper by Brancaccio, Calopsidi, and Papageorgiou, who's really looking like very precisely in, it's really like micro ports basically, who's really modeling exactly the queuing mechanism of the ports and how it works. So, I mean, it's supposed to be exactly scheduled, but I mean, you have lots, it's super frequent that ships are late and everything. So, I mean, disruptions end up happening.
Is there like a penalty if you miss your slot? I mean, how does a contract of unloading a ship work?
So what's difficult is that it's really port specific. Like there is no like unified jurisdiction of ports over the world. Even within the countries, I've been in contact with French ports. Each port just fixes its tariff as it wants. So some have like, most of them have like the longer you stay in the ports, the more you pay. The more you pay. If you arrive late, sometimes you pay, sometimes not. So it really depends.
And so the Calopsidi paper is just, which I've seen that paper, that's just bulk cargo. Is yours?
Yes, exactly.
Is yours also container or everything or what?
No, mine is only container. So it's true that, yeah, what she shows does not strictly apply, but I assume, I mean, like, I rely on this as like, this should be the same mechanism, but I'm not looking as precisely at this mechanism. It's a bit more back. So, yes.
Sorry, somehow related. Do you have any idea about the distance between ports? Because I'm thinking, you know, maybe you can have two ports, like the starting point and destination, which there are no waves, but then on the road, there might be like very, I don't know, bad weather, and maybe that would have an effect.
Yes, so indeed, this is how I have started the project, was looking at the weather, like in the middle of the sea, like when there is a storm on the ship's way, what's happening. It has an effect, it increases a bit the shipping time, but much less because when there is a storm at sea or bad weather, the ships, they can just go around it and at the end. The problem with ports is that they have to go to this precise location. And in addition, since there is infrastructure they may use, it creates congestion. So it's much, I mean, the magnitude of the effect is much more important when it's bad weather at ports than in the middle of the sea. So from this reduce from evidence, I try to build a model to understand more precisely how the spillovers can happen and to estimate the global effect and the distribution. So I rely on Allen and Akolakis 2022 spatial model with optimal route choice, and which I adapt to a shipping setting. So I just consider a set of ports, and I group with each port like the area around the port. So basically all the people that are supposed to use this port to ship goods. Yes?
Who pays for the cost of the time spent, the excess time spent on the port?
Yes, I'm sorry, I didn't hear the question.
Who pays for the cost of the ship during that excess time at the port?
The thing there is almost a perfect path through from the shipping companies to the companies who pay to have their ship carried. So in the end, it's gonna fall on the like exporting companies. And so the ports, they are connected by a transportation network that's represented by a matrix of links cost. So Tij is just the cost of directly taking a ship from I to J. It's an iceberg trade cost, but the network is very sparse and you don't have a ship going between every pair of ports. So when there is no direct connection, this Tij is going to be just infinite. And what I add in addition, so this is very classic in any transportation network, what I add what's specific to shipping is that you have a cost of nodes. That is to say, when you go to a port, you have to pay a port fee. So if you want to go from I to J, well, maybe if you're unlucky, there is no direct connection. So you will need to go through intermediate ports. Just like when you make an itinerary to go from one place to another by bus or by metro. And so the cost you will pay, since everything is iceberg, you will pay port fees in port I, then the cost of going to first intermediate port K1, and so on and so forth. But there are actually multiple routes that allow you to go from I to J. You could take another itinerary. And so this will lead to a very standard trade gravity equation. It's just that agents, they won't only choose from which location they want to source their good, but also which routes they want to take. And so I will have a gravity equation, so about traffic between, trade flows between I and J, depending on the transportation cost, origin and destination terms. But it's just that this term, usually it's like given as trade cost between two places. Here, it's going to depend on the whole set of possible routes between the two places. That's going to depend on all the links and all the nodes in the network, depending on through which intermediate ports you go. I can also derive traffic gravity equation. So trade flows, it's what's produced in a place, consumed in a place. Traffic is just what's going through this link, but maybe it's coming from another origin going to another destination. And I can, most importantly, compute nodes gravity. So that's to say, compute all the goods that go through one port, but maybe just like using this port as an intermediate port. And so what I will do is that usually in transportation literature, the cost of going through a link, it depends on how much traffic you have on this link, like when you have traffic jam on a road. Here in ports, for shipping, it's not so much accurate to have congestion on the links because it's just basically the sea, but on ports, you have congestion. So I will assume that the cost of a link is completely exogenous, but I will make the costs of going through a port depend on how much traffic you have in this port. So I'm relying on a Brancaccio-Calopsidi. I'm saying that the cost of being in a port depends on how much time you spend in this port, and how much time you spend in a port, it depends on how many other ships you have in the port divided by the port capacity, like how many cranes you have to unload and reload the ships. And this port capacity can be affected by weather. And I allow for the effect of weather on port capacity to be heterogeneous depending on port capacity. I just allow for now for being heterogeneous depending on climate to allow for some possible climate adaptation. I've not shown, but I have in register. So this gives me two parameters that are very important. The cost of a port is going to depend on weather with this mu parameter and on traffic in the ports with this lambda parameter. So I rely on the shipping data I've shown you to estimate the structural parameters. I will skip this. So I just derive an estimation equation from the model. I need to instrument for traffic. I build measures of weather, and I get elasticities of ports to weather conditions and to traffic. So I just keep in the interest of time, but I use these elasticities to take my model to the data. So together with other structural parameters I take from the literature. So to estimate counterfactual, I just focus on the biggest 400 ports in 2019. and I need to take the model to the data. I use outcome and expenditure data and the country level that I allocate to ports. And I'm relying on traffic data that I just take from the shipping data. I just count basically the number of ships going from one port to another, weighted by the capacity. What's interesting is that to take this trade model to the data, I'm not using trade data. I'm not relying on trade flows, but from the model, I can predict what trade flows should be based on traffic data using the model, the structure of the model. So this allows me to test the model validity by comparing the predicted trade flows I have from my model to other trade flows data that I'm not using. And it says that the model fits. I can just show. It fits. And so the treatment effect I'm going to be interested in is looking at what happens when weather wave height changes in a different port location. So to look at this treatment effect, I use this very classic trick in trade, which is to translate the model in terms of exact hat algebra, so to know what the effects of the deviation from the observed equilibrium. And I'm going to show you the results of two counterfactual exercises. The first one is just a proof of concept. So it's kind of a third experiment. I'm going to shock the weather in only one port. And I'm going to see how it spillovers to other ports and how other places can be affected. And then I'm going to look at a global shock. I will look for a specific year. I will compute all the days with extreme wave heights at all places. And then I will cancel those out to see what have been the contribution of these extreme weather events to loss in traffic and real economic output. So first, I'm just shocking the port of Jakarta, so which is here. What you can see is the decrease or increase in traffic in all maritime links. So all the links that are either going to Jakarta or leaving from Jakarta, they have decreasing traffic. And links that are connected to links that are going to Jakarta have slightly less decreasing traffic. And in terms of ports traffic, so Jakarta, of course, is the most impacted port. It has the most decreasing traffic, but actually the ports around also have decreasing traffic because they used to have a lot of trade with Jakarta. Now Jakarta is down, so they have less traffic. And ports further away, they have very small effects, but some of them can have slightly increasing traffic because of diversion of traffic flows.
I'm sorry, I'm a little confused. This is the effect of a permanent increase in wave height or the effect of a one-time shock?
No, I'm thinking of this as permanent or over years.
Got it. So, okay, that was my question. So you're assuming there could be just changing the overall port capacity or whatever.
Yes, exactly. That's why I say it's a kind of third experiment, because it's only happened in Jakarta and nowhere else. So this is just to show you the mechanism that only when I shock just Jakarta, ports around are also impacted because of this network mechanism.
Is there forecasting of how wave height will change over time with climate change?
Yes, so I'm working with, so yes, there is, climate scientists are working on that. I'm trying to get just output of the prediction models to have predictions. Don't have it yet, but that's
it looks like it's sort of going up.
Yes. So I can already see I have data from 1940. I can see it's increasing. It's mostly the days where wave heights is extreme that are going up. It's more frequent to have very high wave heights.
I'm also a little confused about the time series, the thought experiment, in the following sense. So imagine it's wavy I can imagine if it was wavy all year round in Jakarta, that lowers the permanent capacity of the Jakarta port. But if it's just wavy on a couple, couple wavy days.
Yes.
Do you actually, do your estimates imply that on net there's less shipping of stuff from, what happens to all the stuff in the port? Eventually it's gonna get all shipped out. So I'm not.
So what happens to all the
adaptation over time?
Yeah, so what I'm considering is that, I don't know, the firms which want to export, they will decide, okay, this year, are we going through the port of Jakarta? No, because we know that the port of Jakarta is going to be down half of the year because it's going to have very high wave height. So we're not going to go to Jakarta, we're rather going to go through Singapore.
So what's that's going to depend on some elasticity of substitution on the sort of shipper side. Where does that come from?
So here, I'm not really considering a shipping sector.
There's some elasticity of substitution behind that.
Yes, yes.
If I've got a factory in Jakarta, I got to use the port in Jakarta, so I'm not elastic. But if I'm in the middle of Java, So where does elasticity come from?
It's just, I don't have the exact formula here. I'm just assuming that there is an elasticity of situation between origins you can source from and different routes you can take, which is the same elasticity.
So it just.
Yeah. Yeah, it just comes from this elasticity, which is fixed and the same everywhere. Yeah.
Could you make the same map for a day of high waves? Because you're thinking about congestion, and so this idea of a year-long waves is actually not capturing the logic of congestion, where you can go in today, but in 2 days it's fine.
Yes.
So if you can make the map on a one day, it would be easier. We don't need to
Yeah, it's true that
brain
yeah, it's true here. It's
experiment.
Yeah, like the short run elasticity is very different than the long run.
Yes, exactly. Yeah, no, it's true. So here okay, I need to work more on this short run versus long run. Here I'm more thinking about a long run kind of factor. So other exercise I can do is just, so this is the distribution of share of days with extreme wave heights of a port in the world. I just do a counterfactual where I assume that no ports ever experienced extreme wave height, and I look at how it affects. So here, port real outcome. So you can see there is some spatial correlation, like ports in South Africa almost always experience extreme wave height. It's not so much the case in Northern Europe. In the distribution of port real outcome, there is much more spatial heterogeneity at the local level, because it's actually not exactly correlated with your own weather shock. It really depends on your position in the network. The final thing I want to talk about in the 3 minutes I have left is going towards a flexible network. Because the shipping network, as any kind of transportation network, is very, very sparse. There are lots of zero in the adjacency matrix. But what's very different with shipping as opposed to transportation on land is that it's actually fairly easy to create a new link or to remove a link, because you don't have fixed costs. You don't need to build infrastructures to connect to places. You just have to decide that you have a ship that will go between the two. And actually, I can find in the shipping data that links are very often opened and closed. Why is this important to take into account for this project? I find for now limited empirical evidence that indeed you have links creation or deletion as a reaction of weather shocks in ports. But so first, we don't yet see some ports being completely underwater, but this is going to happen. And even from a normative point of view, actually, we can see this as a way of the network adapting to its shock, to become more efficient after a shock. So I will just try to convince you that actually this flexibility of the network is a sort of adaptation mechanism that can help to mitigate the shock. So the proof of concept I do, this is the exercise I've been conducting so far. I just shock the weather in the port of Jakarta, and I look at what's happening because of this, not allowing the network to change. It stays exactly the same. And then I will allow for closure and opening of some links. I will explain how. So I will allow the network to adapt in a very ad hoc fashion, and then I will compute what's happening after this. And if I compare those two treatment effects, it will tell me whether link adaptation can be a way to mitigate the impacts of a shock happening in a port. So to study link adaptation, I just rely on what happened during COVID. During COVID, some ships, when there was a port being down because of lockdown, they would omit this port call. That is to say, so the ships were supposed to go through a series of ports. One was down, they would just go directly from the previous one to the next one. So in terms of network, it means there was a link that was open between this port and this port, and those two links were closed. So here I shock the port of Jakarta, and I identify 23 services that go through Jakarta, and for each one of them successively, I just omit Jakarta port calls, and so open a new link and close to ones, and look at what it gives on global effects. And so what I see is that, so with no link reaction, so I just shock the port of Jakarta, it has a negative effect on global real outcome. When I allow for some links to adapt, in some cases, the global effect is still going to be negated. In some cases, it's going to mitigate completely the effects. In some cases, it's even going to lead to a more optimal network. And it's also going to redistribute the local effects. So it means that this network adaptation can act as a sort of mitigation tool to alleviate the effects of Porsches. So this is what I'm trying to work on, this network dynamics, but I'm trying to work on modeling it more properly, how the network should evolve. So I'm trying to have a model of optimal network adaptation, which I'm working on, and all ideas are much welcome. Thank you very much.
Okay, thank you, everyone. Thank you for staying on till the bitter end. It's great to see the room and it's still relatively full. Just to kind of say a couple of things, words of thanks. First of all, it's kind of amazing that different, everybody knows like there's different levels of the economics department. IGC on the top, stickers, and all of those have been involved in organizing that. And I think it sort of shows how environmental is infiltrating many different fields of economics, and then more widely in the school, the geography and environment department grabbed